Welcome to the new section of shell scripting basics. That's where we actually will learn what really a shell scripting is, what are its basics, like, starting from ABC or 1, 2, 3. So that's where we're going to start. So let's see what exactly are we going to cover in this entire section. So we will start with kernel, what exactly kernel is and how does it interact with the shell. And is there a kernel in operating system and how does it interact with your hardware and how does it interact with your shell and your operating system? What exactly shell is, of course, this is the main thing we wanted to know. How the shell scripting works. There are so many types of shells. There are corn shell, there are bash, there are C shell, and so many that I will cover in this lesson. Then we will have starting a shell. How are you going to start a shell? If you are logged into your Linux machine and by default you have a bash shell and you want to switch to a different shell, how do you do that? Then we'll cover how you could run a shell script. So you have created a script. Now, how do you run it? So this is a few things, very basic ones that you should really know. And this is like a fundamental things that you should understand and put it somewhere, deep in your head that outside of these are like actual guidelines that you have to follow in order to run a perfect shell script. So you would know if there is an error message or if there's a problem when you're running a shell script, why did it happen? This section will explain you if you really go through it. Linux kernel. Do you know there is a kernel in every Linux distribution or Unix distribution? What exactly a kernel is? It actually interfaces between your hardware and your software. So let's look at this diagram. Here you will see you have at the bottom is the hardware. And what are those hardware? Hardware is like CPU, memory, hard disk, and any outside hardware peripheral devices. Then you have kernel. A kernel is a program that is stored inside of your operating system. It's like a program, a command that keeps on running. And what it does is it takes the commands from shell. And shell, what is a shell? Shell is anything like a GUI that we have in Windows or a GUI in Linux. Or if you don't have GUI in Linux, we have terminal that runs bash shell or C shell, which we'll cover later on. So when we are in that bash or C shell terminal environment, we execute commands. The commands are being forwarded to kernel, and it's kernel's responsibility to talk to the hardware that's inside of your computer. And then on top of that, you have a browser, send mail, all the applications that we run like calculator, calendar, office, or any Linux related applications. And of course, on top of that are the users, and that is you. So shell and kernel together, that software built together in one package, and that is called operating system. And that operating system is any operating system like Linux, Unix, Mac, or Windows. Every operating system has that little program that actually talks to your hardware. And anything that is a shell, which is written in C programming language as well, that shell or those applications are actually the software. So this is what the real kernel means, and we really need a kernel in any operating system to talk to our hardware. Shell. What is a shell? In this lesson, we'll cover about the shell, how the shell works, and how you can run commands within the shell or how the environment is set up in a shell. So what exactly is a shell? Shell is like a container, like you have like a Tupperware in your home or any kind of containers that holds your environment, your information inside of it. It's interfaces between users and kernels or operating systems. So you have built an operating system, and then it is provided a platform you to execute commands. Again, Windows is one of the platform in Windows operating system. When you start up a GUI, you execute commands by double-clicking on a program. So that GUI interface is your shell. In Linux, when you don't have a GUI, you are given a terminal shell or CLI command. That is your shell. To find your shell, you could run a command like echo $, and 0 that will tell you which shell you are in. And you could also get a listing of all your shells in your Linux distribution by running the command cat etc shells. Your shell is also inside of etc password that is defined inside of the file. In Windows, GUI is a shell. In Linux, KDE GUI is a shell. In Linux, H, which is shell, bash, etc. All these are the shell that is provided to a user. Again, we're looking at this diagram again, and we are second from the top. You'll see the application that talks to the shell, and then shell talks to kernel, and kernel is the one that is telling hardware what to do. Let's look at our Linux machine, and we'll see how we could find our shell. We'll open up a terminal real quick. And when you do echo $0, it tells you are in bash. So you could look at the available shell that is installed in your distribution by doing cat etc shells, and it tells you all the shells that are available. And when you look at the etc password, cat etc password, and you'll see in my username, which is right here, it tells the shell is all the way at the end that I have a defined shell, which is bin bash. I could change that shell if I want to a different shell, but I try to keep it consistent with other users. So that's what the shell does, and we'll cover in the later lessons how we could talk to shell to create scripts and other things to automate our tasks. So now let's talk about what is a shell script. So put all your instruction in a shell or in a container and just run it. So if I have to explain it through a diagram, let's put it this way. This is a shell, right? Like a shell. So you actually putting all those things, all those instructions, like do this, do that, or else do that, etc. Everything, you're putting that together in a shell and then telling shell, run this set of instructions, and of course run them in a sequence. By default, the shell runs all the instructions in sequence. Now, if you notice, you go to Windows and you want to copy a file from one folder to another. You right click to it or Control C to it, and then you go to another window and then you paste it. Now, how does it work? How does Windows knows that I have been given instructions to copy it and paste it? Because when you right click, it gives you the option to copy. And when you go to another window, it gives you the instruction to paste. That is the function of a shell. The shell is a copy, instructions to copy. A shell is instruction to paste. So just like that, any of the commands or any of those functions that you run in Windows, they are all created within a shell, within a commands. You don't see those commands. In fact, if you wanted to really run in Windows, you could just go to open up the DOS prompt, and you could actually run those commands, the copy command to copy file from another. But of course, Microsoft had made your life a lot easier to run all those commands through graphical interface, which is click, click, click. Now in Linux, you don't have that luxury. And that's why also Linux is different, is because it's not GUI based kind of operating system. It's a command line, so you could run your function a lot faster. So you don't have to deal with GUI and GUI using up your CPU and memory. So what do? You run a copy command, or you run move command, or all those commands that you run. Those are, what are those? Those are actual scripts. Those are shell scripts. And who have written those? The developers. Those people who have done development, those people who do C++ or C development, they create those scripts. So you could use those scripts, leverage on those scripts, and create your own shell scripts. So that's how the shell scripting works. Now let's talk about the different type of Linux shells that are available to us in our Linux environment. When we have a Linux machine running, what are the different shells that we could take advantage of? The first one is GNOME. If you don't know what GNOME is, actually GNOME is like a graphical environment that is in Linux. Now you must be thinking, isn't Linux command line interface? It is most of the time, but there are people who actually install Linux with the GUI. And the GUI, while you are installing the GUI or while you are going through the installation, you have the option to install GUI as well. And the two options that you have for GUI is GNOME, and the second one is KDE. Both of these are the desktop GUI environment, and they are the shells. So you log into those environment, you are in the shell, and then you run command. How do you execute commands? You execute through your keyboard and through your mouse. You click, 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 drag, drop here and there. That's how they interact with the operating system, through that shell. Now, of course, let's go back to our main topic, which is the command line shells. Now, the command line shells, the main one is shell, is just SH shell. Of course, we are now talking about when we do not have a GUI. We are in a command line, and now we need to use a shell. When user logs in, a user is given a shell, a platform to work. That platform is assigned to that user when the user account is created. So as I mentioned before, if you go to etc password, you will see your shell. So if you are, let's suppose, are given bash shell by default and you want to switch to sh, you could do that by going to a different shell. How can you do that? We'll cover that later. So shell, this just sh, is a Bourne shell called or sh, is one of the original Linux shells. It is developed by Unix computers by Stephen Bourne. His name was actually Bourne. That's why they picked the name Bourne shell. He worked for AT&T Bell Labs in 1977. Those are one of the oldest days when actually Linux was or Unix was being developed. Its long history of use of means many software developers are familiar with it. It offers features such as input and output redirection, shell scripting with string, integer variables, and condition testing and looping, and so many other things, which of course, don't worry about it. All those, the heavy words, we'll cover them later in the lessons. Then we have bash. Bash, what is it? Now, the popularity of shell, which was sh, was so much that it actually motivated programmers who actually developed the original shell that was compatible with it. But with the several enhancement, they added so many things to it. Linux systems still offer shell scripts. They came up with bash. So they still have shell, but now they came up bash. Now what bash means? It means born again shell. So the shell still exists. Don't worry. Don't think that shell sh is gone. Now the newer shell is available, which is called Bourne Again shell. And in our entire course, we will be using Bourne Again shell. Why? Because it has a lot of enhanced features and it is very user-friendly. So many features or variables that we could use in that shell. Then what are the other shells? There is C shell and TC shell. Developers have written large part of Linux operating systems in C and C++ languages, right? You know that. Using C syntax as a model, Bill Joy, who was at Berkeley University, developed the C shell in, I believe, 1977 or 78. Then Ken Greer, I think that was his last name, working at Mellon University, took C shell concept as a step forward. And when it took a step forward, what did he do? He came up with a newer shell, which was TC shell. And based on your system directory structure and files, T shell does not run bash scripts. So if you are in a T shell and you want to run bash, it's not going to run it. Anyway, most of the people don't use C shell and T shells unless you really are proficient in C and C++ programming language. So my advice to you, you could stay away from it if you are a beginner, not to worry about these. Then the last one we have is Korn shell or K shell. David Korn. Okay, see, that's the name. See, that's why the people came up with these shells, because they associated their name with it. So the person who came up with the Korn shell, his name was David Korn. He developed this Korn shell, and it was about the time like TC shell was introduced. So Korn shell is compatible with shell and bash shell as well. Now Korn shell improves on Bourne shell by adding floating point arithmetic, job control, and so many other things. I don't want to confuse you right now. In Unix environment, most of the time Korn shell is used in Solaris, whereas in Linux environment, most of the time a bash shell is used. As I mentioned again, if you need to know the list of shells that you have installed in your system, all you have to do is log into your Linux machine and type cat sc shells, and you will see all the list of shells. So this is what I wanted to cover, and I want you to be aware these are the different type of shells. If you are creating a shell script and you need to get help on creating a shell script, let's say if you Google it, maybe you will find some of the information or some of the scripting syntax in bash and some of them in Korn shell. So you have to be very careful. They're probably not going to work on one another. That's why you need to know the difference of different shells. Okay, now we know a lot about what are the different type of shells. Now, how do we start a shell? How do we get into different shells? Well, it's simple as is. Simply type the shell name. Meaning, if you are in Bourne shell and you want to get into just shell or C shell, just type SH or just type C shell. So without explaining you more in detail, I'll log in straight to my Linux machine and I'll show you how you could switch from one shell to another. Okay, so I have this Linux machine and you notice that I have this GUI running in Linux. Inside the GUI, I have this terminal. So all the commands that I run from the terminal is actually a shell. And that shell is, how do you find a shell? You do echo $0. And it tells you my shell is bash. Now, if I don't want it to use this command line, and you see in the back, I have this directory called home, and I have this trash can. So if I wanted to view the contents of home, what I do, I double click. So this environment right here, as you see, this environment is GNOME environment. And remember I told you GNOME is also a type of shell. So this is another shell right here, and this is command line inside is another shell. So if I wanted to open this folder, I am telling GNOME, which is a desktop GUI, to open up that folder. So double click, and it will open up the contents of that directory, and these are all the directories I have. This is the file I have of all the directory. If I want to go into another directory, another file, or if I wanted to open up this file, I'll double click, and the GNOME shell is interacting with the kernel and operating system and telling it to open it up. Now, what if I do not have this GUI environment, right? So not everyone is a Windows, not everyone wanted to get into Windows, they wanted to get in the command line. So what do? So if you want to view the content of my home directory, I'm sure you know the output. I'm sure you know the output of pwd, which means home I absolve. So now if I wanted to view the content of my directory, I do ls-l, and you see here is a list of all the directories that I have in my home directory. So I did the same thing as I was doing here by double clicking it, but right now I use the command ls. So when I use the command ls, I actually am telling my bash shell to do this ls command for me. So let's do clear, and it will clear up my terminal. Now, if you wanted to see what other shell that you could change to, you could just simply type sh. When you hit sh, you see your shell prompt changes. And you could also verify it by running echo $0, and you'll see it is shell. Now, if you wanted to exit out of the shell to go back to your bash, you type exit. And if you want to go to, let's say, C shell, so you just type C shell, and you are in C shell. To confirm you are in C shell, you do echo $0 with C shell. You want to get out, what do you get? How do? You do exit. So that's how you get out. Now, what other shells that we learned? Let's say if you wanted to start a corn shell, SKSH, hit enter. It says bash corn shell command not found. It's a similar command as you could use, which is C shell. No, I want to use corn shell. Why? I cannot get into corn shell. Maybe because I do not have corn shell installed in my computer. And how do I verify it? Simply do cat shells. Okay, tell me, do you see corn shell in there? No, right? That's why I was not able to start that corn shell shell actually. So anyway, so that's how you could switch around shells, start a new shell. Again, this is if you want to get into a different shell environment. Now, how does it relate to shell scripting? The shell scripting that you want to learn, right? That's what you're probably thinking. Well, if you are creating a shell script, let's say in corn shell, and as you see right here, I don't have corn shell, that script is not going to run. So you need to know your environment beforehand, before you spend tons of number of hours and then realize, oh boy, I don't even have a corn shell. And you're not even allowed to install or download a corn shell. Anyway, so that's about changing the shells. One of the basic things that we should know is how to run a shell script. So when you create it, there are different ways you could run it. You could run it through absolute path, or there's another one that's called relative path. So absolute path is if, let's suppose, if you are standing right at the first step of a stairs, and you have to pick up something on the very last stair on the top, you have to actually either shoot from the first stair all the way to the last stair on top and grab that thing that you're trying to grab. Or there's another way is relative path. The relative path is that you actually walk up to the stair and then grab that thing that you wanted to grab. It's the same way absolute path and relative path works. If you do not know what exactly absolute path and relative paths are, I would recommend you that you should try to look it up online and see what they are and how they work. And you'll find tons of article there, and make sure you type absolute path in Linux or absolute path in relative path in Linux as well. So the way it works is I have my Linux machine up. Let me log into my Linux machine. So I have my script right here. It's called XYZ-script. If you notice, I am in my /home /iofsolve and /script directory. I created a directory called scripts in my home directory, and I create all my scripts in that directory. So if I am already in that directory, I could run that script. Or if I'm not in my directory, let's say if I just do cd, and which directory I'm in /root. So the script that I want to run, it's just a test script that I created earlier. Let's say if you type that script name xyz-script, and when you hit enter, you'll see it says bash, the script name, command not found. Why? Because the Linux operating system is trying to find that script in /root directory. And I do not have that script in /root directory. So I would have to specify the absolute path to run the script. And the absolute path would be just the same way as if you are standing at the bottom of the stairs and then you have to fetch something from the top of the stairs, then you actually, through some kind of means or like a stick or something, then you could grab it. So the same way you could specify the entire path, which is /home, my user directory, scripts, and now the name of the script. Now, when I run the script, I'll hit enter, and you'll see it's just a script that is actually echo out or print hello world on the screen. How does this script create it? I will cover that in later lectures, but just to focus, this is how you need to run a script using absolute path. Now, what if you are in a relative path, which is that you are already in home, iofsolve, and scripts directory. See, you cd into that directory, you do pwd, and you'll see the path is the complete path now. Now, the script name is, again, when you do ls-ltr, I have that script, xyz script. Now, when you run the script now, script, and hit enter, it still cannot find it. Why? Because when you are inside of a directory, you will always have to specify that you want to run that script within this same directory. And that is the relative path. And to do that, you have to specify dot slash and then the name of the script. You could hit tab, it will autocomplete. So now you hit enter and you'll see it ran. So keep that in mind. There are two ways you could run the script, one through absolute path and one through the relative path. If you are, let's say, in /home directory, and now you want to run the script, you could still specify the entire path, /home, starting my user directory, or you could just simply start from the directory you are in. So you are in iofsolve, from this home onward, iofsolve, scripts, and the script name. And hit enter, and you see it works here too. Because you have to let the operating system know where your script exactly is located. So that's the basic about the scripting, how you run it. So please remember these two main points about running the script. Welcome to section 4 of scripting standards. What are the basic standards that you need to remember? Some of them that we will cover in this entire section is how you need to name your script. What are the naming convention that you should use? Okay, hey, I know what naming convention to use. I don't have to worry about it. I would remember everything that I would know. Okay, if you do know that, be my guest. Skip ahead to this lesson that I will cover. But trust me, down the road, if you have created a script, a year from the time you created a script, you will forget it if you do not have in a proper naming convention and if you do not have in a proper directory structure. So we'll cover about the naming convention. We'll cover how the script permission works. So when you create a file, by default, it does not assign the executable permission. If you want to read a file, it has to have a read permission. If you want to execute it, it has to have the executable permission. We'll cover that in that lesson. Then shell script format, how you should write a shell script, what are the formats, standards that you should follow. Followed by the sequence of the script execution. When you want to execute certain things inside of your script, you want to execute A, B, C, you need to know how they are executed. And the last one is the variables and how to create them. Variables is just like aliases. We'll cover that in this section as well. So these are the basic things. Again, if you know all that, be my guest. You could fast forward, but I would highly recommend you to please go over it. And so this way you will have the right standard in your memory, and you will know exactly when you're starting it from the get-go, you know how to start from the right path. Okay, script naming convention. What are the names that we should use when you create a script? First, First of all, I will tell you that every time you need to create scripts in your Linux environment, always create a directory. Call it scripts or my scripts, or if it's a project-based scripts, type it like HTTP directory or payroll directory where you're going to create your scripts. So directory structure is very important, so you don't create scripts all over the place. So follow the standard, create your directory, whichever folder that you pick that you want to create your directory in. That is fine. Then script name. The script name should identify the function. If you are going to get into a job, or if your job functionality revolves around creating a lot of scripts, doing a lot of automation, then it's best that you name it that matches its purpose. If your script is going to check the date, check today's date, and you are naming it XYZ, then again, few months from the day you create, you're going to forget what XYZ is for. So it's good that you name it like date or something, my date script or something like that. And the script should end with a shell. So if you are using bash shell, then I would say write the name of this the name of the script followed by .bash. Now this rule should only be used, which I usually follow this rule when I am creating multiple shell scripts. Meaning, if you are creating shell script in Corn shell, C shell, Perl, or Bash, then you need to have the extension at the end, which is .sh.corn shell. So these are the three basic standards that you should have. Let me log into my Linux machine, and I will show you exactly what I wanted to cover here. So if you go into your Linux machine and you log into your home directory, let's say my home directory is /home/iAbsol. In my home directory, you'll notice I have a directory called scripts. So this is what I mean. So every time you create a script, you need to create a directory first. So this way you go into your script directory. So this way you don't have to scroll through and find out where your scripts are. So in my home directory, you'll see I have a very few files and directories. So it's very easy for me to find out because it's a test environment. But maybe you're working in an environment where you create thousands of directories. So that's why it's important you create a directory called scripts. Once you create the script directory, then you could just go in and you'll see right here in my home directory, I have a script called xyz-script. Now, as I mentioned, xyz-script, it's not a really good name. You cannot tell what exactly it does. So if I run the script, you'll see it actually spits out hello world on the screen. So that's exactly what it does. So if I wanted to associate that script with a name, then I should do is xyz script, move it. Move is the command to change a name of a file. I'm sure you know that. And I will say hello world or W or complete name. That's fine. And I will run that command, and you'll see now my script name has changed to hello world. Now, if I am using multiple shells, then I should label it as move hello world bash. This way, if I'm creating multiple scripts in Corn shell or C shell, then I would know that this script was created in bash. So this is basically a very quick lesson I wanted to cover. Remember that this is the standard that you should follow. Also, if you are doing that type of work in your environment and you decided to leave your job and move on to another career, the person who's going to come and replace you, that person, I'm telling you, is going to be so happy, or even your manager is going to be so happy that you are so organized that all the script that you created while you stayed with the company are all organized and where to find them. Script file permissions. Now, this is not just theoretical or concept or standard that I'm trying to explain it to you. This is actually mandatory. You need to have the right permission to execute a script and to have a proper permissions on the script file itself. So all scripts to be executed should have a proper executable file permissions, and those are, for example, if you see here, it's read, write, and X is for executable, meaning the root, the person who created the script can execute it. Then read-X, meaning the group who belongs to the user, or the user belongs to a group, has the right to read and execute the script. And the last one are the other people who do not belong to your group, or they are not you. They could also execute that script and read it. But of course, they cannot write it because you don't see that W and W in the middle of group and others. So every time you create a script, you need to assign the executable permission. Okay, so now you're probably thinking, hey, when I create a script, why can't it
gets assigned by default executable permission? Good question. But the problem is that whenever you create a script in Linux, or whenever you create a file, I should say, in Linux, by default, it does not assign executable permissions because it doesn't want you to make a mistake and execute something by mistake and corrupt your file system. That's why it doesn't give the executable permissions, so you have to assign them yourself. Okay, now I created a script. Now, how do you change the permissions? Simply, the command to change the permission is chmod a plus x and the name of the script. A stands for all. Everybody should have executable permission of the script. I prefer letters as A or G or O for user group and others. There are other people, or you probably are familiar with the digits as well, like 65567, something like that, which I'm not too much familiar. I try to follow something that I am very familiar with, and I would like to teach you something that I know. Anyway, if you are comfortable with your own way of assigning permission, you be my guest. You feel free to use that. Now let's see, if I log into my machine and I create a script, then how can we change permission? So let's see, where is my Linux machine? My Linux machine is right here. And I am in my /home/iofsol/script directory. I wanted to create a script, and there are few ways you could create a file. First, you always create a file. You could touch it, you could VI it, and you could echo it and output to a file. The different ways, whichever way you want to start creating a script. So first thing I will use, a very basic, is touch. And the name of the script, let's say script name is Apache script. Hit enter. Now when I do ls-ltr, you'll notice the script that I had before, hello world, has the executable permission, right? This is the third bit you see right here. The new script that I created, which is Apache script, does not have the executable permission. So in order for you to run that script, you need to assign executable permission. To assign the permission, you have to run the command chmod. As I said, I'll use for all. Everybody should have executable. Plus X for executable, the name of the script. Hit enter. Now do ls-ltr. You will see the name of the script and its correct permission. This is how you assign permission. Very easy to do that. If you're already in Linux, you've been using Linux, you're probably like, oh, I know that. Perfect. If you know that, let's move on. Script format. Having a proper format inside of a script is very important. Why is that? Because I'm going to bring back the same analogy. You create a script, it's a very long script, and a few months pass by, and now you need to modify the script or troubleshoot something in the script. You have you have written down the script, but it's all over the place. The variables is up, your comments are nowhere to be found, the description is nowhere, the commands are left and right, there's no indentation, nothing. So there should be a proper format that should be followed so that someone can come in and take a look at your script and says, wow, that's a great job. Whoever did that, so easy to read and so easy to understand. And what are those formats? One is, first and foremost, is define shell. This is something that you have to define. You could say it as a part of format or mandatory. You have to do that. You have to define a shell. When you create a first script, you have to let your operating system know, run that script as bash script. If you're doing a corn shell, you'll have to specify #bin/corn shell. Anyway, when we write our first script, we'll cover that as well. Then comments. Right after defining the shell, you have to put the comments. And those comments always starts with $. And the reason I am telling you that you should include comments is because comments should tell what your script does. When your script was written, who it was written by, was it there any modification, anything that you wanted to include that a user or someone else reading your script can understand what this script is about, please add that to your comments. Then define variables. Variables, what those variables are, we'll cover that. Not to worry about it, but just to let you know quickly, the variables is just like an alias. If you have a long command or if you have a bunch of emails, what people do is they give it a letter equals the whole big command that becomes their variable. So define your variable at the top after comments. Then you run the commands, whatever the commands that you want your script to execute. you need to specify those commands. Or if you do not have commands, or if you have any statement scripts, that's where you put your statement scripts. Those statement scripts are if, then, while, for loop, or so on. Now, when you have statements defined, you should start if the line where you're going to put an if, hit tab, because this way it will show that your if statement is starting from this point on. There is nothing that the script will translate your tab into something else. You could use spaces, you could use tabs, anything that you want, but try to make your script formatted in a way that if someone or even you read it after a year or 2 years, you'll say, ah, this is what I did. It's so easy to read. So let me log into my Linux machine again, and I'll tell you exactly how you should format your script. Okay, this is my Linux machine. I'm already in my directory. Perfect. I created a script earlier, or a file earlier called Apache script. I'm going to take that same script and I will format it the way I have just discussed it. So to do that, I have to now do a VI on that script. And I am sure you guys know how to use a VI. Some of you are familiar with Vim, which is probably an enhanced version of VI. I like to use a VI. It's kind of old school, but the good thing is that it's available in pretty much all the Unix or Linux flavors. So I could never learn something new and not utilize it on an older version, because I use VI in many systems like Solaris, AIX systems, and sometimes Vim is not available. So VI is something that you'll find anywhere, whichever the system you log in. So anyway, I'm going to use VI to edit this file, which will eventually become a script. So you hit enter. Now the first thing, as I said, you have to define a variable, which has been bash. So if you look at the back, you'll see the first thing is defining your shell. I want to run this script as bash script. Perfect. Now the next thing, I said to add a comment. Okay, always add a comment. I usually add a comment is like purpose testing script format date. Put any date. Let's say August 2020. Modification. If you have done any modification to the script, put down the date of that modification. So 02/08. So last modification, of course, since you're creating it the first time, I'll put 20 again. Okay. Then anything that you wanted to add, please go ahead, do so. So if I just put in blah, 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 whatever, it's just a comment. It has no effect on your script. Okay, perfect. I understand, Imran, but how come the first line that you have is /bin/bash has a comment in front of it? Isn't it will be considered as a comment as well? Awesome question. Trust me, I had the same question. But let me tell you this. It's just how it is. Sometimes, it is how it is. So the Linux will understand this as actually a shell script. And it always starts with pound and hash. Why? I honestly don't know. If you really want to know why, you could ask someone else who really know inside out when they came up with the writing scripts. Or you could, I'm sure, go online and find out why you have to define with hash. But anyway, put that in the back of your head. You have to remember this no matter what. Okay, so moving on. Then you define, next thing is variable. Variable is something like every time I want to echo something, I just want to say A and then echo. So let's say in my case, I wanted to have single quote, Imran Afzal. Or, and you know what? I will say, my name is Imran Afzal. This is how you define your variable. And then you could just do echo $A. Then it is going, when you say echo $A, by the way, this is just a scripting language I already started teaching you, but that's okay. You need to understand the format. So variable I have defined here that every time this command will run, it is going to call upon this variable. So why didn't I put that whole thing here? I can, of course. But what if you are working in an environment that requires a huge line and does huge things? Then it's better that you put those variables in there. Then, of course, then you put command. Let's say you want to run a date. You want to run a command df-h or so on. Then the last one I included as statements. If you are including statements in your script, please do not start from if, let's say, $a equal let's say file or whatever. Do not start like that. Always put tab like this. So if something is equal to that file, enter, and then tab again. Then echo this, else, echo that, and then phi to close the statement. You see how it is? That entire if statement came to be on the right-hand side. So you know that this is the statements that I want to run, and they are indented to the right side. What are those statement scripts? I never seen that. Don't worry about it. I'm going to cover that in my next lessons. The purpose of this lesson is just that you know that why would I follow this format on the following lessons. That's why I wanted to cover that right now so you would know. This is the best way to put your scripts together, and it would be so easier to remember when you come back to it. Sequence of the script. When you are defining commands inside of a script, if you want to run command A, command B, and you want the command B to run first, then you should put command B first. That's how the script works. It goes through the sequence and starts from the beginning and it goes to the end. So if you have command 1, 2, 3, and so on, it will run the command 1, followed by 2, followed by 3. For example, if you wanted to run ls command first, put ls command first in your script, followed by date and cal, which is calendar. These are a few example commands I just picked. So if you want to run date command, the first thing, then you should move that up before ls command. That's how the scripting works. Any script that you run, whether it's a Corn Shell, Perl, any kind of programming language that you know, it runs this way in a sequence. Something you should know. And if you are confused that, hey, I run if-else statement, but if works this way and it runs else that way, because those are the statement scripts. We will cover the statement scripts. Don't confuse yourself right now, but focus on this one. Script sequence, it always run 1, 2, 3 as they are sequential, in a sequential order. Hello everyone, and once again, welcome to the basic shell scripting section. Okay, so this is the section where actually we're going to get into creating shell scripts, the basic shell scripts, how we could create jobs, how we could run simple echo scripts, or how we could use input and output of our statements to work with the shell scripts. So what are we going to cover in this section? So let's take a quick look. First, we will start by creating our first script. Yes. So this is the fun part, guys. Okay, so first shell script. You probably have written many shell scripts as well. And the basic one, it might be like, like a ABC for you, but that's okay. We'll always start with ABC. So we'll learn how we could create our first script, how we could execute and permission and stuff like that. Then we'll create a second script where we will run basic tasks, like based on our regular commands, we will run our basic tasks, followed by the basic administration task. Administration tasks are those like if you are checking a disk space or memory, and how can we put that in a script that will do all that automated for us. Isn't that fun that you don't have to log in anymore and then run those tedious commands every day to check your system and see how it is doing? We will cover that in the lesson. Okay, then we'll cover the defining variables. You guys know already about the variables, right? How can we define variables in the script and actually use it? Input and output. When you run a script, it will ask you a question, and based on your answer, how it's going to respond. Those type of questions. Now, how does it work in a real life? Well, if you notice, when you run a script in Windows or even in Linux and you're installing a package or something, it will ask you a question, right? Do you want to go ahead and continue? You click Y and it says yes. Based on your input, it does certain functions. So that is about input output. Then we'll have condition statements. This is where it gets a little complicated, but don't worry, I am with you. That's why I'm starting with basic. It's just like as if you are, let's say, going to a war and you are in the military. The first thing they do is they actually train you. So this is the whole thing is about training. I wanted to start from scratch so you know everything inside out. Then we'll have some additional conditional statement for the case statement, and then for loop statement. Why do we need for loop statements? What are the advantages of it? Do while scripts, we'll also cover the do while scripts, and the last one is getting online help. Now, what does it mean, getting online help? Now let me tell you this, I'm not like I don't know every scripting commands. I don't know every scripting variables inside a script. So sometimes I also go online and find help. So I want you to also utilize that same technique to go online and look for specific scripts that can help you achieve your goal. So how can we get those online help? I'll explain it to you. So sit tight. Let's start with our creating first script. Hello world. Okay, yes, this is a basic script that most of the time that I've seen people write whenever they start learning scripting languages. So we are learning bash scripting languages, and the first script that we will write is to echo or to output on the screen that reads hello world. I remember when I was in college, the first script that was given to me by my teacher or by my professor was to write a script that would output or print on the screen that would read hello world. So anyway, I am going to do the same thing for you guys, that I want you to create the first script. If you know this, how to create a script, awesome. But start with me. Let's go with me. So we're going to start with creating the first script that will output hello world. So I have already my Linux machine session open, and I am logged in as myself. Now, as a practice, as I mentioned before, that always create your script in a specific directory, so it will be easier for you to remember where those scripts are. So let's do cd script. I have already created. You should have that too if you follow my earlier lessons. If not, then go ahead, run the command make dir followed by the script, and it will create a script directory. In that script, if you do ls-l, you're probably not going to have anything if you never had a script before here. If you do, then go ahead and delete the script. The first script that I'll delete is hello world. It says permission denied. Why is that? It is owned by me. It is owned by my group, and I could remove it by looking at this W. It has write permissions. Why can't I delete it? That's a good troubleshooting exercise as well, right? I know why I can't delete it. Because when I created the folder or directory called script, I was root. So let's go one step back, cd ... do ls-l, and you will see. Yeah, I was right. See, right here it says this directory is created by root. So anything under this directory will be protected by user root. Nobody could touch it or delete it. So the best thing I should do is to become root, go into my home directory, and I will simply remove that directory now. So this will start fresh. Okay, so now it's gone. Let's exit out of that root. Make sure you are yourself. Yes, we are logged in ourselves. Also, you could check by looking at the prompt, which tells you the name of the user logged in and the server name. So now we are in our home directory, and now we're going to create a directory called scripts. And we will put all our script from this point on to our folder called scripts. Now, make sure it is there. Yes, it's there. It's the end, and now it is owned by me. Now, you don't have to run all the scripts as root. The only time you would have to run scripts as root if the commands that you are adding inside of your scripts require root privileges. Yes, so you could run any command like pwdls or anything that do not require root permissions. If you are running other commands, let's say dmi decode or dmessage or df fdisk command, those are the type of commands that require root rights. So it's better that you run those commands, those scripts. You create those scripts as root. Anyway, so let's get into our scripts directory. And now you see we don't have any file or any directory in our scripts directory. So we will create our first script, and we'll call it hello world. And you could put .bash as well, but since we will be working primarily with bash shell, so we don't have to specify the extension. So just simply hit enter. Once you are in the VI mode, you specify the shell. So we want to run this script as bash. Good. Second thing, who is the author of the script? I will say it's myself. Perfect. Then again, a comment. Date. Script is created. Let's pick any date. So let's say if you're picking 08/20/2020. Okay. Then we'll put in a little description. And that will read, this script will output hello world on the screen. That's it. Simply that. Now, if there are any modification, so you could put a date modified, and then you could put the date. Since we are doing the first time, you could just put it the same date as we put a date created. Okay, so our shell is defined. Our comment is defined. Do we have to add anything? Nope. It's just a simple script. So I will go ahead and write the script that will print echo hello world. And that's it. Now, you could just do escape out of it and write quit, and your script is created. Now, verified, yes, the script is there, but you cannot run it. Why? Because it does not have executable permission right here. So in order to assign proper executable permission, you will have to run the command change mod all plus executable hello world. And by the way, I'm using tab that auto completes the file. And if the file does not exist, it will not autocomplete. As an example, let's say if I, instead of HELLO, I'll put HALL and hit tab. See, it's not going to work. So it has to have a correct spelling. Okay, so we have modified the permissions. Let's verify it. Yes, now it has the executable permission. And as if you see, as soon as we gave it executable permission, its color changed as well. Now, please remember, don't focus on the color. As I said earlier as well, that sometime maybe you probably creating a script in Solaris or in AIX or in any other Unix or Linux flavor that does not give you that color changing scheme, or that depends on the environment, the shell. So that's why just focus on that it is executable by looking at the executable permission. Okay, now perfect. Now let's run it. So again, you could run it through the whole path, which is absolute path, script directory, and hello world, and hit enter. And there you go. Your first script is created. Isn't that fun? You have just created your first script, which outputs on the screen hello world. Now what I'm going to do is I'm going to run the script as a relative path. So /hello world. There you go. It does the same thing, but it executes it with a relative path. Now, if you notice, there are no lines in between on top and bottom, so I wanted to make it more clear, more neat look. So what I will do is I'll modify the script, hello world, hit enter, and now I'm going to put one echo here and one echo here. So when I put these echoes inside, then it will actually generate an empty lines before hello world and after hello world. And date modified, again, I could just put it like, let's say if you're modifying it a day after the first time you create it, then you just put 21. Save the script, and now let's run it. Hello world. Nice. You see? Now it is giving the output that you want. Now, as an exercise, I would recommend you to go ahead and create a couple of scripts like that will output on the screen. Like, my name is Imran Afzal. I love to teach, and I am whatever that you wanted to add. Just output on it. Chop the lines, whichever the way you want it. This will give you some practice on how to create simple scripts. Basic task scripts. This is our second script that we will create together, and this will actually execute some basic tasks that are like based on some basic commands. So the task that we will define in our script is, the first one is pwd. That will print my working directory, ls, which will list all the files or directories in my current directory, who am I, it will print my username that I'm logged in with, date, the current date, the current calendar, and the last one, I want to create 3 files in my directory that I'm logged in. That files are A, B, C, and the command we will use to create them is touch. So it's just that simple, and that script will run sequentially. If you remember, it will do the first one is pwd, then ls, and then so on. So my machine is right here, and I am going to create my second script. Make sure I am logged in as myself, and which directory I'm in. I'm in scripts directory. Perfect. That's the directory I want it to be in. So I will go ahead and VI a new file, and the name of the file I will pick as like basic tasks. It's just that simple. Hit enter, define your shell, author. I'm going to keep making you do that again and again so you will remember member. Date created 08/2020. Description: run basic Linux tasks. Date. What was this fourth one? Tell me. Modified. Yes. Again, we are not modifying. We're just putting today's date. And I guess that's pretty much it. Now, I always like to start my script with echo, so it will be a new line. And this time I wanted to write down echo. This script will run a few basic tasks. Now remember, this is not a description. This will actually output on the screen. Then another echo just for a new line. Now what do we want to do? We want to see which directory we are in. So simply just type pwd. Okay, it did that. Now let's see if it could do ls. Who am I? Date, cal. And the last one is I wanted to create 3 files, A, B, and C. So that's pretty much it. It's going to run 1, 2, 3, 4, 5, 6 commands, 6 basic tasks. We covered those tasks, what exactly they're going to do, and go ahead and escape out of it and right quit, save the file, and check the permissions. There are no permissions. Assign the permissions. Basic tasks. Do ls-ltr just to confirm. Yep, the basic task script has been created. Now go ahead and run basic tasks. Hit enter. Nice. Okay, let's see what it did. Okay, so this script will run a few basic commands. This is the echo thing that we added in, right? Then the next thing, we wanted to know which directory we are in. We are in this directory. Then ls will list all the directories and files inside of my current working directory. And those files are basic tasks and hello world. So it's this own file that I just ran the command. And then who am I? That's my name. I am logged in as myself. Date. This is the date. It's telling you what date is today. And calendar. This is the calendar that it is output. Now the last one is, hey, what happened to touch ABC? Did it create that file? I am sure it has. But why didn't you see in here when it was listing that files? Very good question. Now let's go back to our sequence. Remember, the script works in a sequence, in order. The first thing first. So by the time touch ABC, it hit that touch ABC, it ran ls command before that. So that's why you didn't see it. So now if you run it, you will see your 3 files in there. So without running the script, just do ls-l and you'll see in there. There you go. See, you see it? So I'll do ls-ltr. LTR will list everything in a date format when it was last created. So if you see, it has created A, B, and C files. So this is how we do our basic tasks. So if you are going through all that hassle every day and you want to automate them through one simple basic tasks, you could do that through simply this way. I like to keep things neat and clean. So what I would do is I will put echo in every line. Echo, echo, and echo. And then at the bottom, I will say echo, end of script. Nice? Okay. Okay. You guys probably noticed, hey, Imran just did something. I did it purposely. I just put it down a wrong command, and let's see what the error message comes up. Let's run the basic tasks. And it did everything I asked for. Now you see it has given me those ABC files as well. And now at the bottom, it says, line 21, command not found. Okay, so something went wrong with the script. Now this is how you troubleshoot a script. I wanted to cover that troubleshooting part right here at the beginning, because every time you write a script, there is always a chance, I would say, I'm not going to say that, very little chance. We are humans, we make mistakes. There's always chance that you fat finger some of the command or you make a mistake, then the script doesn't run. Then how do you troubleshoot? Well, the Linux operating system or the scripting shells are smart enough to tell you where the problem is. So it's telling you that the script is this. And in line 21, there's a command called ECH. That command now found. You want me to run the command? I understand, but there is no such thing as command. Why? Let's try it just by simply typing it. Yeah, there is no such command. So we know that in line 21 in this script, there is a mistake and we have to fix it. And the way I do it is I VI the script, and I will, let's say if I'm right here or anywhere, I'll just do colon 21. This will bring me exactly to that line where it was complaining. There you go. So it brought me right to the line, and I see, oh, okay, I'm sorry, I made a mistake. I left out O. Now it will run it. Perfect. Perfect. I fixed my mistake. That is perfect. That's how we learn. So when you hit enter again, run the script, and there you go. It is giving you everything that you asked for. And at the end, it's telling you end of script. So it's a good practice that you output that what exactly the script will do at the beginning. That will tell the user, hey, the script will run a few basic commands. It will throw that out on the screen. And when the script finishes, it should say end of script. Perfect. So that's how we do simple basic tasks using scripting language. So try it out. Try different commands in there. There are so many commands in Linux. I want you to try them out one by one and see how you could automate a few simple tasks, some few daily tasks. Let's keep on moving. So we are going to create another script that will run basic administration tasks. So before we had the basic commands that we wanted to create in a task, in a script. So now we wanted to run basic tasks. Sorry, basic administration tasks. And those basic administration tasks, an example I picked as the first one is run top. Second one is df minus h. Third one is free, which will check the memory. So by the way, df is to check the disk space. Uptime is to tell when was the last time system reboot and system load. IOStat is input IO statistics. So I'm sure you know these commands already. If you don't know, that is fine. You can look it up and find out what the command do. But anyway, these commands are there to check the system health. So when I actually joined my first company, this is something that we were doing manually. So every time a system administrator would come in, they will run these commands on the servers and checking the system health. Are there any issues? Are there any disk space issues? And so on. So when I learned somewhat of scripting at the beginning, I was like, wow, we could do so much about this and without wasting so much time. We come in, we spend like hours just going through so many systems and running certain commands. So I created the first script called check script. And that would check the system health. And it would actually, I added so many things later on, so many other commands that actually we needed as by the system. But anyway, the point is that you could automate all those system administration checking type of related tasks in a script. So let's create a new script. And we are logged in as ourselves, and we are in our home directory and script directory. And as you know, we have these two scripts that we created, and then we have a few empty files. That's fine. We'll leave them there. The next script we wanted to do admin tasks. So this is the name I picked. You could pick anything that best fits the description of your task. Go ahead and hit enter. What do you do first? You define the variable. Yes. Then author, who is writing the script, that is you. In my case, me, of course. Then we are doing date 08/22/2020, let's say. Then we are doing description. The script will run basic admin commands or tasks, whichever you want to pick. Date modified. Since we're creating the first time, we could pick the same date. Okay, perfect. Now I will always like to do echo and says this script will run basic administrative commands. That's it. This is how it's going to come up. Of course, I wanted to do echo here and one echo here. Okay, now what are we going to do? We are going to run top command first. I'll do echo again. df minus h command, second, echo again. Again, as you know, echo is just to put an empty line, so it'll look more organized. Uptime, echo, IOStat, and echo end of script. Perfect. Okay, good. Now let's go ahead and save it and assign the permissions. And the name of the file was admin task, yes. And let's LTR verify the permissions are given. Okay, so now let's run the script. Okay, so it did run, and if you notice really quickly, it spit out the line where it says this is what the script does, and now you notice that the first command that I wanted to run in my script was top, and now it's not running other commands. Why is that? Because the top command is a command that will keep your session open and give you the status of your processes, your memory in real time. So it does not exit out. It just stays there. So that's why my script is kind of stuck for it to finish so it could run other commands. So how do we overcome this problem? Well, one thing you could do is you could tell the output of the command to be simpler, or pipe it to something else, so this way it will run other commands. So how can we do it? Let's do quit, and you see as soon as I did quit out of as soon as I did quit out of top, it did run all the remaining commands. But of course we were stuck there and we didn't know what happened. So what I'm going to do is we will log back, or we will modify the script again, and the script name was admin task. And this time what we're going to do is we are going to say that when top runs, just give me the first 10 lines. That's fine, because mostly the top part of the top command is the most important one, which gives you the information about memory, CPU, processes, important most processes that are taking up most of the CPU. So I'll pipe it to head -10, and then we will run that command again, the script again. Okay, so let's run it now. Admin task, hit enter. All right, see, it gives you, gonna wait for a few seconds, and then it'll give you everything, because it was processing, and now it gives you from here. See, this script will run basic administrative task, and those tasks are, the first one is top, and the top is giving me the first 10 lines. Then it runs df-h command, which is giving me the output up to here. Then it's running free. Free is free -m is for the memory information. Did we include free? No, actually we forgot. That's why I was looking for free and it was not there. Anyway, we'll add that. The next command that it was running was uptime, and uptime is right here. And the system been up 47 minutes, and the last command it ran was iostat, which is right here. And the last thing we added was end of script. So of course we missed the missed the free command. That's fine. We'll go ahead and add that in. And it was after df-h, so echo free -m, put echo here, and now I have added the missing command that we wanted to run. There you go. So let's see, it did give us, yes it did, right here. This is the output of free -m command. Okay, so this is how you run the basic administration task. You could actually also filter out this output through a pipe, and you could view anything specific that you wanted to know about this output. So what happened was in my beginning years when I joined my first company, when I ran this, when I created this check system script, what I did, eventually it was throwing up so much information that we really didn't need it. So we modified, filtered out a lot of output that was coming from these commands. So you could do that too, depending on what exactly you're looking for. My recommendation is to you is go ahead and create a couple of scripts that will run your basic administration task and see how they run. In this lesson, we are going to define variable and run those variables. So this is a good exercise where you will learn how you could define variables at the beginning of the script. So anywhere you would need to use those variables, anywhere in the script middle or at the end, you could just simply run that container, that variable. So what exactly a variable is? So let's look at this. So look at this list that I have. Now you see I have defined a variable for P. I have put it PWD. For L is just simply ls. W is for who am I, D for date, and C for Cal 2018. So these are the variables. The variables are the first digits, P, L, W, D, C. And the commands that inside of those variables, I would say, are the ones on the right-hand side. So this is how we're going to create a new script, by having those variable defined at the beginning. So I'm going to log into my machine. I believe I already have logged in. So what I'm going to do, just for fun, just for exercise, or just for practice, I'm going to go one step back, and I'm going to create a new directory called mkdir, and I'm going to call it my scripts. So it's just to tell you how you can differentiate from one directory to another. But anyway, whichever directory you pick, make sure there's a specific directory for every script. Don't just put it in your home directory or anywhere else. It's not a good practice. So I have this directory created, my scripts, and I am going to create a new script. I'm going to call it, let's say, variable test. Just that. Okay, and the first thing what you have to do is bin bash, and then you have to define the comments, the author, the description, the date it was created, and all that stuff. I'm not going to take a lot of your time to go into defining every single one of it. So I'm just going to, from now on, I'm just going to define the shell, which is the mandatory thing. So, and then I'm going to go straight to running the script, writing the actual script. So anyway, because I do know the time is valuable for everybody, but I am very hopeful that you guys do follow the standard that I have. So first thing that is I'm going to do is put a comment here. I'm going to say define variables. Okay, and those variables are, first one is P equal PWD. Second one L and ls. W is for who am I, but you know what, actually there is a command called W in Linux, so I'm just going to put who am I, just WIV. So that will be who am I, date for D, and C. Now since the C is a calendar, and then I want the 2018 calendar, so it has a space in the middle, so I have to put that in quote. Single quote should work. Cal, if single quote doesn't work in your environment, you could put double quote. That's fine. Okay, so now your variable defines. Now what do you do is you could just simply say echo run variables tasks, just that. Echo again. Now I'm going to run the command. I'm going to run the variable P. To define the variable, to run it or to get executed, you have to start with $P. So this way the operating system or the shell would know that you want to run that variable. Okay, perfect. Next variable I want to run is L. Third one is WI. Fourth one is D. And fifth one is C. So it's just that simple. Let's save it. Okay, now let's give it a proper permissions. Let's see, it's there. Yep. Let's verify one more time. Yep, you see the reason I came in, I wanted to see if it has all the proper variables in. Okay, looks good to me, but let's try to run, because to test a script, always run it. Variable and test. Okay, so we do have some kind of error messages. Perfect, that is fine, because as we learned, we wanted to see where those error messages are and how can we troubleshoot. Now, as you see, the first message that is giving us that there is in line 8, it says unexpected end of file while looking for matching quote or single quote. So let's go to line 8 variable. And to go to line 8, it's just simply type line 8, and it said, see what happened? I put single quote here, and I put double quote here. Okay, all right, so one problem is fixed. Let's run it again. Okay, I think it ran fine this time, hopefully. Yes, okay. Run variable test, and those variables is PWD is this. The file is variable inside of the directory, the user who, which is a variable, date, and the calendar. So that's how it was coming up. And you notice when I ran the command earlier, the test variable, when it had a problem, it gave me error messages on 2 lines. Do you know why? Because first line is 8, which had that double quote on one side and single quote on one side. So that we know that was an error. But why we were getting error on line 17? Think of it. Let's check why we were. I know, but I want to show you exactly why. So let's go to the file and now this time type 17. You know why? I'm sure now you know why. Because in line 8, the defined variable was this, which had a problem. And in line 17, when it came down to run that variable, it says, hey, I can't run that variable. So that's why it gave us error messages in 2 lines. Okay, so anyway, so that's how you define variables. Going forward, I will be using scripts. I will be writing scripts in different directories. I could be writing in my script. I could be writing in just the script directory. But anyway, you could just follow just one directory if you want to, or you could just do different directory depending on how you want to structure your scripting skills and how you want to organize them. Input and output. This lesson is about writing a script where the script will wait for the user input. So when you run the script will wait for you to type in something. So it would take your command and then output based on that written statement that you have given to the script. So the way it works is the things are the scripting commands that you need to use for that is read, which will wait for your input, and the output would be echo. So whatever that you input, it will output to the screen using the echo command. So let me log into the machine and I will show you how this could be done before I confuse you more. So I have my machine open right here and I am in my home Absol my scripts directory. I am going to create a script called input script. Just like that, and I'm gonna go ahead and hit enter. I will define the variable. Next thing, as you know, you put the author. I'm not gonna just wait time. I'm just a date, description, and so on. Anyway, so you should type everything. I would definitely recommend you. So again, since we don't have time, I really want you to learn fast. So don't worry about it at this point. Then you put in like echo hello my name. Oh, come on. I'm having a bad time typing. Okay, so hello, my name is Imran Afzal. And as you know, it will just simply display that line on the screen. Now, what we want to do next? Then we want to do put echo just for an empty line and then echo what is your name. So now we are asking user for user input, and the way the script is going to wait for the user input is by simply the command read. The read is actual command in Unix or Linux that will wait for the user input. Now you have to define a variable to read. So any variable, anything that user types will be automatically added to the variable. And what is that variable? Well, you have to specify or define that variable. Let's say I'll pick any variable. Let's say even I pick name. So we'll say, you know what? When user put in the name, put that input into a container or into a variable, and that variable name is actually name. I'll just, you know what, in simple words, name container. So make it easy so you are not confused with name itself. Now, once the user provides that information, then simply put in an empty line and then do echo hello, and now you put $name container or whichever the variable you have defined here. You hit enter and echo, and that's pretty much it. Let's give it proper permissions. Proper permissions are there. Let's run it. Okay, you see the first line on the screen is hello, my name is Imran Afzal, or your name. And now it's asking you what is your name. So it's waiting. See, you didn't get the prompt back. Why? Because the script is waiting for your input. So let's say you wanted to type something, let's say Jerry Seinfeld. And now you hit enter and it's going to say, hello, Jerry Seinfeld. That's how the input and output script works. Of course, it gets a little bit more complicated as we go on, but basically, if you wanted to write a script and you wanted to take the input of the user, you have to use the read command. Now, let's edit the same script, add a few more things in the script and make it more professional. Let's see, vi input script, and now I wanted to define variable. So I'll say the variable, let's say a equal host name. And you know host name is actual command in Linux that will give you the host name of your system. So I wanted to say, hello, my server name is $A. And what is that $A? The $A is the container right here. And that container is what? Host name. That it will show you right here. And then you'll say, what is your name? And now, just for giggles, I wanted to change the read it to just a different container. I'll put B. So just so clarify that you do not focus on the container name. Container name could be anything. So you are asking, what is your name? And the user who's going to provide the name will be put into the container called B. Now echo hello B and bye. Okay, so now what we are saying is that when you run the script, tell the user, hello, my server name is $A. And what is $A? $A is the host name. And it will print it here. And what is your name? And you will put in your name, and it will output back to your name. Now, before I run it, I just want to tell you one thing. There will be error in the script. Why? Because when you define a command with a variable, you could run that variable if you only simply type $A. Then it will run it. But if you try to run that variable using like an echo command, then you have to have this ticks on the side. What are those ticks? Those ticks are right below your escape key. Those are the ticks. So you have to have those. But anyway, I want to take it out for now, just so you see that what do we get if we don't put those ticks in there. So escape, save it. Now let's run it. It says, hello, my server name is hostname. Oh, it actually took the exact name that I typed. It didn't think that it's a command. And now it says, what is your name? So now I'm going to put in Imran Afzal, and it's going to say, hello, Imran Afzal. Okay, so this part from right here to here works. This part from here to here works. But I wanted to have my host name here. And what is my host name? My host name is my first Linux VM. I wanted to have that displayed here. So going back to what I was saying is, if you are defining a variable and you want to run that variable with echo, then you have to put the little ticks that is right below the escape character or escape key, and also below that little curly thing. So now let's run it and let's see if it works. Ah, yes, it did. You see right here? Hello, my server name is, this is the host name. What is your name? Okay, Imran Afzal. Hello, Imran Afzal. See, that's how the input and output script works. Try it out with different things, play around with it, and ask questions back and forth, back and forth. So first, what you should do is, as your practice, what you should do is you could put more than one read. How you could do it is like this. You put echo, just an empty line, and then you do again echo. What is your profession or your occupation, or what do you do? And then you have to read here again. Read C. And then you do echo again. One more echo. And now put in, do you like, no, let's put it, what is your favorite show? And now this time read A. We have used B, we have used C, now use D. Okay, that's it. Now what we have to do is, first thing it has to say is echo. It will hello my name. Next thing I want to do is it should echo your your profession, which is whatever the profession is, C, is awesome. Okay, next one. $D, which is favorite show, is a good show. You see how I did it? First, I asked 3 questions. 1, 2, and 3. Once I have all those 3 questions asked, then I have put all these questions in different containers, and I am outputting those containers one by one by saying, hello, Imran Afzal, echo, your profession, whichever is awesome. And then your show, whatever the show is a good show. Now let's see if we could run it successfully. /input. Okay, the first name, the first question comes up. What is your name? Imran Afzal. See, now it gave me a second question. It didn't give me the output right away. Now it's waiting for me to give it all the information it wants. What is your profession? Let's say engineer. Okay. What is your favorite show? Seinfeld. And now when I hit enter, because I have answered all the 3 questions, and it will say, hello, Imran Afzal. Your profession, engineer, is awesome. Seinfeld is a good show. See how it works? Now, think of this now. When you are installing a program or you are executing some kind of script, or even if it's Windows or even if it's Linux, now you know that when you're going through the wizard and it asks you questions, do you want to install that? You say yes, no, put in your organization name, put in this, you type in your name and this and that, all the information that system gathers from you, it actually plugs that information inside wherever your variable is defined. So that's just a simple example of that. So it's like your little script, a wizard that will take all the information and it will send it out on the screen. You could also take that information and put it in your database, send it out in his email, or whichever the way you want. So that's how you work with input and output scripts. Again, I will say go ahead and keep that script long, add more things to it, add fun things to it. There's so much you could do with it. And if you want to share your new creative script, you might send me an email, and I hope your script runs without any error. If you get through any problems, not to worry about it. That's how we learn.
If-then scripts. Now you know how to write scripts. Now let's get into one step up. Some advanced scripts, some if-then scripts. These are the scripts which will define some variables, and if those variables are met, then you could run those scripts. In if-then script statement, if this happens, do this. Otherwise, do that. So whatever that you define that has to be met, then it will run it. Otherwise, it will give you some different output depending how you write a script. To better illustrate this concept of if-then script statements, let's get into our machine. Okay, which directory we are in? We are in our home directory, and the directory inside of it is my scripts. In this directory, we're going to create a new script, and we're going to call it vi if-then script. Again, it does not have to be the name that I'm picking. You could pick any name like my script or XYZ or ABC, anything that you want. So when we want to write a script, you do vi and the name of the file. It will get you into the insert mode. So the first thing you do if you want to write a script is define a variable. Now, I already have a script written that I'm going to copy it from, so it will save us time. And this is a script which checks for the variable. I'm going to copy it, and I'm going to paste it. Now, let's look at what this script does. This script is going to look for count equal 100. So if count equal 100, which is the variable, then it's going to say echo the count is 100. If it is not equal to 100, then it's going to say the count is not 100. So that's what pretty much if-else statement does. So let's look at our script. Let's run it. Let's first save it. And once we save it, we'll of course verify the file is created. Yes, what's inside of the file, we'll look into it, and it has exactly the same thing that we typed in. Now we need to give executable permission to this script. Verify it. Yes, it does have executable permission, and I'm going to run it. There you go. It says the count is 100. Perfect. Because we defined in our variable that the count is equal to 100. So what happens if we change the count to, let's say, 1? We save it and we run it. Once we run it, it says count is not 100. So this is the exact purpose of if-then statements. Is if it looks for the variable, whatever the variable is defined, if the variable value is not met, it will tell you exactly what you want it to do. You could also change the output by saying if, then, else, saying, sorry, the count, let's make it lowercase, count is not 100. Again, count is 100. This is our variable. And it says if bracket count equal 100, then echo it, count is 100. Else, otherwise, echo, sorry, the count is not 100. And fee is the opposite of if, and it is telling the script, now you should exit out, that your work is done. An if-else statement is done. So you exit out of it by saving it. And now when you run it, it tells you, sorry, the count is not 100. So you just change the output to whatever you want, and that's what the if statement, if else or if then statement does. Another example of if else statement that I'm going to pick is right here. I'm going to copy it, and I'm going to create a new script is if then new. I'm going to define the variable, which I already copied. And the first command I have clear. It means when the script runs, it's going to clear the screen. I don't want to see anything that's already on the screen. Next thing it's going to do is if minus e, which is used, which is the option that is used to check if a file exists or not. So it's saying if this file, home iobserve file exists, then what you should do, you should then echo file exist. Else, if file does not exist, then say echo file does not exist. And that's what pretty much it's doing. So let's run this command. And we, of course, have to give executable permissions. Let's verify it has executable permission. Okay, it does. Now let's run it. If now new. Okay, when you run it, it says file does not exist. It's telling you the actual thing. Why? Because there is no file exist. Let's do cat if then, and it's the file exists. Where should the file exist? The file should exist in my home directory error.txt. So I'm going to create a file now. I'm going to just touch it, and I'm going to create this file. The file is created. Now I'm going to run the script. And now it says file does exist. So this is sometimes a very useful command, and it is a very useful tool for system administrators who wanted to run this command at a certain intervals or a certain day because an application creates some error files or not, and they run this script on a cron job to see if the file exists or not. If it does, it means the application is running fine. If it does not, then it means the file does not exist, and it will throw you an error message. So this is a if-then statement, and we do have other if-else statements examples in this file as well. And this file is also part of your resources, your handouts, and I want you to try out every single script, create every new script, and try out different values that you have here. So this is a very cool script that I have written. It tells you about your name, and it's asking you, do you like working in IT? And it asks you, if you respond yes, it'll tell you you are cool. If it does not, you say you should try IT. It's just a good feel. So I want you to run the script on your own, create a new file, write the script, and execute it. And I'm very sure it will run just fine without any error. Case statement scripts. Now this lesson, we will go over the statements of case where you are given
options in a script to pick from. So it's like an interactive way of involving user, whether they want to select option A, B, C, or so forth. So in case statement, if A option is selected, do this. B is selected, do that. C is selected, do this. So these are the different options. And what exactly A or B or C is going to do? Well, it depends on what the variable you assign to them. For example, if you assign A to do to output date on the screen, it will output the date if A is selected. So now let's look at the script. I have a script right here. Always starts with the shell. The shell is bash. The next is echo, which is just printing out an empty line. Then it's going to echo, please choose one of the options below. It will print out A, as in for variable, equals display date and time. B, list file and directories. C, list users logged in. And D, check system uptime. Now this is all just a display message that's going to show up once the script is run. Then it will read all the choices. It will put all the choices in a container. Then the case statement comes in. It's going to say choices, which is this variable choices. In the container, we put in all these choices. And what these choices going to do, A, it's going to run the command date. B, it's going to run the command ls. C, is going to run the command list of users who are logged in. And D, it's going to run the command uptime. Now remember, all of these are actual commands inside of your Linux operating system. When you run it individually, it will give you the date. But this script will allow you to automate the task to pick these commands for you. So let's copy them. This is the whole script we have. And I'm going to go into our Linux machine, which I have already logged in. I'm logged in as myself, and which directory I'm in my home directory. I'll go into my scripts directory. I believe my scripts, cd my scripts. And in that directory, I have already created some of the scripts that we learned in the previous lessons. So for this, I'm going to create a new script. I'm going to vi, and I'm going to name the file case script. You could name it anything you want. Once you are in VI mode, hit insert I, and you could just simply right click on your mouse and it will paste everything for you. The first option is, once again, it's just the shell. It's telling you to run which shell environment. The second one is you could type in anything. This script is created by me or yourself, your name, or whatever you want to do. Second thing it's doing, by the way, empty lines in the script doesn't really matter. You can leave them empty, or you could just put a hash sign. Next thing, echo. Again, echo is just going to throw an empty line on the screen. And as we went over the script, this is exactly what it's going to do. And we're going to save this file. Do ls-ltr. This is still a file. It's not a script because we have not assigned executable permissions to it. So to assign the executable permission, a plus x, to assign executable permissions to all, user, group, and others. And the name of the script is kscript. Verify it has all the permission. Yes, it does. Now we're going to run the script by / and type kscript. Once you're going to run it, you'll see it's going to give you that please choose one of the options below. So you have the list of options right here. A, to display the date and time, is nothing but exactly the display of all those texts that I have typed after echo, which you see right here. It's everything after echo. It's nothing but an output on the screen. So now if I select A and run it, it exits out the script and it gives me the date. It runs the command date itself, as if you type date. It gives you the date, today's date, the time, and year. Let's run it again. And this time we'll pick B. Once you do B, it lists all the files or directories inside of my current directory, which is the command that you already know, which is ls. Run it again. And this time I'm going to pick D, check system uptime. And the command to check system uptime is just simply uptime. And this script will run the uptime command and will output on the screen. So this is what exactly the case statement does. So the last option, if you notice, we have a star right here. What it's telling me that if any other option is picked, it's going to say echo, invalid choice, so buy. So let's try to run it. And this time I'm going to pick F. Of course, F is not one of the listing. So once I do that, it'll say invalid choice, buy. So that's how the case script works. I want you to try it out. Pick different commands that you want to run. Pick different text message that you want to associate with those commands and try to run it. Let's say if you run it, pick A for what is your name, and it should type who for it, and it will give you the login name and so on, and all the different commands that you have learned. If variable is defined 10, then run the script 10 times. Or variable is green, blue, red, then run the script 3 times for each color. So it actually simplifies your tasks. If you want to, for example, create files or 10 files, then you don't have to run the command again and again and again. For loops will do it for you. We'll go back into our Linux machine and we'll try a couple of scripts for loops, and then you could try it on your own, and you'll become proficient by running these little tiny scripts. So which directory we are in? We are in our home directory. Always home is not just home, but entire home directory. And the directory that we are in is my scripts. So in my scripts, we're going to create a new script. We're going to call it this time ABC. Do vi ABC. And the first thing you know already by now is that you define the shell script that you're going to run this script in, or the shell environment, I would say, that you're going to run the script in. And again, I have already written a few scripts for you to go over this training, and I'm going to go into our first script, which is a simple for loop output. I'm going to copy this script, and I'm going to just simply paste it. This already has a defined shell, so I'm going to delete that line. So what is it doing? For I in 1, 2, 3, 4, 5, do. So I here is a variable, which is telling that this container, which is the container name is I, it holds the numbers 1, 2, 3, 4, 5. And then what is asking it to do? The script is going to do echo welcome variable 1 times variable 2 times variable 3, variable 4, or variable 5 times. And then once it's done, it is done. So that's why we have to define done at the end for the for loop to finish doing what it's doing. So I'm just going to save the file. Once the file is saved, again, you have to give executable permission. The permission is given. Let's verify it. Yes, the ABC file is there. Let's see what's inside of it. Inside of it is exactly has the same thing. Let's run the script, ABC. And there you go. It's doing welcome 1 times, 2 times, 3 times, 4 times, and 5 times. So basically, if you have a repetitive task, and trust me, you're going to be working in a corporate environment where you would have to do so many repetitive tasks, and this loop script is going to become so handy for you that you will be creating scripts for every repetitive task that you will be doing every day. So this is outputting 5 times. Let's look at the second script. So the second script, what it's doing, it's basically doing the same thing, but this time it will just output the names. And I'm going to make this XYZ as the name of the file. And it has always starts with the shell. The shell name is bin bash. And now this time we're going to put in some comment, and we're going to say this script will output Imran with different actions, because it will say see Imran eat, see Imran run, see Imran jump, and see Imran play. So this is what the script is going to do. So that's why I have put it in just a comment. You can put more comment. Let's say the script is created by Imran Afzal, and if you want to put a date, you can, but we'll skip that out. And the script starts right here. It's telling you for I in, again, I is a variable, in is you putting inside of your variable, and variable is just like a container. It's telling you put eat, jump, run, play inside of a container called I. Once it has all these 4 words inside of the container I, then do what we are doing. We are echoing see Imran $I. The variable is always be displayed with the dollar and the name of the variable.
So it's telling it $I, and then once the script is going to display every word in the container, then it's going to be done. Once done, the script is created, the script has done its job, and we will verify it. The script is there. Next thing you know by now is to change the permission on the XYZ. So it will have executable permission. And executable permission, once again, I am reiterating again and again, if you cannot run the script, it's because you do not have executable permission. So we do have executable permission. Awesome, perfect. Let's run it. X, Y, Z. Uh-oh, it says bash XYZ, no such file or directory. Why is that? Of course, we have put Z. It's Z actually, X, Y, Z. So let's run it. And there you go, cmron eat, cmron run, cmron jump, cmron play. So again, it is doing a repetitive tasks for you. So this for loop is a very strong statement in a scripting environment that will let you run repetitive tasks again and again. So you don't have to do it yourself and spend time all day and creating those little tedious tasks. I want you to write other scripts that I have inside of this file. This file is again in your handouts. I want you to download this handout, create these little scripts again and run it and see what they do. It will be a great exercise for you. Do-while scripts. Do-while scripts are very similar to for loop scripts. The do-while script or statement continually executes a block of statements while a particular condition is true or met. For example, if you are running a script and you create it in a loop, it will run until a certain variable is met. For example, if you wanted to run the script until August 2015 at 2 p.m., then you will define that in do-while script. And a lot of times the scripts or the daemons, the process that never dies, that keep running and running and running, they always have do-while scripts because they are running continuously until a certain condition is met. So for example, run a script until 2 p.m. As soon as the 2 p.m. hits, you are done. Exit out. While condition, do, command 1, command 2, command 3, and once all these commands are done and the condition is done, then you are done. You are done with your script. So let's look at our Linux machine and let's try out a do-while script. Let's clear the screen where we are. We are in my script directory, which is the directory we want it to be in. And this time we're going to create a new script and we're going to call it script do-while. Again, it's just the name I'm picking. You can pick anything you want. Hit enter. You are in VI mode. You hit insert and you start typing. What's the first thing that you type? You type hash bang bin bash, which defines your shell environment. And if you wanted to put a comment, you could say this script is created by Imran Afzal on 2018. Yeah, that's fine. And if you wanted to put a description of the script, you could do that. But let's get into the script. I have already written down a script. And I'm just going to go in and copy it. There are two scripts in my handout. I'm going to take the second one. I want you to do the first one yourself. I'm just going to copy it. And I'm going to paste it real quick. Let's see what the script does. The script is doing, of course, the first one is defining the shell, which we already have. So we're going to take it out by hitting DD. And then it's telling us that the count is 0, the number is 10, while the count is less than 10, do, echo, number of seconds left to stop this process. And the process is the variable, which is $1. And echo is just an empty space, empty line. Sleep is a command that will wait for the number of seconds that is defined after the sleep command. Then it has a few number of expressions. These are the expressions. You could get it anywhere online. I have that expression for a while that I tried out many times in my work environment. It works perfectly. And if you want to use it in your work environment, you are more than welcome to do. So the next one is the echo, and then it says echo $1 process is stopped. And echo, again, it is telling it that it's giving an empty line. So let's run the script and let's see what it does. Give an executable permissions. It says 10 seconds left to stop this process. 9, 8, 7, 6, 5, 4, 3, 2, 1, and done. Process is stopped. You see that? So these do-while scripts are created for a certain value or certain time to be met. And once that variable is met, it will stop the process and exit out of it. I want you to create a new script in your environment, and this is the script. Again, this is also in the handouts. You could copy and paste the script, create a new script, and run it. You could also be my guest to go online and just type do-while script examples. There are tons and tons of do-while scripts that you could try and get a little exposure to do-while scripts. I'm sure by the time you will run at least 5 or 6 scripts, you know exactly what this statement do.
All right, let's look at the exit status. What are the exit status? Every time a command is ran in a shell, or in, I would say, let's go one step back in Linux, it always has a status associated with it. If it is successful, it will always give a status of 0. And there are statuses from all the way from 0 to 255. Every status has a different meaning. These are the actual error codes or the numbers that developers associated with different meanings. So every developers or every application have a different meaning. But for us, we only going to focus on a very few statuses, and that is number 1 is 0, which is yes or no if the command that we ran previously is successful or not. If it is not, then it will give a message 1, exit status 1, which is known as a minor problem. Or number 2, it's a serious trouble, or everything else, which is exit status from 3 to 255, everything else. So why do we need actually exit status in our scripting? Good question. Well, when we have to do a lot of comparisons in our shell scripting following these lessons. And in comparison, you need to know if your command ran. So if it did ran and it was successful, then do this. Otherwise, don't do that. As we learned that there are statement scripts, if, else, while statements. Every one of those scripts or statements do need some kind of status before proceed to the next execution. So let me show you real quick by logging into my Linux machine. I am logged in as myself, and I am in my home directory. So now let's see if I run a command ls -l, and it ran successfully, right? It gave me everything that I was looking for. But if I wanted to know actually the status of my preceding command, I would do echo $, and then the question mark. This is telling the shell or the bash that what was a command that ran previously and tell me whether that command was successful or not. If I get a 0 return, there you go. It means it did run, right? Because I wanted to get a listing of all my directory files and directories in this directory, and it did give me, and that's why I have 0. Let's take another command. Let's say I wanted to do which directory I'm in. I'm in home IFSol directory. Perfect. It ran. And if I do echo $? Again, it will give me 0 again, that it was successful. What if I run a command, let's say pwdd, right? This command, there's no such command. So if I run that, it says bash command not found, similar command is pwd, give me a recommendation. But anyway, the command was not successful. So now if I ask the shell whether the last command was successful or not, I will run the same command, echo $, and it is giving me error code 127, which is different from 0. So as I said, anything from 0 to 255 is not error codes, but anything above 0 is all error codes. Anything that is 0 is successful. Now, when we create a script, so let's say I go into, I create a script, I call it test code, just that. And I will declare my shell, and now I will not define all those stuff that I know you already know. Since this is a very small script, I'll just do echo hello, and then I will ask if the command was successful. And I will save it. Test code. Now when I run that, you'll see I'm getting the hello, and with that I'm getting the 0. It means it was successful. Same thing if I wanted to do something else. Let's say if I go back to test code, and this time I will do, instead of echo, I'll just replace that with iki. So there is no such command as iki. So anyway, let's see what the error message comes up now. I'll run it again, and now it's giving me the same error message that it was not successful. Same way if I try ls minus LLLL, and oh, it does exist actually. Let's say ls minus z. There is so many options, right? ls dash 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 p. Okay, so there you go. See, unrecognized options. So now let's see what the error code is. The error code is 2. See, it's different, and that is about error code that shows serious trouble. So this is about you have not defined the option successfully. Now let's run another script really quick. I'm going to create that script. I'll call it vi exit code script. And I will define the shell. And this time I want to make sure I run ls-l home iabsol /check. This is the command I want to do. So what it's going to do is it's going to do ls-l, and it's going to only find out if home iabsol and there's a file name check exist. Okay, so now I have to define the statement if $, which is the command that I ran, equal to 0, which means if the command ran successfully, then do what? Then echo file exist. Else, echo file does not exist. And phi. And let's run it and give executable permission. Now let's run the script, and it will say cannot access home iabsol check no such file and directory. Then it says, of course, file does not exist because the error code does not match 0. So if I create a file check in my home directory, so I'm in the home directory, I'm just going to do touch and check. The file is there, right? So just verify it, check, and it is there, right? So now when I run that script again that I just created, and it did give me that file with my ls-l command, and it says file exist. So that's why it is, that's why the exit status importance is there. So this way you could actually associate each code with some kind of meaning. So developers like C++ or other developers like object-oriented based programmers or people who write operating systems, they are the one, they heavily use these codes because these codes make a lot of difference. But in our class or in our lessons going from this point on, we're mostly going to use 0 to make sure if it exists or not. And that's why most of the time the system administrator engineers use in the everyday Linux scripting languages. So try it out and see how you could create different scripts with error codes and what the error code gives you. Welcome everyone, and welcome to the real life shell scripting section. This is the actual section that you've been waiting for, where you want to learn actual real life scriptings. In this section, we are going to cover all scripts that I have actually experienced in all my 16, 17 years of system administration, system engineering type of related tasks, where I had to actually automate tasks using shell scripting. And there are also many other shell scripts that I have included in this section that you will find very, very useful in a real life, where you, if you are already in a system administrator capacity, you will find those scripts really helpful that will help you automate your daily tasks. I'm not going to list every script right here because I will keep adding them as the course goes, and you will see so much information about it. Accessing data from a file. a file consists of some kind of data, right? It has a lot of information inside, and you need to pull that information every now and then. Now, that file could be any file. It could be application file, database file, a simple text file, a log file, or any kind of file that you try to retrieve some data, massage the data, and you want to view it the way you want to. Now, you could do that manually by running commands, adding commands here and there every day. But of course, if you are doing that changing of data or running those commands every day, then this task, doing it manual, become tedious. So the best thing to do is to automate that. And the way you automate it, you actually create a shell script to do that. So in this lesson, we are going to create the first script that will pull errors, failures, or warnings, or any kind of information that you want to pull from a file. So most likely, we will be using like our log messaging file, which is a huge file which gets which actually logs all the error messages or warnings or failures or many other system-related messages in a file. But sometimes when you want to view that file, you don't want to go through all that stuff, that informational stuff, or something that is not related or is not actually what you're looking for. So this is the first script that we'll go into, and we'll create a script. The second script that I wanted to cover is when you actually have some of the administrative commands that you run, and then you want to change the output of the file and perhaps output to a different file. So this way, every time you come in, it's viewable by you, and whenever you run the command. So let's look at our first script. I'm going to log into my Linux machine through the PuTTY client. I'm logged in as myself, and I am in my home directory. Now, I want you to copy varlog messages from varlog to your current directory. Now, what is your current directory? Your current directory is home ifsol. Now, I want you to go ahead and create a new directory and call it professional scripts. This is the name you have chosen, where we will add all our newly created scripts into this directory. And when I do ls-ltr, you'll see at the bottom it has that directory. Now, I wanted to copy var log messages file into my current directory, and that would be dot. When you hit enter, okay, you say it's coming up as permission denied. Why? Because varlog messages file is owned by root, and it is not. It does not have read permission for anyone else. So what we will do is we'll become root, and now I will copy var log messages sorry, I'm doing cd var log messages to my home directory, and from there I will copy it to professional scripts. Now it is copied. Now let's go to my home ifsol professional scripts directory, and let's see, the file is there. Okay, good. So now in order for me to read that file, it should have the read permissions right here. So what I'll do is I will go ahead and first of all I'll change the ownership of the file, chmod ifsol messages, and well, okay, I think it's chmod messages file to ifsol. Oh no, sorry, I'm using chmod. It has to be change ownership because we're changing the ownership. Okay, it is changed. Now you'll see, let me make this a little bigger. Now you will see this file, messages file, is owned by ifsol. Now I'm going to change the group as well. So change group ifsol to messages. And now you will see I should be able to read this file. So I could have assigned the read permissions right here with chmod, or I just have given the ownership. I changed the ownership to ifsol. So now I could exit out of root. Now which directory I'm in? I am in /home ifsol, and I'm going to go into my professional scripts directory, ls-ltr, and there it has the messages file. Now to make sure I could read it, I could just simply cat the messages file just to make sure I could read it. Yes, I could read that. Let's clear the screen. Now I'm going to create a first script. I'm going to call pull data. If you are using different scripting as well, I'll put .bash here. I'll just leave pull data. Hit enter. Now what do you do first thing? You give the correct shell script. Sorry, the shell, which has been bash. Next, you put the author. Date 08/08/2020. Description. This script will pull only error messages from var log messages. You could directly pull those messages, but you have to be root. But since we are not root, it's just an example that I'm giving. We copied the messages file in our local in our home directory. And modified. If it is modified, since we're creating for the first time, we'll leave the same date. Okay, so our basic things are done. Shell is defined. The comments are defined. Now, what are exactly we doing? We wanted to pull only error messages from the messages file. We don't want to view anything. So to do that, we'll have to do grep, because we are grepping for error messages. -I is to ignore lowercase or uppercase error. From where? I would always specify the absolute path. You don't want to specify the relative path, because if you're running from another directory, the same script will fail. IFSol professional scripts. So for now, just run that and just make sure if it works. So controls right quick, enter. Now the next thing you have to do is give executable permission to pull data, ls-ltr, and you'll see our first script is created. So when I run that pull data, it says grep home ifsol is a directory, because we did not specify the file. We need to go in one step inside. So pull data, and we are actually trying to grep for errors from directory. So of course there is no such thing as a directory doesn't have the data. Directory only has files. So we'll put messages here. Okay. Now when we run this script, it is giving us only the error messages, all the lines inside of that varlog messaging file. I'm only getting the error messages. Now you're probably thinking, why do I need just error messages? Well, if you are in corporate environment, trust me, you're gonna be troubleshooting system-related, application-related so many times that you would have to go into the log files and look for error messages that where it failed. So you could go through one line by line by line, which is going to take you forever, or you could just simply filter out for error messages, and then you will get right to the point that why and how it is failing. Now there are some failed messages right here. Of course, we are not troubleshooting these failed messages, but it's just an example that I'm giving. Now, every time you come in, you log into your system, your manager or your someone from the development team or someone will say, hey, I'm getting error message from this system, or system is running slow, or this application is failing or something. So you just, all you have to do is run the script and see what are those error messages for. So what I will do at this point, I will, instead of do pull data, I will rename this file to move pull data to pull errors. So this way it is specific to the data or the words that we are trying to pull. So let's run again, pull errors, and now we have all the errors. Similarly, if you want to pull all the warning messages, we could do the same thing, but instead of recreating a new script, what I will do is I'll copy pull data, pull errors, and I'll name it pull warning. So now I have two scripts. One is pull errors and the other one is pull warnings, but now both are same. So I have to go into the pull warn script, and I'll have to, instead of error, I'll put in warn. Okay, now save it. Now let's run pull warn now, and you see we have a lot of warning signs in the system. What's going on? See right here is warning application, genome settings killed by Signal 5, or any of the things that happen with your application or your system, it will be logged here. Now the last one I will do is, let's copy it again, pull warn. I will do pull now fail. Okay, now I'll go into fail script again, and instead of warn, I'll just do fail. Now I have 3 scripts to verify it. There you go. The last one is pull fail. So let's run pull fail. And now it's only giving me failed related lines. Anything that has fail in the line, I will only get that. Now you could also leave it as is right now if you want to, but most of the time what people do is they output this to another file. So this way they could easily manipulate the text inside of that file instead of just going into the var log messages. So how that is done, you could just, let's go back to our first script, which is pull error. And here I will go grep -I error, and I will output to my home directory. And this is the directory. And now I will name the output of the script as output error. If you notice, I have 2 slashes here, so I'm going to get rid of 1. So now let's run it. Now this time when you run it, it is not going to show you all those error messages on the screen. Instead, it is going to push out all the messages that came with the word error. It's going to go into a file that we just specified. So let's run pull error. And you see you got your prompt back. So it doesn't mean it didn't run. It did run. But it has created a file that you wanted to create. There you go. See, output error. So now you could just simply cat out this output error file and read through it. The same way you could do it with fail. The same way you could do with warning if you want to. Now, also what happened is, which I will also cover later on, that many system administrators, what they do is they schedule this type of scripts in cron job. They tell the cron job, run the script at certain time of the day, and when you come in, all you have to do is view that file. That's one step further. Now, if you want to take it another step further, what it will do is it will not only run the script, it will also send the output of the script, which is the output-error file, through your email, through the send mail protocol, which is one of the best ways you could do that. When you come into your office in the morning, and the first thing you do, you open up your email and you say, hey, I got these emails and alerts that's saying I had these type of error messages. So this is about creating or pulling data from files. You could also modify it in terms of, if you wanted to just see the number of warnings, you could just do pull warning. So you see when you run it, you get all those messages. Now you could use your own script and combine it with operating system commands to view or to change the output of the script. So if you wanted to see how many warning messages or lines we have when we grep for warning, you could just do pipe wc -l. And you'll see there are a total of 46 warning messages. This shows that since we have the system, we have 46 warning messages that came in. You could be more specific. So if you wanted to just do grep and code, and you just wanted to do August 27th, then it will only pull August 27th warning messages. And how many we have for August 27th? We have 46. So basically all those messages that have came in today. Anyway, so this is how you pull the data. This is how you modify. The second script I wanted to go over is a script that will format the output of the administrative commands. Let's do the administrative commands. First, I'm going to create a new script called admin commands. and hit enter. And I will go through again because this is something that you really need to know. Author, date, description of the script, format the output of admin commands, and the last one is modified. Please don't get annoyed by this because I'm keep typing that. The reason I do that is because I really want you to get in the habit of doing that. This shows that you are an organized engineer or administrator who actually organized his or her scripts and put all the scripts in the right way. So 2020. Okay, now what are the commands that we want to do? Let's do some administrative commands like date, uptime, and df-h. So let's say if I wanted to do that, and let's say we run it. Before we run it, we have to give executable permissions. And now when we run it, you'll see I have the date right here, the uptime, and the df-k. Now when I mean to format the output, you could do that by either you run the script and format it in a way like, let's say if you only wanted to view the first column of your script, then you will only see like Monday, the date of the uptime and file systems are. That's if you want to change the format after you run the script. Or you could go into the script. The script is vi admin commands, and you could go into date, and you could do awk print $1. Uptime, you could do awk print let's say $3. And for the df-h, we'll just script for root. So this is how we change the output of the command. So now when we run it, you'll see the first column, it gave us Monday, the second column is the date, and the third is df-h. I just wanted to know only the root partition, how much disk space I have, how much I have left. I don't care for other file system. So this is how you could make changes to it. Same way, there are so many commands that we learned earlier. If you wanted to change the admin commands and you wanted to format it, you could try it with different commands. And this is how basically we could access the data from a file. Hey everyone, here is another newer script that we will go over. It's about checking the other server connectivity. Of course, you need to know all the time, if you are in a bigger environment, you need to know if your other servers are actually reachable and pingable. Now, I know there are a lot of monitoring solutions that are out there that a lot of companies have. They actually, those are monitor the servers, they monitor the health check and everything. But still, once in a while, you do need to actually ping other servers or remote servers that actually tells you if they are alive or they are down. So this lesson is about pinging other servers. What we're going to do is we actually going to create a script to check the status of the remote host or host, and we'll find out if it is pingable or not. Very simple script. We actually have to combine in this script. We have to combine if else statements. We will have to actually combine do while statement together, and you will see how we could ping other servers. I have my Linux machine open. And I also have a quick document here, you could say a cheat sheet, which already I have a script written there, because if I go over completely blank with you, I might forget and I might lose time, and I definitely don't want to do that. I definitely don't want to lose my time and your time. So anyway, the first thing I wanted to do is I do want to mention one thing that previously we actually created a directory called professional scripts. Now I noticed this whole directory is a very long directory. Let's make it short. So this way it will be easier to actually change directory from one place to another. So I'm going to just do move professional directory scripts to PS. Just simple as that. Now you'll see I have a directory called PS. When I go to PS, which stands for professional scripts, and now I have all my scripts. So just to start off with that, now let's start creating our first script that is going to ping an IP address. Now the IP address that I have selected is the IP address of my home modem, which is 192.168.1.1. And most likely, if you are in a home environment, not in the office, then your IP address is the same as 192.168.1.1. If it is not the same, then you could go find out the default gateway IP just to test if you could ping it or not. Or you could just ping, or you could just pick any IP that you could test your script against. So I have picked 192.168.1.1. This is my IP that I'm going to test. So let's first create a script, and I'm going to call the script ping script. Okay, and this is the first time I will copy later on, so I'm just going to quickly do the information. Date, description. This script will ping a remote host and notify, of course. Then modified, and since this is the first time, and I am going to leave that date as. Okay, now let's get into the real work. Now we define the variable. Now ping. I'm sure you guys know what ping script is. Ping goes out on the remote host, ping an IP address, and tell you if a host is available or not. So let me just write and quit out of this script. Make sure you save it. And just if you don't know ping, then just type ping 192.168.1.1, and you will see you are getting 64 byte back from this machine. It means there is a machine out there with that IP address, and it is reachable. Anyway, so now let's go back to our script. So what we are trying to do with the script is we want to ping. -C is count. Just ping once. The IP 192.168.1.1. Now, as you go along, you're probably thinking, hey, how come Imran knows all those different options to specify? How can he remembers? How can he just pick really quick? Well, to be honest, I don't remember. There are many times I just go online, I Google it, and I get the options. So if I want to Google ping only once, I'll type ping only once in shell script, or ping only once a remote host, and it will give me the option that I'm looking for. So don't worry about it. You're not the one that you're thinking, hey, my memory sucks, I'm not going to remember that. Trust me, my memory is probably worse than yours. So don't worry about it. If you forget anything, go online and search for it, and you will get it as long as you type exactly what you're looking for. All right, moving forward. So we are pinging this IP. All right, it will ping. It will ping one time. Perfect. Now what will happen? What are you trying to do when it pings? Okay, we are trying to say is if single bracket $? Now what is a $? $? is the output of all the command that you run. By default, the $? Returns two values. One is 0, which is that yes, it ran successfully, or anything else. So these are the exit status. If you don't know the differences between exit status, you could look it up, but there are mostly two exit status that I usually rely on: exit status 1 and 0. So $? If the return of my command above, which is ping -C1, the IP address, is equal to 0. Okay, you see, if the return value is equal to 0, which means it did run, it was successful, then since we are in if-else then statements, we have to specify then tab. As I said previously, always put tab so it will look neat and clean. Then what do you want to do? That, you know, the ping is successful, the host is reachable. Then what do you want to do? Well, simply say, okay, how's that? Just that simple. All right, perfect. Now, what if you don't get the 0 status, which is it can't ping it? Then what do you want to do? Then is what else? If that doesn't work, then what else? Else, echo, not okay, right? So if, do this, else, do that. Okay, perfect. Now, every time you start if, you have to end it with fee. And that's pretty much it. Save your script, give executable permissions to your script, and now run the script. Let's create a screen and now run the script. Perfect. You see, it ran, and it ran one time, and it came back. It was successful. Statistics came back, one packet transmitted. This is all part of ping script. So we came back, the exit status was 0, which means it ran, and that's why I said, and that's why the script said it was okay. Perfect. Now what if I give an IP address? So I'll change my IP address right here. I have specified right here again. I'm going to change the IP address to 192.168.1.235. Now, how do I get that IP address? I just pinged some of the IP address in my home network. I'm sure if you're in a home network, your IP addresses are probably used from 2 to like 15 or 20 at least, because we have so many gadgets at home. But it's very highly unlikely that you're probably going to be at 235 IPs. So what I did is, before I picked that IP, I just simply pinged that IP. Okay. So you see, I pinged that IP, and that IP is not reachable. So that's why I just picked that IP. You could pick any IP that is not pingable either. So I'm going to go back into my script, and this time I'm going to change the IP to, instead of 1.1, I'm going to change it to 235 and save it. And now when I run it, what should I get? It can't ping it, right? And it's going to come back and it's going to say, not okay. See, that's how the if-else script works. And to ping other hosts, other devices, that is something that you will definitely will be working on. I'm sure if you are in system administrator or engineer or any kind of role, you probably will have to do that. Now, next one is, if you notice right here, I have this output coming in. That output, it's going to give me that it ping, and then it will give me the not okay. Now, what if I'm just concerned that don't show me anything, just tell me if it is okay and if it's not okay. So what do we do here? As I have written down here, you could output, because right here when you do ping, it output to the screen. If you do not want that to be output on the screen, then there is this syntax that you have to specify. It says ampersand, greater than sign, and dev null. It means that you are outputting it to a dev null. Dev null is just a file in Linux. It's a null file. Every time you throw anything on dev null, it will just disappear. That's how it is. And I'm very hopeful you probably heard of that as well. So I'm going to go back into my ping script. And this time, I am going to tell it that, you know what? Don't throw the messages on the screen. I don't care about the message. All I care about is what is the outcome. Is it okay or is it not okay? Now I will run it. Now if you see, now let me clear the screen so you will see it will come up very nice and neat and clean. See, it's not throwing all those messages. All I'm going to get is not okay. That's what I care about. So many times you don't really want to see all that junk on the screen, because that will not only confuse you, but it'll take your time to actually read through it and what exactly you're looking for. So if I change the IP back to 1, then I should get okay, simply and straightforward. Just okay. Perfect. Now, next thing I wanted to cover is, what if you wanted to define that IP in a variable? Meaning, you put that IP in front of a variable. So instead of just pinging the straight IP, you ping the variable. Why do I do that? Because many times you do want to add multiple hosts, or certain things that you want to you probably want to ping multiple times. Then you don't want to specify IP again and again and again. You just specify one time and then let the host do itself. So I'm going to go back into ping script, and now I'm going to put in variable right here. And variable I'm going to do is host equal sign code 192.168.1.1 code close. That's my variable. Now instead of ping the IP, what I'm going to say is ping the host and $host. Right? And this time I'm going to make my script a little fancier. I'm going to say if ping this host, which is this variable, and output to a dev null. If the output is successful, then okay. Instead of just okay, I'm going to say host, the IP is okay, And else, if that IP is not pingable, then host is not okay. You see, I used my variable so efficiently. Now I used it in three different places. I don't have to specify IP here. Sorry, IP here. I don't have to specify IP here. I don't have to specify IP here. I have specified the IP just one time as a variable right here. And now I'm just going to use that variable or that container, and I'm going to use it again and again and again. Okay, so let's run it. Nice, right? IP that I'm trying to ping is okay. So now it's very specific. It's telling me that this is the IP that you're trying to ping, and it is okay not to worry about it. Now, what if I change the IP to 235, which is, of course, one of my IP that is not pingable, that is not assigned. And now let's clear the screen so we can see better. Ping script. It's going to ping. And the reason it takes a little longer because sometimes ping just waits for it to respond. It's by default, it just waits for it. Anyway, so you see it came back. It says 192.168.1.235 is not okay. Perfect. See how we actually make the use of variable here, and we use if and else statements, and we are putting the variables in place. Okay, now next one is changing IP. We already did that. Perfect. Now the next one is a little complicated one, but it's easy if you do it together. Okay, now what if you wanted to ping multiple IP addresses in one script? Okay, one IP, I could ping it, right? I don't even have to create a script to ping that. Right, I understand. You're probably thinking that, but the reason we start off with one IP is so you would understand. What if you wanted to ping 100 servers? Now things get interesting. Now you really need to have that script, right? Okay. So first of all, what you need to do is you need to put that IP addresses that you want to ping to a file. So I'm going to create a file, and I'm going to call it my host. And I'm going to put in the IP address of 192.168.1.1. And the second one, I'm going to put it 192.168.1.235. So now since we are working on only two IPs, if you have multiple IPs, you want to try it, please go ahead. Now save. Now this is just an empty file. Sorry, this is just a flat file. And let's do my host. And you'll see it has two IP address. Now instead of changing the existing script, I am going to create a new script. And of course, I'm not going to create a new script from scratch. What I'm going to do is changing the existing script, I am going to create a new script. And of course, I'm not going to create a new script from scratch. What I'm going to do is I'm going to just copy my ping script, and I'm going to name it ping script-all. So this way it will identify that this is for all multiple Linux servers or multiple hosts. Okay, now vi ping script-all. You see everything here is done, but I just have to change the description. It says this script will ping a remote host, not a remote host, multiple remote hosts. Make sure you change this description. It's very important. Okay, now we're going to come in, and what I'm going to do is I'm going to simply, you know what, let's first get rid of this variable host. I'm going to start it from here. What are those hosts? So this is the variable, and variable is what? You have to specify the location of your file. So that is /home I of Sol /PS, PS for professional scripts. Remember we did that? And what was the name we picked for the flat file? Was it host? I'm not sure actually. Let me go check. So please make sure this location and this host file is correct. Otherwise, the script is going to complain. No, I specified my host, and it is home IFL PS directory. My host. Okay, perfect. So now here is the location of the file that has all my multiple hosts. Okay, perfect. Now I wanted to use for loop for that. Why? Because for loop allows you to go through the script once, twice, or as many times until everything is being read or everything is been satisfied. So if I don't specify for loop, what will happen is it will pick the first IP in the list and it will be done. It's not going to go through the second IP. That's why we have to specify for loop for IP. Now, why I picked IP? IP is just a container again. It's just a variable. You could just pick anything. For IP in and $ parentheses in where? Cat specify $host. Okay, now you see what I did for IP. I'm creating a container, another container IP in, and I'm catting this etc host file. Sorry, not etc host file. I'm catting this $host files. What is $host file? $host file is this home ifzol ps my host. So this is what I'm telling for IP in, put everything that comes from this result cat host, put everything in IP. All right, perfect. I will do that. Now, what else do you want me to do? Now, do, because you have to specify what exactly. Once you do, for always has to have a do. For, do, done. For, while, do. Okay, so for, okay. Now, what do you want me to do? I'm going to do is I'm going to move this one tab over, and I'm going to say ping C1, same thing. And now instead of host, I want to do IP, because right here, it says IP, right? This is the container. I'm specifying it right here. Now you're probably thinking, hey, Imran, why can't I just use the same variable? That's a good question. I don't know. Try it. Maybe it works. But this is how I actually go through my practice. And if you wanted to try it, please be my guest. Try it. If it works, perfect. All right, so IP. Okay. Going into dev null. Now coming back to our same script. If pound dollar question mark equals 0, then instead of host, now you're talking about IP. IP is, I put it there, ping pass. I'll just leave it as is. IP is okay. And the same thing here. IP is not okay. So by the way, this file that I'm looking at it, I will attach that file with this lesson. So you don't have to worry about it. You could also copy paste if you make a mistake. Sometimes when you're writing a script, many times I would say even 80% or 85% of times you make mistakes. I make mistakes too. That's why I try to write it so there won't be any mistakes. Okay, so this is how it's going to do again. So hopefully you understand what I'm trying to get at. This is the variable, and what variable is going to do, it's going to specify the name of the file. Okay, now for IP, this is another variable, and it's saying that, you know what, go and read that file, cat that file. And that file is etc just $host. I don't know why I keep saying etc host. It's just so used to it saying etc host. Anyway, okay, do ping that whatever is inside of cat host, and to go through the same scenario. Now, another thing, don't forget at the bottom, when you have do, what do you have to have? Done. Same thing if you have fee, you have to have, sorry, if you have if, you have to have fee. If you have do, you have to have done. All right, perfect. Now let's run it. Let's verify we have it. Okay, we do. Ping script all. Hit enter. 192.168.1.1 is okay, and 192.168.1.235 is not okay. You see how it works? So that's how you could actually create a script that will have a multiple IP address or multiple host name and that you wanted to ping. And of course, if you wanted to run this script at a cron job, you could try that, but we'll cover that later as well. So just focus on this one and try it. And if you could seriously try to do a cron job that will automatically run at a certain time, try it. It will work. All right, good luck. Script schedules and notifications. Now we have a few scripts that we already run. Those are useful, valuable scripts. Now we need to schedule them. And how do we need to schedule them? You schedule them through the cron job. A cron job is a process and an automated service in Linux or in Unix flavors that you could specify scripts to run at a certain time. And then we could notify the users or administrators or engineers through the email that this script ran, and here is the output of the script. So this is something that you probably already been doing, or you might have to do when you are in corporate environment. When you create shell scripts, then you need to make it more automated. What I mean is more automated, meaning you automated a script to perform certain tasks, right? Now you go one step further, which is to schedule it so you don't have to run it yourself. Okay, that's a second step of automation. The third step of automation is is that once it runs it, what do you want it to do? Well, you want it to either have a file created or do something, or you could just the script could just notify, or cron job could just notify the system administrator. So this is a few steps that we will take. We will use this lessons based on our previous created scripts. So I'll log into my Linux machine right here, and I am logged in as myself. And which directory I'm in? I'm in my professional scripts directory, and the script that I will use to schedule is ping script all. So when you run the script, it actually pings an IP address that is pingable. It will say okay. If it's not pingable, it will say it is not okay. Now you could run the script and view that result on the screen, right? But if you want to schedule it so it will run itself and it notify you, you have to specify that in the cron job. So first, make sure you have the complete path. PS ping script dash all. Okay, so this is a complete path. Copy it so you don't make any mistake while you are creating a cron job. Now type cron. Before you type cron, type date so you will know what time you want to run. At this time, it is 2031. I will schedule it for 2034, for example. So if I do cron tab -E is to edit. So the first field of cron, and I'm sure you are familiar with it, is the minute. So I want to pick the minute 34, and the hour is 20. And the day of the month, I want to run it every day. Month of the year, every year. And day of the week, every day of the week. And now the command. So hit right click, and it will paste your script. So it will paste it. Now, how do you know it ran? You could just output to script ping output. So this is the output from the script that will run, and the reason I'm putting ping dash output, so this way you will know that the script did run. So let's save that cron. It's 2034. That's the time it'll run. What time is it right now? 2032. So we actually have to wait 1 minute, and now it's 2033. So in 1 minute the script will run. So you will see we have a file name called output-error. So don't confuse with this one. The file that will come in will be output, what was it, tab-L, output, the ping-output. So this is the file that will spit out my script, and the different variables are specified. Now, as we wait for the script to run, the next thing that I will cover is about the notification. Now, how do we notify a user through the email? Well, you could actually take that file that will be created, which is ping-output. You could take that file and send it to the user, right? You could do that, but then you have to cat the file and send it. But how about we just simply, instead of going into ping-output file, we'll just specify the name, or sorry, the email address of the user that is going to. So that's what we will do on the second step. So let's check again. What time is it right now? It's 2034. So the script has already ran. Let's confirm. And it did not output. The output is ping output. Ping output. Where did it? I think it's probably putting it into my home directory. That's probably it. So the ls-l home IFSol ping output. Yes, see, that's why. If I wanted to have this output file to be in the exact same location where my script is, then I have to specify the full path, the absolute path. But since I did not specify it, by default, it will put into the user's home directory, which is home IFSol. So now, anyway, let's go one step back. This is my home directory. Let's check, and that the file is ping-output. And you see it is there. 192.168.1.1 is okay and is not okay. Anyway, so that's how you could schedule your scripts, and it becomes so much easier when you actually rely on cron tabs. Now, next one is the notification. As I said, you could cat out the file and send it over to another cron, but why you want to do another cron? So what you would do is you go back to your cron tab, -E, and now instead of running it to ping output, what you could do is you could pipe it and do mail -S for subject, connectivity status. This is going to be a subject. And where is it going? It's going to my email. And that's pretty much it. So if I schedule this for a time that is right now or 2 minutes from now, it will run, but it is not going to email me. Why? Because the email relay server is not configured in my server. So if you already have email configured in your Linux machine and it is able to send out emails outside of your environment, then it will work, definitely work. But in my case, it's not going to work. It's just the example that I'm showing you. This is how you could notify the user. So try it at home. Try to schedule different scripts that we already created in the previous lessons and see how it works. You could also output to a file just to confirm it works. Now I'll just save it and exit out. Now let's talk about another script to delete old files. Now this is a definite script that everyone might have experienced or will be experiencing if you are becoming a system administrator or becoming a Linux or taking over a Linux job. So you have a system, and as you know, this, when you build a system, so many people log in, so many program runs, so many logs get created. As the system ages, over time, it creates a lot of files. When a lot of files are created, there is no mechanism inside unless you enable a couple of other services to delete older files. So what happens if you don't delete those old files? Well, it will fill up your disk space. And once the disk space is full, your system will become unresponsive. So it is very important for all the system engineers or administrators to actually keep an eye on all the old files and that are no longer in use. So in this lesson, what we're going to do is we're going to create a script from scratch that will delete all the files for a specified number of days or years or whichever that is being specified in the script. And what we're going to do actually, first we're going to create files with older timestamp, because in my system is fairly new, and most likely the system you are working on is also new. So maybe you don't have older files, so you would have to create files with the older timestamp. So we could try out our newer script. Then we're going to find and delete those files that are older than 90 days. Why pick 90 days? It doesn't really matter. You could pick 100 days, 80 days, whichever days that you like. But in a general standard is that most of the time people want to get rid of all the files older than 3 months. And then we're going to find another way or another script which will find and rename old files. So if instead of deleting it, what you could do is you could find older files, let's say older than 90 days, and instead of deleting it, how can we just rename it and rename it like a .old or .archive or whatever that you want to rename. So you need a script for that too. So these are the type of scripts that we'll work on in this lesson. I will go straight into my Linux machine. Okay, I have it open through my PuTTY session. I am logged in as myself, and I am in home IAPSOL PS directory. PS directory is something that I previously created, stands for professional scripts. Anyway, you could pick any directory as I mentioned earlier. So now we are in this directory, and when you do ls-ltr, you'll notice that I do not have any file older than August 27th, which is not 3 months old. So for me to test my script on older files, I would have to create some files that will with older timestamps. Well, can you do it? Yes, you could do it. You could do it with a touch command, and the format for that is touch with -d option, and you specify the time. Let's say Thursday, comma 1st March 2018, 12:30 a.m. and create a file called, let's call it A. Okay, so now the file is created. Let's verify it if it is created with the older timestamp. Yes, you see I did ls-ltr, and this option with ls-ltr, it will give me all my files in the timely order. So the most recent one is created at the bottom, and the oldest one is at the top. So if you see the top one is this one, it is created on March 1st. So March 1st is a lot older. I created that. So now I want to create, just like that, I want to create other files as well. So I'll create B, I'll create C, I'll create D. I'll create 4 files. So this way, when I run the script, it will find all these commands, all these files, and execute it. Now let's create our script to delete it. So first thing is to find it. First of all, every time you need to create a script, it's better that you run that command so it will work in the script. So do find path to where you're finding it. So I'm going to find it in this path, which is right here. So find in this path with time, modify time, plus 90. And then once it finds them, then what you want to do, you want to execute a command. And I just wanted to see the listing of it. So I'll do ls minus l of what returns. And what is returned is specified with curly braces, open curly braces, close, space, backslash, and colon. This is just a standard way to find files. It's not something fancy that is only written in script. It's just a simple command. Even you search online, you will find the exact same commands. So once I run this command, you'll see I will find all the files that are created 3 months ago. And you see it found 4 files, right? Perfect. So now I will create a script that will do exactly the same thing, and I don't have to actually run it manually. I'll just cron tab that job, and it will run on a schedule basis. So if I do vi and I will put delete old files. This is the name of my script. I'll hit enter, and you know here what you need to do is bin bash and author Imran Afzal, date 08/08/2020. Description, very important. This script will delete delete files older than 90 days. Perfect. Modified. Do we need to worry about it? Not really at this time because we're creating for the first time. Okay, perfect. Now this is the description and the shell that's defined. I'm going to right click, which I copied that same exact file earlier. And now just save it. Give executable permission to my script, which is delete all files. Let's check. Yes, the file is there. Now when I run it, delete all file, and you'll see it is giving me all the old files. Now I want to delete them. So to delete them, you vi the script again, and instead of execute ls, you just do rm, delete those files that are returned. So now when I run it, delete all files, and it gave me my prompt back. It means it ran. So when you do ls-ltr, you'll see all those files that I had earlier, A, B, C, D, E, all of them are gone. All right? So that's how you create a script that will delete all files. Now, what if you just wanted to rename it? Let's try the same script. And this time, I'm just going to say move, delete all files to rename all files. So now it has renamed, so I'm going to change it to rename all files. And this time what I'm going to do is once those files are found, I want to move whatever is returned to return name .old. So this is going to find and move whatever it find to the name of the find with .old extension. You copy and paste. Now first, before I run it, I want to create those files that I created earlier. So I'm going to hit up arrow key, because up arrow key remembers all the commands that I ran previously. Okay, so this is the one, D, C, B, and A. Let's verify it. Let's do ls-ltr, and you'll see all the files are there. Now, when I run this updated script, it should update the name of these files from D to D.old, C.old, B.old, and A.old. Let's do rename all files. And it ran. Let's verify it. You see? A, B, C, D.old. So this is about the script. Again, it's an everyday script that you're going to be using it. It's a real life example script. You need to know that. You need to know how to delete all files or rename it or whatever that you're trying to do with the files. It will do it for you. So try it out yourself. I am going to include the instructions that we just followed in the lecture's text in the same lesson. You'll find it. You could copy paste or you could start from scratch. Okay, so now in this lesson, we are going to write a script that will back up our file system. Very important script. If you do not have a backup product or backup application or backup solution in your environment, most of the time, smaller companies do not have the backup third-party application that does the backup for them. So what do they have to do is they have to rely on this operating system tools that are available to do the backup and run those backups manually by creating little script. If you're in a bigger company, you have a backup, perfect. You probably don't have to worry about it, but I would still say that sometimes you do have to tar a file to do the backup if you are making certain changes for certain times. Anyway, let's go into the lesson. And in this lesson, we are going to back up our /etc and var directories using the tar command. Okay, why am I picking /etc and var directories? Two reasons. One, these are the most important directories in a Linux system environment, which is /etc that has all the configuration files, and var that has all your Apache and logging information if you need to go back and troubleshoot. Same thing if you need to go back if something has changed in your etc directory, configuration has changed, and your application has stopped working, you could go back and restore it from your backed up etc directory. That's one reason. Second reason is I'm just picking these up. You could actually pick up any directory that you want for your test purposes. So I am picking these up as just for my lesson to go over to make you understand. So we will create the backup of these two directories by using the command tar. I'm sure you're familiar with it. Then what we're going to do is we're going to compress the backup file, which is the tar file now, using the gzip command. So compress is actually going to reduce the size of the tar file. Then what we're going to do, of course, then we're going to write a script to automate the entire process. And we're going to put some logic, some intelligence inside of the script that will look for the backup file first before it's actually move it somewhere, send it to someone, or send an email that the backup is complete or anything. So we will put that logic in there. So let's go into a Linux machine. I have logged in again as myself. And which directory I'm in? I'm in my home directory. Now, since we are going to back up the /etc and var directory, these are the directories that are owned by root. So me being myself, I don't have permissions to do the backups or even touch those directories. So what do I have to do is I have to become root. Perfect. Who am I? You confirm that. I am root. Now I'm very powerful. I could do anything I want. So the command, first of all, before you write a script, always run your command to make sure that command works before you actually put that command inside of your script. So I'm going to do the same thing. I'm going to do tar cvf. It's just the option for the tar to actually put everything off, let's say etc or tar, and then you have to specify the name of the destination file, which is backup.tar. And what are we backing up? We're backing up etc and /var. So that's simple command to tar both of these directories and put them into backup.tar file, which will go into /temp directory. Let's run it. As you can see, it's coming up with all those files and it looks perfect. It actually taking every file in etc and every file or directory in var and tarring it together in a tar ball, and it will put into the file that we have specified, which is backup.tar. Okay, so it should be done pretty soon. My system is small. It's not huge, but if your system that you're working on is pretty big and has gigs of file system partition in etc and var, then it's probably going to take a little longer. So anyway, we'll give it a few seconds. Oh, there you go. See, it's done. It's a matter of conversation that I was having with you, and it's done. Now, let's verify it if it actually has created the file in where we define the location temp, right? and the file was backup. Right? I hit tab and it automatically completed because it knows there's a file there. Hit enter, and now you'll see the date, the time the file was created, and it is there. Perfect. It has everything. Now, if you wanted to view what's inside the file, you could view that by untarring it, or you could use the option tar TDF, which will not untar it. It'll just show you what's inside of it. Anyway, our focus is not the tar or compress command. Our focus is to write a script that will run those commands, right? So now we know that it works. Next thing we have to do is we have to compress it. So gzip temp backup. You'll see the size of my /etc and /var is this much, and when I do the gzip, it will reduce the size. Most likely it should bring it down to about half of its size, and once it's completed, it will actually change the extension from backup.tar to backup.tar.gzip, and of course it will have a lot smaller size. All right, hopefully it should be done soon. If you are doing with me while I am teaching you, that would be a great exercise to actually tar your files and to compress your files. By the way, if it is taking a really long time, you could actually open up another terminal. I'll show you. This is a good exercise as well. Log in. This time log in as root because you're running as root. Okay, now go to temp directory and do ls-ltr on backup asterisk. And you will see both files. One is backup.tar and the other one is backup.tar.gz. Now, since our command is still running, it means this size is going to change if I run that command again. You see, it's keep reducing, keep shrinking the file. Okay, anyway, if you look at the back window, you will see the command is finished successfully, and both of our commands that we wanted to include in our script ran successfully, and even if the script will run it, we know it's not going to error out or it's not going to complain. Now the time to actually create our backup script. So we'll call it backup file system. You could pick any name you want, of course. Hit enter. Now you have to specify the shell. Bin bash. Again, who's the author? I'm the author. In your case, you're the author. Okay, date 08/08/2020. Why am I picking 08/08 all the time? Is this something, someone's birthday, or is it something important? No, it's just something I'm picking. It's just stuck in my mind, so I keep on picking on that. But anyway, description is backup /etc and /var file system. That's it. Description is important. Modified, it's the first time, so we'll leave the same date. All right, now we have to put the same command that we ran, which is tar cvf temp backup.tar /etc/var. Then what are you going to do? We're going to compress it. Gzip backup.tar, right? Now you're probably thinking, hey Imran, maybe when it runs, the script runs all the time, it does the backup.tar file, and the file already exists. It's going to overwrite the older file, right? Yes, you're right. It will overwrite. If you want to have a different name every time it creates it, you could do that by specifying the date variable. Again, I'm not going to go into it. It's going to get very longer, but you could definitely do that. Now, get into our backups. Now, the first thing I have to do is find backup.tar.gz. Before it's actually going to run the script, I have to actually, when it runs the script and creates it, I have to do something with that. I have to notify the system administrator, or I have to actually copy that backup and put it somewhere. So in case if this system or the server I'm working on, if it actually crashes, then I could actually recover it from another server. So it's always a good idea to transfer it anywhere. So this is the time I'm actually doing that third step. So before I do the third step, I have to verify if that actual file that I'm going to transfer exists. So, and that would be, I'm saying that find backup.tar m time, and if it exists, -1, meaning if it was created today, not yesterday. I don't want to send yesterday's backup.tar file. Type f print and then ampersand dev null. Basically, I'm saying if it is exist m time this, which is the type is the file, simple file, then print. I don't have to put that print. It's going to put it on the screen, but you know, it's just a command that I have. I'm going to leave it. And I'm saying ampersand greater sign, meaning whatever the output comes out from here, don't throw it on the screen. Just put it on dev null. Dev null is just a way to flush out the output. But it doesn't mean that we are flushing out the actual output and we're not going to use it. We actually will use it, but it's not going to throw that on the screen. So now what we're going to do is if $? Is equal to 0. Now what is $? It's exit status. So if the command that ran earlier than that, which is this, so what we are saying is if we find a backup.tar.gz which was created today, and that's where we define, and their exit status is 0, which is it's there, then let me put then right here. Then what do you want to do? Echo backup was created. Perfect, right? Echo, just put one more line in. Echo another. And now say archiving backup, because archiving meaning you are sending it to another location, and the another location would be you have to run the command like FTP or SCP or whatever the command that you're running. So run scp/temp/backup.tar, which is the file, to where? So to root anywhere your server that you want to send it to, 192.168.1.1 or 2 or X, whatever, and then the path where it's going to go to, and then do else if it cannot find it. Now else is if the output is not equal to 1, then what do you want to do? Else echo backup failed. Simple as that. And then just do if. So this is the script to actually back up the file system and actually transferring that file, the backup.tar file, to another location. Now, since we are testing it and this is like a training lab, I just wanted to exclude this. I put hash here because what hash is going to do is going to comment out this entire line. So now when I'm going to run this script, what it's going to do is if this file, backup file exists, then it's going to say backup was created and archiving the backup. And if it does not exist, then it's going to say echo backup failed. Simple as that. I'm going to modify the permission executable to backup file system. Perfect. Now let's run it. All right. Moment of truth. You know what it's doing? It is backing up your file system. You see just what happened here? It came back and it says backup.tar file, no such file or directory. Why is that? Because let's see what our script is doing. Our script is first tarring and putting it right here. And then, see right here, I did not specify the /backup. So I'll do var backup fs. I have to let it know where that file is located. And the file is temp. So that's where you have to do it. Here you have to specify the absolute path again, because if you're running from somewhere else, it will complain. Now, it should run, but now I don't want it to run it. I want it to comment that out because we already have the backup.gz. Let's verify it. Temp backup.gz. Yes, we have it. So now let's run our script. And it says backup was created, archiving backup. Perfect. Now what if I delete that? Yes. Now I run the script. Backup failed. There you go. Bingo. Anyway, so that's how you need to create a backup. If you are in your environment, a corporate environment, you could back up the entire file system or specific file system that you want to do. And whatever that you want to do with it, you want to send an email notification or you want to send it to a different host, you could do that. Okay, it's about time now we start for loop scripts for file system. Well, we already learned for loops earlier, but now we are actually going to learn more smaller and bigger and advanced for loops as well. I am going to actually include multiple scripts here. This lesson is not about just one script and we'll move on. In this lesson, we are going to create simple counting for loop scripts. How you could use it. There are counting by 1 to 100 or whichever the specified number of times. We are going to create multiple files with different names. So if you want to create, let's say 10 files, are you going to do touch 1, touch 2, touch 3? No, right? You want to create a script that will create multiple files and of course with multiple different names. So that's what we're going to cover. Next, we're going to cover create multiple files with user input. So user will have to specify, it will be like, hey, do you want to create a file? Yes, and what's the name of the file? There's how many files do you want to create? I want to create 10 files. Wouldn't be that nice? Then we have to create another script like assign write permissions to files. We'll create another script that will assign write permission to files with total time it will take. So I am actually going to cover 5 different scripts in this lesson. And the reason I'm keep on focusing on for loop is one of the important statement for loop scripts that you will be using more often than any other statement scripts. Okay, without further ado, let's log into our Linux machine. We have our Linux machine right here. I'm going to clear the screen real quick. I'm going to exit out and I'm going to log into my other one, which is right here. Clear the screen. Who am I? I have Sol. This is my other session that was running. I don't want to have 2 different sessions open. This will do nothing but to confuse you more. Anyway, I am in my home directory and I want to go into my professional script directory that I created earlier. I have a few scripts that I worked on it earlier. You probably have it too if you're following me exactly every lesson one by one. Anyway, let's clear the screen out. The first thing I wanted to do is I wanted to create a simple counting script for the for loop. So what it does, let's first create the script, then you will know exactly what I'm talking about. Simple count. Again, what do we have to do, guys? So now I am trying to save you time. So I'm just going to leave this author date. So you could fill that up yourself, description, but please don't forget to do that. I am skipping it because I don't want to waste any more time on this. I want to get straight into scripting. All right, so everything is defined. So now for loop, I is just a variable in curly braces, 1 dot dot, let's say 20. Enter. Now what I'm saying is I want you to put all the counting from 1 to 20 into a variable called I. It's just that what I'm doing. So think of it, you have a can and you're putting 20 numbers from 1 to 20 in that can. So and that can name is I. You could name it anything. The can name is A, or just even you could even name it can as CAN can. So you could do that. Now, what do you want to do now? So you already put those 20 numbers in a can. What do you want to do? Again, it's a perfect example. So do. First is echo $I. So it is actually going to echo whatever is inside of the container. So I am actually boxing 20 numbers in a box. And then once I did that, then I want to open the box and read those numbers. That's pretty much it. And then I don't want to read all of them in one shot. I want to read one number at a time. It will read one number at a time, but it will read it so fast that it will look like as if it's reading all in one shot. So in order for me to verify that it is reading one at a time, I'm going to put a command inside called sleep1. Sleep1, what it's going to do is actually going to read one letter, sleep for 1 second, then read the second, the third, the fourth, the fifth. So I don't want to waste your time. I'll just put here 10. So we will just run the script for 10 seconds. It will sleep for 10 seconds. Oops. And right here is done. So I hope you understand this. For I in, there's a container I, put number 1 through 10. Then what you want to do once you have all the numbers in a box, then read those numbers for me, please. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. But I want you to sleep, like put a break in every number while you're reading it. And that break is only for 1 second. Okay. Okay, sir, we will do that. Perfect. And what do you want to do once I'm done? Then you're done. Don't worry about it. Okay. All right, let's go into our script, modify the permissions, simple count. Oops. Sorry. And as I mentioned earlier, that you could use numbering way to do the change mod, or this way. I prefer this way, so I use it that. Anyway, the permissions are done. Now let's run it. There you go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done. See, it's just that simple. Now, you're probably thinking, hey, Imran, what is the real-life application for this type of script? Okay, perfect example. You probably, perfect question, sorry. You probably installed a lot of softwares in your machine, right? If you are using Windows, you install software, it goes through a wizard. If you're running a Linux script, then you're installing something, it goes through some kind of little wizard. But then you also notice it gives you some kind of progress bar, right? That is where those people, those developers, put those progress bar by putting these counting in there. It does the counting. It tells you, okay, approximately it's going to take this much time, and that's how it does. Counting 1, 2, 3, 4, 5. So that's what it actually is. Why I have not put it in a real example, because I want you to go and find that out, how you could put that in a regular everyday example. Now going to other scripts, the other 4 scripts that I have, I'll show you exactly where I could put in other examples as well, but not just in installation wizard, but in something else. Second script now we are doing is we are going to create multiple files. Right here it says create multiple files with different names. By the way, these scripts that I'm typing, of course, I do not remember all of them on top of my head. I actually have them written in a notepad in another computer that is right sitting next to me. So I am not like, you can't say, oh, Imran is a genius, he remember every script on his head. I don't. I'm just like a regular person like you. So I have this notepad open on another computer, and I have that notepad attached to every lesson that you're going to do. So once you're going to play that lesson or this lesson, you will see an attachment .text file. I would like you to open the text file and then look at the text file and then create it, your script. Anyway, so let's create a second one, and I'm going to create that for multiple files. So vi create multiple files with different names. This is too confusing. Create files. Simple as that. Enter. Oops, I didn't put the insert in. All right, you know what goes here. So before I do that, the best way to do is, I just remember, I usually do that. So I'll copy simple count, which we created just before that, and I'm going to name it a different one, create files. All right, so now vi, so this way we'll have everything up there that we need. Just remove this part. Okay, now for I like I, so I keep picking on I. You could pick anything again. In curly braces 1 through 10. Okay, so now you know again, I'm putting 10 numbers in my box, right? So now you know that. Okay, now what do you want to do? This time I want to create files, and the file name should start with Imran. Perfect. And it should end with $I. Nice. So you see what I'm doing? It is going to create 10 files, and every file will have the name Imran.1, Imran.2, Imran.3, and all the way to Imran.10. See how easy it has become to create multiple files? Probably you would have to create 1,000 files. Then creating it manually, it's not productive at all. So that's how we use for loop commands. Anyway, moving forward, so I'm going to create 10 files with the name Imran, and then I want you to be done. Since I copied from simple count, it should have the executable permission as well. So create files, hit enter. Boom, it actually threw an error message right away. Perfect. I want you to have that experience as well, because you will be troubleshooting error messages while you are creating scripts as well. So anyway, it says unexpected end of file. This is EOF while looking for matching backtick and code. And it's line 7. So what I would do is I'll go straight into the file, create files, and I'll go into line 7 by putting colon 7, and it's coming right here. You see it has this thing tick. I don't want that tick. That's why I was giving that problem. Now save. Now let's run it, create files. Bingo. It came back. When you have a command that comes back and gives you a prompt back without throwing any error message, what it means, the script ran successfully. Now let's verify if it ran. Let's do ls-ltr, and you'll see right here it created 10 files. Awesome. Perfect. Okay, now let's move on to the next script. And next script, I'll just do copy, create files, and this time I'll do create files with input. Input. It stands for IP. I don't want to do this, so I will do in, out, in, out. vi create. You know what? I will change it. I don't want to confuse myself. In, out. Instead of that, I will do user input. Now create files dash user input. What I'm going to do here is first bash, and let's get rid of all of that. And now I want the user to tell me how many files they want. So this is the third script. It says right here, create multiple files with user input. So user, the script will ask users, how many files do you want to create? And it will say what's the name of the file that you want to create. So let's do that, echo. How many files do you want? And I want the script to read that response, and that is T for total. It's just how I picked it. Echo, just to put a empty line. Then I want to throw another question at the user, and I'm going to say, please enter the start name of the files. So the file name, if you want the file names to start with Imran, then please enter Imran. Read, and just a number, not number, just a variable. Now, for I, n, again, I is a variable. Now I want to put sequence here. So I put $ sequence 1 through T. Okay, so this is going to, what it's going to do is, this is going to put this variable, which is the sequence, inside the variable I. And the sequence is going to be the number of files. So the reason I'm putting sequence here, not 1 through, let's say, $T, you're probably thinking, hey, Imran, why didn't you pick, let's say, ... like this? This is something, if you think of that, then I would say you are right on the right track. But when you have to specify the variable, which is $T, then you cannot use one ... and the variable, because one ... only works with the number or integer. So in order for it to work, you have to put a new thing called sequence 1 through that variable, which is specified by the user. It's just, that's how it is. You know, so that's what some people says. It is what it is. Okay. Now that is done. Do what? Come on, my cursor is stuck, looks like. Oops. My network went down. I don't know why, but anyway, I am going to copy this so I don't lose my work. I'll go into my machine. I'll verify the IP, and you see the IP is gone. I don't know what happened, but anyway, I'll just restart my network. This is just a command to restart. You could just fast forward it if you don't want it to know. I'll just log back into my PuTTY session once the session comes back up. Now it has restarted. Now let's see if I got an IP. Yes, I got an IP. So now I'm just gonna do right here, restart session. It has restarted. Okay, so now I'm gonna go back into my PS directory and my script that I was working on. Oh, it says found a swap file name this because I lost my session and it still has that .swap file open. So it says read only, edit anyway, recover, quit, and abort. I'll say recover and enter. Yes, it has recovered. So let me just quickly save it and make sure it does save it. Edit anyway. So now that's where we left off. Now we're going to do is do touch n, which is the name of the file, dot $i, which is the number that's specified by the user. Done. That's pretty much it. Let's save it. Let's cat. It is there. Now let's run it. Create files, user IP. Now it's asking me the question, how many files do you want? I want just 5 files. Please enter the start name of the files. This time I'll just put IMR, just first 3 initial of my name because I already have other files in there. So I'll enter. And when you do ls-ltr, you'll see it created files with my name, IMR initials, and 5 files. That's how you give that option to the users. If the users are not very friendly with the command line, then you could create a script for them and they'll run it and it'll create the script for you. Next, moving on, another script that I want to do is to assign write permission to the files. So now you notice that I have created these files and I want to give, let's say, write permission to every one of them. So of course you could do that chmod write and just do Imran and then hit this asterisk and it'll assign it. But what if you have different names, then you have to do one by one, or you could actually make a mistake while you're working on it. So it's better you create a script. To create a script, I'll name it assign permission. Oh, I don't want to do that. Again, I would have to write it, so I'll just create files and assign permission. Save time, assign permissions. Okay, so now for I in Imran, do echo assigning write permissions to $i, which to do is execute this to $i and sleep 1. So it will do one at a time and done. Okay, so basically what it's going to do is going to look for all the files that has Imran.*, and then it's going to do echo assigning write permission to all those files, and then it's going to actually assign those permission one by one. Let's run it. Assigning write permission to Imran 1, Imran 10, Imran 2, 3, 4. How many we have? We have 10, right? That's the one we created in our previous script. So let's verify it. Yes, there you go. So it assigned all the right permissions. Did it give write or executable? We give executable. But anyway, you understand what I'm trying to do, right? So you could do, instead of dex, you could just put W. Anyway, moving on to our last script for for loop. I want you to keep doing for loop so you'll get used to it. The next one, I want to assign write permissions to files with the total time it will take. So if it's going to take 10 seconds, and I want to know the wizard to tell me, hey, it's going to take that much time. So I'm going to use the same script. This time I'm going to just VI the assign permission script. I'll come back right here, and this time I'll put right here ls minus L. Oh no, you know what? Total. Let's assign a variable. When you assign a variable, you hit equal and then tick, which is right above the tab. And the variable starts with ls minus L, Imran, asterisk, and then how many files we have? Tick. This is going to give us the total number of files that starts with Imran. Okay, so now echo. It will take total seconds to assign permissions. And the rest I'm going to leave out as is. I'm not changing anything. So, but this time I'm just going to update this one. Okay. All I did is I am telling the user that when you run this script, the script will take this much time to complete. It's just like as if you are installing a software and the software tells you that it will take that much time to finish the installation. And I am creating a variable, and inside the variable I'm putting this command, and that command is going to do is it's going to run ls minus l imran asterisk w c minus l. So what exactly that does? So this command, when you do ls minus l and when you run it, it will give you the total number of files that matches imran dot asterisk. So basically I'm saying, since we have sleep here, so if there are 10 files and it's going to sleep 10 times, then it's going to take 10 seconds. So let's do assign permission. See, it says right here, it will take 10 seconds to assign permissions because there are 10 files. Okay, so now let's check the right permission, and you see every file that has Imran has the right permission now. So these are a few examples of creating these for loop scripts. Try them again and again, and you will become very, very skilled in for loop if you try all of these scripts. Okay, moving on to the next lesson. This lesson is also about for loop and its extension of the last lesson that we covered. Here we are going to cover again a couple of scripts. One script that we wanted to cover is how we could rename files that has .txt file extension to .none, or any file that you wanted to change with a different name. The second script that we'll cover is check to see if files exist. Now, the file exists. Sometimes you have to actually log into a different server, and you need to find out if in a different server a file exists on that server as well or not. So you could create that script in there, and you could check that. Both of these scripts have a very much application to the real life, because I actually worked on many of these type of tasks where I have to change or rename the files, or I have to check if those files exist or not. So I'm going to cover these again, real life example. I'll log into my Linux machine straight here. I am logged in as myself, and of course I am in my home directory, and I'm going to create a new script, and I'm going to name it rename files. And we're going to start with our same practice. It's only going to take a few seconds, so please get into the habit of doing that. Date, description, which is for me the most important one. This script will rename files ending with .txt. And then I have to do the modified date, which is, since this is a new one, I'll just put the same date. Okay, the script. The first bit what it's going to do is it's going to create a variable for, so this time I'm going to pick a different variable. I'm going to put like a file name. You can put I again if you want to. N asterisk.txt. So it's going to look for all the files in the current directory that has the ending name with .txt. And asterisk, as you know, is a wildcard. It's going to look for that, and it's going to put in a container name, file name. Okay, it's going to do that. What else do you want it to do now? I want it to do move whatever comes from that container. So whatever comes from that container, name it, rename it to file name, %, change it right here, to none, and done. So once again, it's going to get the list of all the .txt file and put it in a container, and the container name is file name. Then it's going to do is move that list of all the files that are in the container, and it's going to rename it to, and this is the string or syntax that you have to pick, which is dollar curly braces file name, which is the name of our actual file, and this % is actually like a wildcard .text. So it's saying whatever that is .text, change it to .none, and then be done with the script. Give the proper executable permission. Now let's run it and oops, it's not the right one. Rename files. Okay. And it says cannot stat *.txt, no such file or directory. Perfect. It means it works. How it works? Why did it give us error message? Because we do not have any file in our current directory that ends with .txt. So if you do ls-l *.txt, see, nothing is in there. So we will create some files. So touch imran.txt, afzal.txt, or any.txt. So we created these 3 files. And these 3 files will be renamed to .done when I run the script. So let's run the script, rename files, hit enter. It ran, and let's verify it. And it did change from .txt to .none. So that's one of the examples. You could change multiple files with your script in one shot. Next one we have that we want to cover is check to see if file exists. This one I use it. I have used it in the past as well many times. So let's do copy, rename files, and I want to do check files. Copy saved us time, so now vi the files. I'll leave everything in there except this script will check for files. Simple as that. Just change the description. Everything stays the same, and remove the script and start the new script. So now, what are the files that you want to check? So I want to first create a variable. In the variable, I'll just put files equal, put double quote /etc password. Every system has that, right? /etc group. Every system should has that too. If it's not, then we have a problem, right? So that's what we wanted to make sure. Shadow etc and nswitch.conf etc sshd _ssh _config. And the last one, I just want to put fake. It's just a fake. I wanted to see if the script actually finds it. Hey, this file does not exist. All right, so these are the files. Close the quotes. These are all the files I'm putting in a variable called files. Good. Variable is defined. Now what do we want to do? Put echo, so it will put an empty line. For, now we are creating another variable for file in files. So all these files that are in this variable, now I want you to put those files coming from this variable into another variable, and that variable called is just file, lowercase file. Do if, now here's a new one, if exclamation E file, this is going to do is if the files are coming here that do not exist, exclamation means do not equal to the file that I have specified, then echo the file do not exist. Echo another empty line, fee, and done. Okay, so basically what I'm saying is if you go and look for all these files right here in this container and then put all these files in a new container, so and then do is test if these files actually exist in this system, and if they do not exist, then tell me they do not exist. If they exist, don't worry about it, don't tell me. So that's why I didn't use else command. So let's run it and now check files. Okay, you see right here it says etc sshd _ssh config do not exist. etc fake do not exist. Okay, yes, so ssh _ssh config, that file, I actually, there is a file there, but I actually by mistake picked the wrong one. Actually it is etc ssh, actually I am not root, that's why it's not going, no, it's actually ssh config. Yes, this is the actual file. So, but I have it specified wrong here. That's why it says do not exist. That's how this script is doing. So why do we need that script? Because as I said before, what was that? Sorry. As I said before, many times you do have to go into different system to check if those files exist and make sure, even if it's an application file or database file, you need to verify those files exist. And that's why you're not having the problem, because files do not exist. That's how you run the script. You could specify different files to test on it and see how it works. Copy files to remote hosts. In this lesson, we are actually going to write a script. This is also a for loop script, very useful. I use it many times, and I know a lot of my friends who are in IT or in Linux write scripts that actually copies file from one location to multiple servers. You could copy files from one system and to the second system to the third system using commands like FTP or SCP. But if you have multiple systems, you don't want to do it one by one by one. So this is a very short lesson. I wanted to show you how you could copy files and how you could use for loop commands for that. And if you remember exactly how for loop is done, I'm sure by now you are expert in for loop and you should be able to do it yourself. If not, just follow me and I will go into my machine and clear the screen. I will name this script as copy files to remote. And you know what we have to do? Bin bash date 08/08/2020. Description. This script will copy files to remote host. Hey guys, I missed one thing. What is that? Author. Yes, it's very important because if you are writing a script and you have multiple system engineers, administrator in your department, they are also writing the script, then this is the easiest way to find out who wrote that script. And they could simply get in touch with you and ask you, hey, the script is not doing what we want it to do. Can you modify it? Okay, so now for I, pick I variable again. N, now you'll put the host name or the IP address of the machine that you want to transfer it. Just for giggles, I'll put the host name, let's say Red Hat 1, Red Hat 2, Red Hat 3, Red Hat 4, or as many servers that you want to transfer over, you could do that. So you know that now you're putting 4 Red Hat servers into a container and the container name is I. Okay, it is in the container. What do you want to do? You want to do SCP of a file, right? You want to transfer the file. So the file name is like some file. I don't know which file. Because this script that I'm writing is just a test script. I am not going to test or run the script because I do not have multiple Linux servers in my lab environment. If you do have it, then you could go in and actually change the host name right here, which is Red Hat 123, to the actual host name that you have, and to the actual sum file to the actual file. Okay, so your SCP sum file, where? To I. I is what? I is a container, and the container has what? Container has all your host names. And colon / let's say you want to transfer to temp. And this is right here is just the standard way, right here, starting from colon to if you want to transfer a file. And I'm sure you know that, and just be done. So this is actually, as you know, let me repeat it again. This is going to copy some file to Red Hat 1, 2, 3, and 4. And if you have multiple files, you could also, what you could do, you could put all those files in a file, create a file, let's say ABC, and put all the list. Let's say if you have 100 servers, then you don't want to write those 100 servers right here. Then what you have to do, you have to specify a variable that will do a, let's say this is a variable, tick cat that file. So if the file is /home ifzol ABC, you're catting that file. Now you're telling it for file in $A. Then you do same thing again. So now you don't have to specify all your host names into the script. You could just specify all your host name into a file, and then you tell the script to go and read that file and execute that command against it. That's pretty much it about this lesson. If you actually have multiple hosts that you could try on, go ahead and try, and I'm sure it'll work. Okay, let's look at this next lesson about directory assignment. What are we going to do in directory assignment? What kind of script are we going to do? Well, this is a script also I have experienced. Many of my coworkers or my friends who are in this field, they have experienced this kind of issue. What happened is there are home directories, or there are directories inside of /home. But what happened is all those users that are in the etc password, those directories do not belong to them. So why do we have those directories then if they do not belong in etc, to any of the users that are in etc password? Because in reality, as a standard, every user directory should go into /home. And if there is a directory that is like XYZ and it does not belong to an actual user, should be deleted from /home. Unless it has an application associated with it or you know there's a business justification for it. So we are trying to find out those home directories that do not belong to a user. So we will do is we will match the users from Etsy password to /home, the directory. And it will complain, hey, this directory do not belong to this user or has no user at all. Okay, so let's go into our machine. Now this time I want you to be root. And first of all, what you have to do is to go into the /home directory and create a user directory called Junos. Now Junos is a directory name that I picked because I do not have Junos in my Etsy password. You see nothing came up? It means this user do not exist. So if my script works the way I want it to work, then it should complain, hey, Junos is a directory in /home. That directory do not belong to any user in Etsy password. So I want to know that. Okay, so how do we do that? Let's get into our script. And I want you to create that script in /temp. Go to cd/temp and do vi check dir. This is the name of the script that we will pick. And we will define our shell and our author. Who's the author? That's you. Date. Description. This is the best part. This script will find directories without users. Modified 08/08/2020. Okay. Now what it will do, it will first go into cd into /home. I want to run this command. Then we'll put a statement for, and I will put a variable this time, dir. It's just a variable. You could pick anything again, n asterisk. So I went to cd/home directory and I am looking for all the directories and I'm putting all those directories into a variable called dir. Then I want to do is create another variable and I'm going to call this variable chk. Check equal dollar parentheses, which is right above number 9, grep minus c from dir, sorry, this is a variable we have, and against password. Let me write the script and I will explain you once more time what I'm doing. Check is equal greater than 1. Then echo. You don't have to put code if you don't want to. Sometimes I do, sometimes I don't. It really doesn't matter. Directory is assigned to a user. Else, echo, directory is not assigned to a user. Fee, and done. Okay. This is a script I wrote. Now, let me explain to you again. Okay, so what is the script is actually doing is it's going into the home directory and it's finding everything in the home directory and it's putting into the dir directory, which is a variable. Then what it's doing is it's defining another variable, and another variable what it's going to do is going to run a command grep with -c option, which will do the count if it finds it, 1 or 2 or whatever. And it's going to grep from this list, which is in this variable, and it's going to grep from Etsy password. And if it finds even one directory that has a user, that's what I said, if check is greater than 1, if this variable returns anything more than 0, which is check is greater than 1, then echo directory is assigned to a user. If it is below 1, then it's going to say else directory is not assigned to the user. And fee, and done. So we will run the script real quick. And I wanted to assign the permission. Now let's run it. Okay, now you will see it says I absolve. So basically, before I tell you the output, let's go to home, and you will see there are 1, 2, 3, 4, 5, 6 directories are at /home. And now it's going to grep all these 6 directories from Etsy password, and it's going to say if that matches. So it says I absolve is assigned to a user. Perfect. Junos is not assigned to a user. Peter is not assigned to a user. Test is, test 1, 2, 3 is, and test 4, 5, 6 is. So basically that's what I'm doing. Now what I could do is I could simply, if I run the script, and I could simply do grep, and I'll do not, and it will only give me no such file. Check. Oops. I am not in temp. So now check. I think I put it in check. I'm putting in /root directory. All right, so check dir, and when you hit enter, and now when you do grep not, I will know that these are the 2 users that do not have a user account, and their directory is there. Why is there? That's a problem. That's a security risk. So now I could simply go in and delete it or find out who these users belong to. Also, what happened is, and that's a real life example. What happened is if you have a group of people and one of your coworker leaves the company, so you delete his or her account. But somehow when you delete it, it depends on which command you run, the user delete. It does not delete the home directory with it. It keeps the home directory unless you specify in the user delete with the option, I believe it's -- remove, then it will remove the directory. Otherwise it will not. So that's why you have to come in and do some of the housekeeping and make sure all those directories are gone. So that's how it works. Try it. It's a very useful script, and you will need it one way or the other, whatever that you're doing. Or if you are trying to look for other things, you could just change the script to whether you wanted to use it for. Our next lesson is about listing users who have logged in, let's say, for example, today or any specific day. So what happened is, let's say your manager comes to you and asks you, hey, Imran, can you get me a list of all the users who have logged in today? And if they are logged into from a specific machine, from a specific IP, or even you could say, hey, can you give me a list of users who logged in on July 25th? Then what would happen? You have to actually go in, get for the right command, look for the right options and the right piping commands, and then you run the command. So what if you already have a script that does this type of job for you, and you know that your manager is going to come back to you and ask you the same thing probably like 2 or 3 times a week or a month, and then you need to create a script. So we'll create that script for our manager, so he'll be happy. So let's go directly into our machine, and by the way, what the script is going to do is it's going to look for users who are logged in today. That's the first script that we will write. The second, what it will do is, within the same script, what we'll do is we will add the user input, meaning we will ask the user, okay, you want me to get a list of all the users, but do you want to get it for a specific day or specific month? So we will give that option, give the leverage to the user, so they could simply input the month or date, and it will get them that output. Sound interesting, right? We'll try that. All right, let's go back to our machine, and again, you're logged in as ourself, which directory we are in. Let's go to our professional scripts directory, and I am going to name this script list users. Okay, our regular drill, define our variable, our author, date. I'm going to leave the date out. You could put it in. Description, this script will list users logged in by date. Modified, you could pick that too. I'm going to leave that out. I know you're expert now. Okay, so the first thing that it will do is, now before I write anything, let's write and quit out of this, save it. And if you want to get a list of users by date, what do? You do run last command, right? You hit enter and you get all those users on the first column, and the machine, their terminal, the time, and which date they logged in, the time, and if they're still logged in or not. If you do, let's say, last, you'll see these are all the machines that users logged in with, from all the machine, the time they're logged in. So we want to know the list of users by the date. So the command we ran already, right? But we don't need all that stuff. We need the simple users. So we have to modify our command, right? So it will be last, and then we will do, let's say, grep for, like, let's say, Monday. So it will give us all the Monday and everything. But we also want to make sure sure that it actually goes by the date. So if my manager says, give me all the list of users that are logged in today. So I know I could run that command and I know today's date, right? And I could just simply grep for that. But what if I want the script to run automatically? Then the script needs to know what today's date is. And for it to find out, you'll have to run the date command. And then you could do is simply grep for this date, let's say Friday, August 31st. And then, sorry, first you type the last command and then grep for that specific date. And it will give you only the users for that specific date, right? That's how you do it. But again, script doesn't know what date is today. So script has to run the command date to find today's date and parse it and then put that into the script. So to do that, we'll get back to our script, which is list users. And here first we'll do is we'll define the variable that what is today's date. So today equal, and we'll put the tick. The tick always comes before the date, before the command. So date, awk, print, $1, we want month, $2, $3. This is what we want. And tick again to close it. But what exactly this command is doing? So let's copy this command, save our script, and run it. See, it's giving you the first three fields. So if you just type date, it'll give you the three field, the time, the EDT, which is the zone, the year, and a bunch of information. So you don't want to get all that information. You just want the first three columns. So you could grep against these columns. So we already defined that in our command, and it will pick only first three columns. Let's get back to our list of users. We already defined that. We put in a variable, and variable is called today. Now, we will do is we'll do last, which is to actually run the command, and we want to grep for what? We want to grep for our variable, and variable is what? Today. So basically what's saying is run the last command and grep for the variable, and variable is this. So this is what it's going to do, and now let's run it. Give permissions. Okay, you see what is happening here? It's saying August, no such file directory, 31st, no such file directory. Why is happening? Let me tell you why. Okay, so let's do the cat of the script. You see, it's when you run this command, it gives you the information, which is Friday, August 31st, and we are passing this output to the grep. But when you do this passing of information of grep, and then you do this entire thing, then the grep doesn't know which to grep for. It has to grep for Friday or August or 31st. So we have to put that in quotes. So the grep would know that this whole thing is one string. Then it'll grep it. So we have to modify our script the same way, list, and we will put the quote around our variable. Perfect. Now let's clear the screen. Let's run it again. And this time it is giving me all the users that have been logged in today. So system will find out today's date, and it will grep for that today's date. So this is our first script that I mentioned that we wanted to do. You have the list, submit it to your manager, and if the manager only wants the user, you can modify your script by doing list, and instead of last and grep today, you could just do awk it to what? Column number 1, because you don't want all that stuff that comes with it, right? So now let's run it, and you'll only get the users. And that's what he or she wants to get the list for, right? Now, next thing is we want to create a script that will ask the user input to pull a user. So what if you have the script, which the script knows that I'm going to pull users that logged in today only by default. But now we want to give the power to the user. So the user will define its own variable or its own choices. Let's put it this way. So for that, we'll go back into our Linux list user script. And what we'll do is we'll leave everything as is. And we will actually have to remove it because this one actually is for today, and we don't want to grep for today. And we will get rid of this one as well. So you know what? The best thing is instead of deleting this or removing this, oops, just quit out of it and just copy it. List user by input. That's a second. Oops, sorry. Let's use it by input. Okay, so now now we can modify it this way. We could leave the previous script as is and modify the new one. Okay, so let's get rid of it. So description. This script will list users logged in by date or now by, oops. By user input. Okay. Okay, so first thing is it has to ask the user what you're looking for. So whenever you need to ask user what do you have to do, you have to display the message on the screen. To display the message on the screen is echo. And I'll put quote here because I'm going to put parentheses. So please enter day. And I'll put parentheses, for example, Monday. Because I have to let the user know the example, and I'm putting parentheses. That's why when you put parentheses in echo, then I think you would have to put in quote. But you could try without quote. Hopefully it works. But anyway, just to be sure. Okay, so now you have to read the input. So you do D as for day. Echo, just to put an empty line. Next one you need to ask is, please enter month. For example, August. That's how the user has to enter. Echo again, just put an empty line. Sorry, not echo, read, because we have to read the input. Read M is a variable for month. Echo. Another echo. Now we have to ask another question. Please enter date. For example, 28. Okay, now read the date. D, we already have a variable for it, so we'll put DA. Okay, so we have asked all these questions. Let's put a quick echo here. We have asked all the questions, and we have added those questions into a variable. Now, what do we want to do next? Next, we want to do is run the command last and grep for quote $D, $M, $DA. You see how it is going to grep it? It is going to grep the entered month, the entered day, entered month, and entered date, and we'll put that variables here, and we'll grep it from the last. Let's run it, and we'll see how it works. List users by input. Please enter day. Perfect. I'll put in Monday, as it say. Please enter month. Let's say August. Please enter date, and I'll put 28. And it says there is no user that actually has logged in that day. To verify our script runs, let's run just last command just to see if there is actual users who work. So we'll pick Sunday, August 26th. Perfect. Okay. Let me clear the screen so this way you'll see it clearly. Sunday, August 26th. So we know for sure that this is the day, month that someone in my machine or I have logged in. So when I hit enter, now it's giving me all the users that have been logged in to my Linux machine on this date. Again, if you want to just view the list of users, not the whole information, what you have to do is you just put it at the end, you put in awk $1. And this way it will only give you the users. Clear the screen. Let's run it again. List user by input. Please enter date, Sunday, August 26th. Perfect. This is what we wanted to know, and you could just simply copy and paste it to your email and send it to your boss, and you are happy, he's happy, and your script is done. Next time he comes back to you and says, hey, can you get me that same list again? What do you have to do? You have to run the command to put in all those variables again? No, you have a script. You made your life easy. So you just run the script and there it goes. Now you could go one step further. How is you could actually automate this task by running through the cron job if your manager tells you that I need a list of everyone who logs in on Monday of every month. You could specify that as well. All right. Hopefully it works out for you. Try it out. Try the different options. Okay, this is the time about central logging. This is one of the script that a lot of places have it in place, and a lot of companies would like to have some kind of automation tool around the logging. How it works is you have every Linux machine has var log messages, right? And you would actually have to go into the machine, log into the machine to view those logs. and to see if there are any error messages or failures or anything. So you probably would have to do that multiple times if you have multiple servers, or you have to do probably for 1,000 times if you have 1,000 servers. And you have to go and VI the file, test it, grep it, so many things. What if I tell you could write a script, a central logger script? What it's going to do is going to trace the var log messages file. Not just trace like entire file, it actually is going to sit and wait for the new line generation to log in to the var log messages. And as soon as it comes in, it is actually going to filter out whether it has error messages or not, and it's going to put it out if it matches your criteria. If you are looking for only, let's say, error messages or failures, then it's only going to grab for that keywords, and once it finds those keywords, it's going to push that out to a file. And you could read that file later on by yourself, or you could actually leave that script to run it in the background. While it's running, it's keep outputting your error messages or your failures related lines from your var log messages to a file, and then you could go in and read it. And you just have to do is run it in the background. Or third step you could do is you could, as soon as those file is created, you could create another script and tell if it's going to wake up like every 15 minutes or 20 minutes and tell the users or administrators or managers that, hey, there is this file that's been generated and it has these many errors and failures. Or, of course, you could go another step, which is to schedule that script through the cron job. So if you look at it backward, you have a script that is scheduled to wake up every 15 minutes. That script will have to notify a user if a file exists, and that file that exists that has your information that you're looking for, like errors, failures, shutdown, offline, or anything that you have specified. And those messages are coming from where? From var log messages. So we will create this script. It's a little long script. We'll create this script step by step, and you could actually implement that script in your job if you are at Linux capacity right now, and you will see definitely that this will make your life so much easier when you actually have these error messages coming in through the email without you having to log into every machine. So let's go straight again to our machine. Let's clear our screen, and I want you to this time become root, because in order to read var log messages, you have to be root. Without root, you cannot read var log messages. It does not have read permissions for anyone else but root. Okay, here you have to start writing a script. But before you write a script, I just have to tell you that the way you could look at the logs is by doing tail, let's say -10 var log messages, right? Most of the time people will do that to see if there are any messages. Or what they do is they do cat /var log messages, and they will just grep for -I to skip uppercase, lowercase, error. You see, I have so many error messages on my machine that came up. I wouldn't known if this error messages exist unless I come in and log into the machine and actually run this command. But is that something that you want to do on every day and spending so much of your time just looking for log error messages? And if you have a 100 system, then forget about it. You're going to spend all your day, and it's going to affect your performance significantly, and you don't want to do that. Okay, so for that, you have to write a script. And to write a script, I'm going to pick which directory I'm in. I'm in /root. And here I have a few other ones. I already have one script that I created earlier, which is called logtail. And I will actually use that script, but I will tell you exactly how it works. So let me clear the screen. So logtail is the script that I've written. I will hit enter, and then you'll see here I skipped it real quick, but I want you to put it in. The information that we always need. Date. Description. This script will log only defined keywords modified, whatever that is. Okay, so let's get into the script. This is what the script is going to do. First, the script is going to tail with -F and 0 option. Tail is a command that will tail the last error messages from a file. Sorry, not error message, but any messages from a file. And when you specify -F, this is going to tail the live incoming traffic. With -N0 option, what is telling it only look for the latest new incoming messages. Don't look for messages that have been previously in this log, which is fine, because when you're going to run it, you don't want to start from the beginning. You don't want it to keep getting the same error messages. Okay, so I'm sure you're familiar with this command. You do var log messages. Next thing right here, you put a pipe and you do while read line. What this is doing is while it is doing tail. If you leave it right here, then it is going nowhere because you're running a shell, but you want to put it somewhere, right? So you do a while script. The reason you do while is because you want to run the script in a loop, meaning it doesn't stop. It just keeps running and running and running until you actually go in and stop the script. So what it's doing is we are telling the script to run the script while in a while loop and read the line. And what is the line? Line is our variable. And what is coming inside the line, whatever the output from this is going to go into this variable. Okay, now we're clear here. Now, once we have all those messages coming in this line, what should we do? Right? What should we do? Echo that line, first of all. Whatever is inside of this variable, echo it again. Once you echo it, it's gonna read it, right? Then it will grep. Egrep is another command. It's efficient command that will grep multiple keywords. So egrep -I, and I have keywords here. It's refused, invalid, error, fail, lost, shut, down, offline. These are the keywords that I have gathered in the past from my experience, and I know these keywords actually work, and these are the type of keywords that mostly come in to the system and valuable to the system administrator to find out. So anyway, whatever comes in, and it will grep for all these messages. Here we're putting in if command. What we're saying is if statement is if $, meaning if the exit status is equal to 0, meaning if it does find something, any of these keywords, only then, echo that output from this to a file called temp filtered messages. That's my own created file I wanted to put into this filtered file. Once it's been put in, fee and done. So let's save that file. When I run that file, you'll see it will run an infinite loop unless I actually put in some kind of logger message in it, and then it will put it into the filter files. So let's control C out of it, and if you notice, where is it putting? It's putting into /temp/filter messages right here. I ran this command previously, and it has some of the error messages, and then when you do cat filtered messages, you will see some of the error messages that I sent through the logger, it came in here. The logger command to run it, I think it's, let me do from my history, grep for logger, and you see right here, this is the logger if you run any of the command that will go into the var log messages. Because let's say if you run logger -t error test entry, I'll put in like Imran is testing and hit enter. This entry is going into the var log messages. How do you verify it? You do tail -5 var log messages. You see it's right here. It is being recorded because logger tells it to record it. So now if I do the same thing again, I run the log tail script, and now I open up another terminal, become root, and here if I run the logger command, and I will put in Imran is testing again and hit enter. Oops, sorry, it has to be the exact logger testing. Clear. Logger Imran is testing again. Hit enter. Okay, you see, as soon as I ran this, the log tail also threw the message on the screen, and I'm sure it has also logged into our this file /temp/filter messages. So let's verify it. You see, it has added that right here into our message. So that's what happens every time a error message comes in. It will be logged in here. So if I also have, let's do our cat log tail. If I do invalid, so let's do logger. Instead of error, I'll put in invalid. Let's say it picks up that Imran is testing invalid keyword. Hit enter. As soon as I hit enter, you see in the back, it also listed that into var log messages. And when you read the file where it's pushing it to, sorry, clear. You see it has also added that to your /temp/filter file. Okay, now you see one step is done. You have actually, if you notice right here, let's minimize this. You have actually created the script to trace the log. You run the script in the background. Next step is now you see my prompt is not giving me back. It's stuck. Why? Because this script that I've written, it is going in a loop and it's not going to give me my prompt back. So in order for me to run that script in the background, I would have to run that script with no hub and ampersand. So just do Control C out of it and hit up arrow key. And this time I'm going to specify no hub, meaning don't bother my terminal. Give me my terminal back. Logtail, sorry. And just put ampersand. Why is that no hub and ampersand? That's how it is. That's how you run the commands in the background. So you hit enter. Enter. Oops. Did it work? Log. 1 second. No hub / root logtail ampersand. Yeah, sorry, one ampersand. Okay, so once you run it, you could actually do ps -ef and grep for logtail, your script, and you'll see it is running right here. See right here, it's running two scripts because it's one is it's reading, and second it's putting into a file and grepping for error messages and invalid. So if you wanted to bring it to the foreground, I believe it's foreground something, and it brings it back. Anyway, so whenever you run this script, you have to run it with this command, no hub /root /logtail ampersand, and it will put it in the background. Next thing is right here we have user admin notification. Now what if it actually generates the file and it put it into the user, it actually throws that message to a user email. So for that, I believe I also have a script. No, actually I don't. I would have to create a new script and I will name it log alert. Before I do that, let me copy that logtail to log alert. So this way I don't have to type the variable and description. vi log alert description. This script will send an email to administrator. That's it. Modified. Okay, so now let's get rid of everything. So this way we are typing it from scratch. First thing is, if you have multiple users that you wanted to send this log to, instead of putting their email one by one, you could put them in a variable. So the way I do it is I put in like if your group name is, let's say, IT. You put equal and now put quote and the email address, imran_ny@hotmail.com, comma, let's say Peter dot says at email.com, code close. So I'm just picking two users right now. If you want to specify more than that, you just put comma and the email address. Another advantage of putting the emails in a container or in a variable is because if a user leaves the company or a new user joins the company, you don't have to modify your script. If you could make a mistake, you could simply modify this variable. Okay, so now our variable is defined. Now you put if statement. If is always very strong. The newer option that we're picking is -s. So what we are doing with -s is /temp/filtered messages. What I'm saying is, first make sure if that file exists. I don't want to send an empty file, right? If the file is there, then I wanted to send it. But before that, let me make sure that this is the correct file. So save this your script and just do ls-l. Yes, it is. So vi log alert. Okay, so if you find a file there in temp and file name is filtered messages, then you cat that file, sort it, unique it, mail it to who? You could mail it to the IT, right? But also put in some subject is syslog. messages and then send it to IT. Remove this, else, don't do anything, fee. Okay, let me go over it again. I know probably typed it fast, I went over fast, you probably don't know what I just did. Again, I specified the email addresses, I put it in a container, then I ran the command if, and what if is doing is making sure this file exists. Because again, you don't want to send an empty file. If it does exist, then what you want to do, what you want script to do is to cat that file. Okay, did cat, then sort it. Why am I sorting it? Because I want to unique it. All right, but why are you uniquing it? Because what happens if you have 10 messages, 10 error messages that are the same one? Let's say error, user cannot log in, error, user cannot log in, error, user cannot log in. You don't want it to view the 3 repetitive same error messages. You just want it to know one time. So that's why I'm putting in sort here. So it will sort and unique it. Just give me one message and I would know. You don't have to tell me 3 times. Okay, so once you do that, then you mail it. The command for mail is simple mail minus S for subject. And the subject is going to say syslog message. Okay, and where is going to go to? It's going to go to $IT. And who is $IT? These are the people of $IT. Okay, all right. And then once you are done sending it, then I want you to remove that file. Why are we removing the file now? The reason we are removing that file because we do not want new messages coming in and adding it to the same messages. And then what will happen is we will get new messages as well as old messages. So that's why I'm removing that file. Else, do nothing. If there is no file, then of course don't do anything. Don't send any error message. I don't even want to know, hey, the file /temp filter message is not created. You could do that, but you don't want to get that message every 15 minutes if this script is running every 15 minutes. So basically else and fee and you're done. Again, if you run this script in your real environment, you will start getting messages. I do not have actual mail relay server, which is going to actually send out mails outside to my lab environment, so I cannot test this script. But again, I have tested this script in my job, in my previous jobs, and it works perfectly. All right, save it and change mod a plus x log alert. All right, so now you know we have 2 scripts. One is logtail, second one is log alert. Logtail will continue running forever until you actually stop it. Log alert will run only when you want to view those messages and you want to send an email with those messages. Now you could go into your machine every time and run log alert. But again, it's a repetitive task. So the last thing we have to do right here is schedule the script through cron job. And to schedule the script to cron job, I'm sure you know you just have to type cron tab -E to edit it. And you specify, let's say, if you want to run the script to every 15 minutes, you'll do */15. Every day, every month, and so /root/log alert. Oops, alert. And this script will run every 15 minutes. Of course, I don't want it to run it because this is my test environment. I'll just edit it and I'll put it as comment out of it. And this is how you create a central logging script. It took me a while when I first created it, but eventually I refined it many times. Now you have this script already done, created for you. I want you to create this script from scratch. Don't just copy mine from the text that I have attached with this lesson. This is just for your reference. If you skip something in my video, then you could always go back to my text file and look from there. Otherwise, try everything from scratch and it will work perfectly. User account management. This is the lesson we are going to cover how we could automate the user account creation. Now, why do we need to create user account and why do we have to have an automation around it when all we have to do is to run a user add command, right? Well, that's a very good question. But what happened is sometimes you are working in an environment where your system is also being accessed by other users, let's say QA or development. And they also need to create user account for their own group. They don't have root privileges, or that's one reason that you need to automate the user account creation, that you don't want them to run user add command and make a mistake or mess up your etc password file or even delete users accidentally, so you don't want to give them root access. So what you do is you create an automation tool which will allow them to only enter the user's username and some information, and it will create that account for you. You could actually create sudo rights for them, and that's how they could do it. That's one of the reasons that mostly people do, and that's one of the reasons I created that script in the past as well, where I was working in an environment. There's IT group was huge, but they were all interlinked, where there was a QA department, development department, and database group, networking group, all needed access to the user accounts in Linux. So we didn't want to give them the full access, so we created this automation tool. Well, another way is that even if you do not have that type of environment, you are the only one, you want to create users. You could create them, but then again, you could do user add command. You would have to remember it again. What was the option chosen, whether that user ID exists or not. But anyway, this is what this whole lesson is about. What are we going to cover in this lesson is that first thing is we will create a script that will simply create a user account by just asking what is the username, and the user account is created and done. Second script that I will create is it will error out if the user already exists. Let's say if you are creating an account, let's say Jerry, and if a Jerry account already exists, it will error out and it will tell you, hey, this account already exists. Second thing that I want to add as a third script is add a user description. Now, you could use user add -c option to provide that description, but most of the time people do forget to input that description or use the -c option. So we could add that to the script as well. The fourth script that we will write, we will combine everything, but also add the user with ID option, meaning if you want to create a user with some specific user ID, it will ask you to put that user ID in, and will create it. So what happened is Linux system, when you do user add command followed by the user, it will auto generate a user ID based on the SE password, and it will add one to the last created user ID, and it will give that user ID to the account. But sometimes there are applications that require a specific user account. So for that purpose, you have to specify user ID. And then the last script that I will create, fifth script with you, is adding everything that we discussed, all four scripts. But with that, we will also error out if that user ID exists. It will do the check. So this is a whole combined script. It's a little longer script. So we'll cover that one script at a time. So again, I have my machine right here, my Linux machine, and to save time, save my time, save your time. Well, your time is more valuable. So I have created 5 scripts already. And if you notice, I have these 5 scripts: create user 1, create user 2, 3, 4, and 5. I will go over each script one at a time, but you have to write those scripts. Again, those scripts are in the text document attached to this lesson. You could download that notepad, and you could view that text file and then simply copy paste or type it. I would prefer that you type it. Most of the time when you copy paste, something goes wrong with the script and it doesn't work. So type it. Anyway, so let's look at our first script. Vi create user 1. All right. Variable author date description. This script will create a user account, modify date. I already have that. Again, no waste of time. Next thing is echo, please provide a username. This is simply, it's asking the user to provide the username, and it's going to read the input and echo just line, and then simply it's going to run the command user add with the variable, and variable we have you, and the variable is the one that's provided by the user. And then once that account is created, it's going to say echo user account has been created. Simple, right? Straightforward. Yes. So let's run it. Create user 1. Please provide a username. I will pick Jerry. Hit enter. Jerry account has been created. Perfect. My script ran. Awesome. Verified grep Jerry from password file. And you'll see it created the Jerry account with user ID, group ID, home directory, and my shell. That's the first script. Second is I wanted to create a script that will ask the same thing, but it will error out the user that, hey, this user already exists. So I can't create a user ID for that. So for that script, I have created a second script called, let's clear it. Vi create user 2. Hit enter. Same thing again with a little modified description. please provide user ID, username, read you, echo, right here, grep command. That's where I'm adding that check. It will check if that user exists or not. How is going to check? Right here. First, it's going to run the command grep with -q option. Q is the silent mode. Don't show anything on the screen. And grep the user, which is that container, which just user specified, from etc password. Okay, good. Now, I'm saying if the error code is equal to, the exit status is equal to 0, meaning if it does find it, right? So if my command is successful, it will give me 0, right? And the only way it could be successful if it actually returns something. So if it is 0, then echo error. User, this variable already exists. Echo, please choose another username. Echo exit 0, just exit out. Don't do anything. Fee. If that is not equal to 0, if it's something else, then it will add the user. Then we'll go through it. If this goes through, if this checks is work, perfect, then error out. Otherwise, you run this command. User add, echo user account has been created. Let's run it. Create user 2. Please provide username. We created a username earlier, Jerry, right? We'll create it again. And it says, error, user Jerry already exists. Please choose another username. That's what we wanted to do. If I run the same command again, and this time I pick another user, let's say Kramer. And it says Kramer account has been created. You could check that. And you'll see right here, Kramer with user ID and from 1003 to 1004, it added one number to it. Okay, so this is the second script. Third script we wanted to do is add user description. Right here, the third one, add user description. So the way you could add user description is by running the command user add and the username, whatever, and -c is the option, and then you put in the code, system admin guy or whatever, and then you run it. But most of the time people don't use that, but we want to force that user to add that user description. So I created a script, vi create user 3. Updated the description, same thing, please provide username. It will do the check, same thing, if the user exists. It will come down right here. Next one, echo, please provide user description. Read D as in variable. And then right here it says user add, the variable u, -c option for description, and the D, the description. The reason I put a quote around D, the variable, is because you could actually add user description with spaces. So if you have spaces, then you have to have a quote around it. All right, time to run it. Create user 3. Please provide username. This time let's pick Kramer. It's not going to work because Kramer already exists. Run it in a new one. Please provide username. So this time we'll pick George. Hit enter. Please provide user description. George. A character. Hit enter. George account has been created. Perfect. This is what we wanted. Now let's confirm. Okay, see, it has a username, the updated user ID, and the description right here. User description is George, a character. Goes to home directory and the bash. This is our third script, which is to add user description. Fourth script is to add a user ID. Now, what if you don't want the Linux to pick a user ID for you? You want to specify that user ID. Perfect. Clear the screen. For that, I have already created a script, which is create user 4. Hit enter. Updated the description. Now here, same thing, echo, please provide username. Everything is the same to check if the user account exists. Right here, echo, please provide user description. And now from here, this point on, this is the new stuff that we have added. This is going to ask the user echo, do you want to specify a user ID? Because we also want to give the user the option to say yes or no. Or we could just simply force the user to say, hey, please enter user ID. But what if the user doesn't want to add it? They want the Linux to pick itself. So that's why we have given the user both options, either specify yes or no. So we're going to say echo, do you want to specify user ID? Y/n. Read, and this is the variable I just picked, y and u. Echo. Now here we're saying if the variable equal y. This is what works with letters. If I had digit or integer there, I would pick -eq. But since it's a letter, I'm picking equal. Y. So what I'm saying is if the user enters y, then echo please enter user ID. Right? Perfect. And then once the user ID is entered, put that in a variable and name the variable UID. Okay. And then what to do? And then simply user ID has been specified. Then you run the command user add with -u, -c with the description, and -u is the option to add user ID, and user ID is the one that's been specified by the user in this question. Perfect. Echo user account has been created. Perfect. Now, what if the user says no? If the user picked no, I don't want it to pick a user ID, then what do? Then you come down here and then you say elif. The statement that you have to use is elif. Remember we had if then else. What else does is else if you say yes, then do this. Else do whatever that you specify. But now since we have to specifically say n as the letter n, so that's why we have to pick elif. Elif user input is right here no, which is n. Then what you do is echo, no worries, we will assign a user ID. It's just a friendly message I picked. Then what you do is user add with -u, -c for the description and the description that's been specified right here in this variable. And then echo user account has been created. Fee, done. And this fee is coming from this if. You always have to end if with fee. That's pretty much it, guys, for the fourth script. Save it. And now let's run it. Create user account 4. Please provide username. Kramer. Kramer already exists. Okay, no problem. I'll pick another one. Please provide username. George. Uh-oh. I created George already. Sorry. Okay. But it's a good check, right? Okay. Please provide username. Elaine. Hit enter. Perfect. Please provide user description. Yes. Then it's going to say now Elaine, Jerry, friend. Perfect. Hit enter. Now it's going to get into user ID. Do you want to specify user ID? This time I will say yes. Then it's going to say now since you hit Y, now please enter the user ID. I will say 1007. I hope it's not picked. Hit enter. Elaine account has been created. Perfect. Yay. Let's confirm. Let's see Elaine. Yes. With the description, with the user ID. Perfect. Awesome. Okay. Now everything is working as expected. Last thing we wanted to do is what if I had picked a user ID that's been assigned to, let's say, Jerry, which is 1003. It would have been a problem, right? Yes, but before we put that fourth script, let's run that script again, and this time we'll pick no, just to make sure our no works as well, right? You want to test both options. Create user 4. Please provide username. So I picked already all 4 characters. Moving on to the next one. How about we pick what's the characters of Seinfeld show? This is where I'm picking those user characters. How about David? You guys know David Puddy probably if you watch Seinfeld show. That's David Puddy, Elaine's boyfriend. So you'll pick just David. Enter. Please provide user description. I will put Elaine boyfriend. Do you want to specify user ID? I would say no this time. It says no worries. We will assign a user ID. This is what we wanted to do, right? David account has been created. Okay. Let's see what ID it has been assigned. It's assigned 8. Okay, hey, why didn't it assign anything after Jerry? Or you know what, let's do cat password, and you notice it has 3, 1003, 1004, 5, 6 is not taken, 7, 8. Why didn't it assign 6? Well, this is by default, but Linux always picks the ID from the last ID. So if it's last ID, let's say even if I change it to 10, it will pick the next one is 11. That's a counting mechanism it has, so that's how it picked. Anyway, let's go back to our script. Let's not talk about how it creates user accounts. Now the last one. And the last one is the longest one, is that we wanted to do everything that we just did. Let's clear the screen. But this time, we wanted to do is, last one, error out if user ID exists. Okay, so we do everything, but this time if the user ID is picked that is already in that C file, I want it to error out. No problem. Let's see how we could add that in there. So I have created a script for it, create user 5. Everything the same, description is a little modified, same thing, please provide username, checking the username exists. Okay, next one is please provide user description. Then echo, do you want to specify user ID? This is what we did in the last script. Perfect. Everything is perfect. Now right here, if you notice, this is the part that I added. So if you are creating this script, I would recommend you to copy your create user 4 script and paste it as a newer one and name it create 5, and then you can modify by coming directly into this line where it says read user ID. Then you add these lines here. All right, so what this line is going to do, again, it's going to do the same thing, grep q user ID from password. Remember the same way we did if you go back up to check the user ID right here, it did the same thing, right? It grepped from Etsy password. So the same mechanism or same syntax of the scripts will implement right here. So we'll do grep q, which is silent, user ID, which is specified by the user right here from Etsy password. And if the status, the exit status is 0, then, meaning if it finds it, then echo error user ID already exists. Echo empty line exit. Exit 0 meaning completely exit the entire script. Okay, if it does not exist, then run user add with -u option, sorry, not -u option, with -u variable, -c as a description, d as a description variable, -u and the user ID. Okay. And then echo user account has already been created. This is the check right here. If that check passed, it will create that. Now this one next coming down here is the same thing that we have. If the user says no, then you simply come to this one and run it. Okay, so let's run the script real quick. And 5, and this time I'm going to pick Stella. Please provide user description. Stella is mother. She's mother of George anyway. Do you want to specify user ID? Yes. And enter user ID 006. I know sorry, 007. I know user 007 ID has been taken. So I'm going to put it in just to test. And it says error user ID already taken, right? So I know the user ID 6 is not taken. So I'm going to put that in this time. Stella is mother. Yes. 1006. And Stella account has been created. Perfect. Grep for Stella. etc password, and you will see it has been assigned user ID 6. And when you do cat etc password, and you'll see it's at the bottom. Next time you create an account, it will automatically check for ID and appends to a new one. But if a new one is already taken, it will give you, if it automatically goes to the next one. Anyway, this is about this user account management. I hope you have learned a lot from this lesson. It's a very useful script. Try it out with different options and a different way that you wanted to add a user account. Disable inactive users. This is another lesson where the security comes in, and not like actual security. I mean, the security concerns are that the users who are not logged into the system for a certain number of days should be inactive. So we will run the command in this lesson to identify those users. And how does it work in a real world? Well, it happened to me, many people, and I'm sure it might have happened to you too, that your boss comes to you and says, hey, give me a list of all the users who haven't been logged in for the past 3 months or a year. Well, you could do two things with this. Is one, people who are already working in your environment and they just don't have the need to log in anymore. So you want to go in and delete their account. That's one. Second reason, people who have left the company and somehow you missed one of the servers or a few servers where you forgot to delete user account of that person who left the company. So of course it's a security concern, right? If the user account is still there, well, mistakes do happen and you do forget to delete user account on certain number of servers. Actually, if you have 1,000 servers, then forget about it. So what do you need to do? You have to implement some kind of automation tool that will run like after 90 days or after a year or whatever the number of days you want it to run, which will pick up all the users that haven't been logged into the system, and it will simply disable them. You could also delete it if you want to, but the better disable it. So this is what we're going to do in this lesson. We'll first identify the users. Then we will create a script. We'll create two types of script. One script is a for loop script, which will look for all the users and disable the inactive accounts. The second script that we will create is, it will be exactly same script, but we will use XArgument command, which is a newer command that I'll show you that could be used in scripting language to take the input from the command and execute another command on it. So that's how we will do. And so let's log into our machine, our Linux machine. Now, again, as I said, I have created these scripts for you already to save time. So the script that I first created is, let's VI that script, and I name it disable users 4. 4 meaning this is the script I did for loop. What it does is, of course, to define the variable and all the author, date, description, modified comments. Then it's going to run this command, last log, tail, grep, awk, these few commands to identify those users. Now, why am I picking these? Good question. First of all, last log is a command which will give you all the list of users that have been logged. You could use last as well as last log, but last log is much efficient for this purpose. Then tail dash minus 2 dash tail minus n plus 2, meaning get rid of the first line of the output, which I'll show you in a minute what is the first line. So if I open up a duplicate session, let's log in as root. And if I run last log, you will see, oops, let's do more. You'll see at the top, this is the line that comes up that you don't want to get. So that's why I'm using the option, last log, tail minus n plus 2. Tail minus n plus 2. and just do more again, and you'll see that first line that was showing up is not showing up again. So that's what I'm using, that minus n plus 2. Then next one is grep test 0. So now if you want to disable those accounts that haven't been logged into the system for 90 days, then you have to use the command, I believe it's last log minus B90. So this will give you all the users that haven't been logged into the system for the last 90 days. Oh, sorry, I have to remove the pipe right here. So these are the users that haven't been logged in. So now you also notice that there are other users that are system users like root or mail or operator games or nobody or FTP. You don't want to get rid of or disable these accounts, so you would have to actually make sure that you put some kind of grep inside with removing, filtering out some of them, and or you could just run this command and grep it against all the users in etc password file, and you could actually do grep for either people who have home directory or grep minus v for those who actually have the user like no login. So let's see, if you do cat etc password, you see all the users that are system users or have no login, and the users that actually create an account and log in have the /home directory with it. So you could specify different options, different grep commands to get rid of those. But anyway, let's go back to our command. This is the command that will give you all the users that have been never logged in or have not been logged in for the 90 days. So for my test purposes, this lab, I created a script, cat disable user 4. So this script, what it'll do is it will actually do the same thing last log, but instead of minus B90, because this is a test to show you how to delete the system and how to create a script, I just removed minus B minus 90, kept the tail command, and now I'm grepping for only test. Why I'm grepping? Because I do have a test account in there that I'll show you in this exercise. If I run it, you'll see I have 2 test accounts. So this command will grep these 2 test accounts, and then it will use the command user mod minus L to disable the account. So let's VI this script again. And here, if you wanted to specify, let's say if you wanted to grep with with minus A, not A, it's minus V actually, and you wanted to exclude never, you could do that and then print out all those users. But since we are doing the test only, so we'll pick the test ones, and now you'll see this is going to disable all the accounts that matches test. So instead of doing 4, so for now I will use the for command. For in the variable $a, which is getting from here, is putting in the variable a. It's doing user mod, and minus L option is to disable the list, and done. So instead of just for test, I will do cat $I for now, and I will just put, I'll put a comment here, so I don't want to delete it right now. So I will just check what are those users. Let's run it. Oops, 4. Oops, it says no such file or directory. What happened? Let's take a look. 4. Last log, this is what is giving us the entire list of users. And then we are doing is we are putting this list for I into the I. And then, oh, we don't have to cat, we have to echo. Just to see what are those users. Clear the screen, disable users for loop. Okay, so here's a list of all the users that have not been logged in, but it's still not correct because I just wanted to grep test, right? So let's take a look at the disable account 4, and I want to, oh, I did the minus V to exclude. I don't want to exclude. I want to grep only those because, as I said again, this is just for test. So now let's see, and you run it, it gives me only those users. So now we have identified these other users that we want to disable. I'll go in and disable user for script. And this time I will, instead of echo, I will get rid of that line. I'll put user mode -L, and whatever the user return, disable them. Perfect. Before I run this script, I will verify it that I could log in with the user that is going to disable. It was going to disable test 1, 2, 3, and I'm logging in, and you'll see it has logged in. Perfect. So now I could get rid of this, and now I'll run my script. The script ran. Now let's say, now it should have disabled those accounts. So let's say if I log back in, test 1, 2, 3, in the password, and there you go. So it's not going to let me get in. It says access denied. I know it has disabled those accounts, and to verify it, you'll see you could do grep test 1 or just test and etc shadow. Shadow is the one that actually puts the exclamation point right here that will tell that this account should be disabled. See right here. So if I just modify the etc shadow file and look for test, I could remove this exclamation point, and I also remove exclamation point here. So now I should be able to log back in, and to log back in, my user is test 1, 2, 3, and put in password, and bingo, I logged in. Exit out again, run the command again, and it should have locked the account. Try again, and it's not letting me in. Access them. Perfect. The script works. So now this is the one way to disable user account using the for loop. Another script I wanted to show you to do the same thing is this VI is, I have created a script for you guys already. It's X argument script. So what it's going to do is it's gonna, instead of specifying the variable and then running the for loop and then going through the whole process, it's going to run that script right here, do everything, grep for test, and awk those. And instead of that, putting into a variable, I am actually passing that to as an argument. I put an X argument and -I option, curly braces, meaning whatever comes in as a result from this command, do user mod lock these accounts. It's just that simple. Instead of doing the for loop command, you could also specify what you wanted to do with the exact same line in one command. So let's try it. Let's try to run it. But before we run it, we already have disabled those accounts. So I'm going to enable them again by going to etc shadow, look for test accounts, and get rid of exclamation point, and save it. Now when I run this disable X argument, it should have disabled those. I could verify by doing grep test on etc shadow, and you'll see it has put that exclamation point in there. See, it's doing the same thing as for loop doing, but it's a different way. So I have two scripts that you need to learn. One is one is disable for, and the second one is disable arguments. So both doing the same thing, as you see. Again, if you wanted to do the test with me, you would have to create test account before using this, before doing this exercise. I will actually add that to my video at the beginning by editing it. But anyway, if you are listening to the message, you know already that this lesson has been edited for you to create accounts first, which are test 1, 2, 3 or test 3, 4, 5, or whichever account that you wanted to disable and do your lab for it. Now we will talk about checking processes status and killing it, meaning or stopping it or exiting the process. So there are many processes in a Linux system that when you run it, it doesn't stop gracefully or it doesn't shut down gracefully. And those processes most of the times are called like the zombie process, or a process that does not have a parent. A parent process was started and it initiated a child process, but then the parent process was stopped, but the child process was still lingering around. So those are the type of process that you do experience in your career, in your IT career. So you would have to actually go into the system, find those processes, and kill those processes. So this is this topic or this lesson is about that process that we have to find out. How can we automate that process? How can we put a script around that process to make it run it at certain times that will wake up and see, hey, I see this process. I'm going to go ahead and kill it. So what we're going to do in this lesson is that we will create a dummy process. Anything that is just taking up some of the CPU or memory resources, we'll just create that process. Then what we'll do is we will run the command to find that process ID. Commands, there are different commands that you could check, like top, you could do ps minus ef. There are so many commands that you could run to check which process is running. And then you could pipe it to grep for specific process that you're looking for. So in this lesson, this is a lab environment. We will have a process that we will initiate, and then we will run the ps minus ef command and grep for that specific process and its ID. And then, of course, we'll create a script around it, and then we will kill that process within that script. Okay, so this is the exercise we'll do. So for that, let's go ahead and log into our Linux server. I'm logged in as myself, and I am in my home. I've installed PS directory, which is a professional script directory that I have or created earlier. Anyway, so first, before I create a script, I wanted to test my commands. So I will run a process, a dummy process, which is to sleep. Sleep is just a command that will actually start taking your terminal, and it will not give you your prompt back for, let's say, if I have 600 here, it means 600 seconds, which is like 10 minutes. So this will take away my prompt or create a process for that prompt, and it will wait for 10 minutes, and then it will return my prompt back. If I hit enter, you'll see I do not have my prompt back. Now, how can I check if this process, what process ID is assigned to it? Who is running that? Well, you cannot do it from the same terminal because you do not have the prompt back unless you control C out of it. That's one way. Second way is if you run the sleep process in the background, then you could get your prompt back, and then you will see the process ID. But anyway, we'll start our duplicate terminal session. And now I will do ps minus ef command to check the process, and I will grep for sleep 600. And as you'll see, the first process right here is initiated by me, the process ID, the process user ID, the process name, time, the terminal started from. The second one is just the grep itself command. When we run the grep for it, see this grep, since this grep is also a process, when it runs, it greps itself. How come it greps itself so fast? Well, that's how it does in milliseconds. Anyway, so we'll run another command to grep out of grep. So filter out grep. Now I will only see my sleep command. Okay, so this is the entire line. I do not want to see the entire line. I just wanted to get the process ID so I could kill the process ID. So for that, we have to keep filtering it, and we'll do awk print $2 because it's the second column. Hit enter. Now I have a process ID. So the process ID is this, and I want to kill that process ID. To kill this process ID, I'm just going to make this bigger, so this way everything can show up in one line. Before I kill it, it's always a good idea that you test it, that it comes back with the right ID. So I'm going to use the xargument command, xargs minus I, parentheses. This is where it holds the result of this command. And now when it holds that result in this parentheses, what I wanted to do right now is I wanted to echo that whatever inside of that parentheses. So I'll hit enter, and you'll see it brings back the same process. It didn't kill it. Now I could run a command, kill, right here, and I could simply kill that command, that process. The process is gone, and if you go back to your terminal in the background, you'll see I got my prompt back, and it says right here, it terminated. So this is one of the ways that you could actually create a script like that, which will terminate your process that are no longer needed. So let's go ahead and create a process. vi kill process. Binbash, who's the author? Of course, we all know that by now. Okay, date. Description. This script will find dead or zombie processes and kill it. Modified 08/08/2020. Okay, so I'm just gonna go ahead and save this, and I will copy my entire command from here, go back into my script and paste it by right-clicking in the PuTTY terminal. So for that, what I could do is just either I could just leave it like that and then do echo all sleeping processes are killed. So this is how you could run that simple command, and once you run it, before you run it, you have to give it executable permissions. Kill process has executable permission. Perfect. So now I'm going to run that sleep command in the terminal behind me, hit enter, and now I will run the script kill process. And all sleeping processes are killed. Let's see if you got a prompt back. Yes, terminated. So that's one way to do it. The second way, I'm sure you know, I want you to try that second way. I'm not going to tell you, is to use for loop. So you could actually put this entire command until here into a variable. Let's call that variable A. And then you will run the for loop for it for I in $A do kill $A done. So try that, and I'm sure it will work. And if you have any issue with this for loop command when you're trying this, let me know. But I'm sure you will be able to write both scripts with X arguments and for loop. Disk space check status. No matter what you are doing in IT, this is one of the issues that everybody experiences, whether you are a database administrator, networking guy, Linux guy, Windows guy, or working in any kind of application capacity. You're always going to get to this point where you will have a disk space issue. And disk space issue either on your own computer, on your laptop, or a server that you're working on, where you would have to actually tell the administrator, hey, can you free up the disk space? And the administrator would eventually go in and free up disk space by deleting disks. But anyway, system administrators or engineers who are actually managing the servers, whether it's Windows, Linux, or any other operating system, they have to be vigilant of all the system health. And one of the main system health that you have to check is the disk space. If the disk space is out, it's out 100%, then your system will become unresponsive. And sometimes what happens is you know you want to delete a file, but it's too late because you cannot even log in. The system is not letting you in, so you have to be proactive and make sure your disk space does not get to 100%. So that's one of the real life examples that everybody would faces, and I'm going to put a script for it, and then we will automate that, and we'll make sure this is not going to happen in anybody's professional career where they would have to face the issue of disk space. So what we'll do is, in this lesson, is we'll first find disk space using the df command. Of course, there are different commands as well, but the most important command and mostly used command is df. You could also use du to find a disk usage based on a file system as well, but df will give you the file system usage on the partition level, and this is what we are looking for. So we'll run the command. Then what we'll do is we will run different scripts that will filter, output, and compare. So it will run the same script, df command, and then we'll put the filters around it, like grep this, awk that column, and then do the comparison. If this column is greater than 90, then let me know, or if it's less than that, then what do you want to do? If then statement. So there are different ways we're going to do that comparison. This is a longer way to do it. It's always been done like that, but now and at the end I will also show a simple script which will actually go in, and it's like a one-liner script, and it will actually tell you the disk space, and that I'll show you at the end. So let's go into the Linux server that we have. Okay, I have this terminal open, and for disk space, you would have to be root. No, I don't think so. For df-h, yes, you could run that command without being root. So that's why you don't have to be root. Just make sure you are in PS directory, which is my home iAbsolve PS directory. That's where I'm keeping all my script. Okay, so the first thing first, what do you want to do? You want to run the command df-h. And the status that you will get is not from the size, not from used, not from available, but from the usage column. If the usage column is reaching above 90 or 95 in some companies, then it's a problem, and you should be aware of that. And if you do not have some kind of monitoring application deployed in your systems, then you would have to do it manually. And sometimes the systems do not behave normal when you install a monitoring agent on it. Then you have no luck but to create an automation tool yourself, like we are going to do here in this lesson. So we will focus on this column, which is 1, 2, 3, 4, fifth column, and we will compare with our threshold. If threshold goes above 90, let me know, complain. If it stays below 90, then perfect, just keep running it and keep doing your job. Okay, so for that, we know that now, as you can see, the first thing we have to do is df-h, and now we have to get rid of these temp fs partition. These are swap space, and you don't want to get any information on that, so you will do egrep -v tmpfs or dev tmpfs. So I don't want to filter out everything that has tempfs or dev tempfs. Now hit enter, and now you will see that you have file system right here, only the one that you're looking for. Now you could also get rid of the first line if you want to. So let's see if I could get rid of the first line, and the first line is file system size used, all that stuff, and tail -n+2. And it has got rid of the first line. Perfect. Now we have 4 partitions: root, SDB1, SDA1, and VG Oracle. Now you probably have a different file system in your environment, and I'm sure you do, not just probably, because your system is probably built, of course, your system is actually built on a different way or a different partition. So you will see something else on the file system being mounted and the actual file system. But I'm sure you are following me what I'm talking about, how we could get rid of the stuff that we do not want. Okay, so that part is done. Now, what do we want to do? We want to get only the 5th column, right? Because 5th column is the one right here. This is the column that we want to do a comparison on. So we'll do awk print 5th column. Oh yeah, I accidentally put %. It should be $sign. Okay. This is not the right column I'm looking for. Oh, I made a mistake. I put 4th column. I want to replace it with 5th. Okay. Now we know 72, 16, and 2. Okay, we are here up to here. Perfect. Now, if we are comparing these integers with our predefined number, let's say we wanted to get an alert if the value is above, let's say 60, and then we know the value is 70, but it has this percentage sign. So when we do the comparison with the if-else statements, this is going to complain and script won't run. So we have to get rid of this % sign as well. So to get rid of that is I will use the cut command, cut -d and unwanted character, which is percentage code, single quote, space -f1. And you will see, okay, let me make this bigger so you will see the entire command. Hit up arrow key. So the command filter out the first column, first row, filter out the 5th column, and cut and get rid of % sign. And once you get rid of a % sign, give me the first field. And first field is number 1 field, which was right here. And then if I put F2, it would give me just %. So we want F1. So we got up to this point. Perfect. So this is what exactly we wanted to get out from df command so we could do our comparison. Now what you would have to do is now you create a script and do a for loop. So let's say you did this and you copy it and you create a script called check disk, and you define the shell, author, date, description. This script will check for disk space. Modified. Okay, now I could put it down right here. Okay, so this is going to give us all the values in the fifth column of the df command, and it will filter out the percent sign. So if I just run this script like that, check disk, vi check disk. Oh, I put it a variable, that's why I didn't run. So let's take out the variable and just stick in the command by itself and then do check disk. You'll see it is giving me the entire column and with 4 rows. Okay, good. So now we know we are getting the result that we want. Now we have to give this entire command and assign a variable, and I'll give the variable name A. And if it's a command, you put a tick, which is right above, which is right below the escape, and you close it, the entire command, with tick as well. This will show that this is a command, not just a value. So now what we wanted to do? Now we have to use the for loop. We could do this first, like if $A is greater than, let's say, 50, then echo check disk space. Else we don't want to do anything else, just phi, and done. But it will not run. Let's try run it. See, it didn't run. Okay, the reason it didn't run, it says too many arguments. You see, it says right here, too many arguments. Why too many arguments? Because when we run that line, this command, it gives us more than one value. Remember, it gave us 4 rows with 4 different values. So if it has given us only one value, let's say if it has given us just first row, and number is 40, then it will work. But since it has 4 rows, then we have to use for loop for that. So for loop can go from first row, second row, third row, fourth row, and then done once it's finished looking at every row. So that's why just for single if is not going to work, we have to put for loop around it. So how we do it? We do for, and I'll put I as in variable in $A. What is $A? $A is this variable. So what I'm saying is whatever the result is coming from this line, put it into another variable, and that variable is I. Okay, I put it in. It's in the variable, it's in the container. Now what do you want to do? Now I want to do is if that container is $I, now not $A. If that container has a value anything above 90%, which is 90, then echo check disk space, phi, and then done. Because we are doing for loop. Sorry, I missed one thing. For also has do. For I in $A, then do what, right? So I missed that do. If, which is finishing up with phi, and do is finishing up with done. Perfect. Now when I run this script, it is not going to give me anything. Why? Because I have defined the value as if the output of this command, any of the output, is above the number 90, then tell me the check disk space. But none of the output, let's check, none of them has 90. My file system is the highest one is 70. So I have to pick a value that is below 70, so this way we could verify our script. So instead of 90, I will pick 50. So now this should work. Now it should give me this check disk space. So I'll do clear the screen, check disk. There you go. See, it says check disk space because it did find one of the values that is above 50 and it complained. Now we have to be a little more, we need a little more information from it. Let's say not just check disk space, but tell me which partition, right? So if I have this 4 partitions that I was looking for, let me cat my script and let me run this command again. And you'll see I have this 4 partition. Let me take out this one as well. I have these 4 partition and it gives me, if I run my command, which is check disk, it gives me check disk space because it actually met the value I have defined, but it only gives me information that check disk space, but not which disk space. So in order for me to be more informational about this error, I have to give it the map drive as well. So how can I also give the map drive information? What I could do is I could come in here and I'll say echo disk space, check disk space, and I'll put $I, like which disk space. If this is $I is only going to give me the number. Okay, nice. I have the number. Let's check the number. Which number is that? Clear the screen, check disk space 70. Okay, we are here. So now we know that there is a disk space, a disk partition with up to 70%. Now we also need more information that which disk partition. All right, no problem. We'll keep working on that. So for that, what we have to do is we have to grep that $I from the df command. Okay. So if I put in right here, I could do tick because again, this is a command, df minus h grep for $I and tick close. So now echo will echo out this, and if I don't put in tick right here, then it will read out the entire echo with df minus grep. Let me show you, you know what, so this way you know what I'm talking about. So let's say if I take out tick and run the check disk, you see it is giving me df minus h as if it's actually it wanted to output to the screen. So that is why I have to put a tick around it. And close it with tick. Now I should have the exact information that I'm looking for. See, check disk space 70, which is on file system CentOS -root and space and an entire thing, and is mounted on /. So it's basically grepping it, that number. And of course, that number exists. That's why I'm going to get that back. So anyway, this is the for loop that you would have to use to check the disk space. Another way we have the same script written a different way. I actually got this script, the second script from online. I was looking online, and this was the script that I found out initially. So I have already created the script, and what I did is I copied the create disk file, check disk, and I copied it to 1, and I have 2 now. So now I'm going to go to the second one, which is check disk 1. Okay, in this one you'll see it is slightly written differently. What it is doing is it's running command df minus h, uppercase h, which is pretty much the same as the lowercase h. If you wanted to see what man df has with minus h, uppercase h actually, it says likewise, but use powers of 1000, not 1024. So it's pretty much gives the same thing. So I'm going to leave it as is. With grep e, it is trying to filter out anything that starts with file system, tempfs, cd-rom, or tempfs is doing the same thing. Then awk print $5 and $1, which is the 5th column and 1st column. So when I run this command, just that, and my other terminal, I have to put a df minus h before that. Df minus uppercase h, and now I run the command, and I'll get that output. So pretty much the same way I did. Now, the difference is that they, instead of using the for loop, they're using the while loop. So in while loop, what they're doing is they while read the output, and the output is this entire command. So put the output of this entire command into the variable called output, and then do, and they're defining another variable, and the variable they're doing is echo the output and awking it and print $1, which is the file system, cutting it and getting rid of %sign if there's any to it, and no, sorry, but the output, they're trying to get rid of the fifth column %sign and putting it F1. Second variable they're defining is echo the same output, which is the output right here. This is a variable, and awk and print $2. I have a little space here. I'll just get rid of that space. Okay, then if the use percentage, which is this variable, is greater than 90, then echo running out of this space partition, which is this partition variable, on host name, which is the host name of this machine, as on date, which is today's date, and fee, and done. So this is written a little differently, and let's try to run the script. This one. It didn't give me anything because the set value is 90. So I'm going to change it to 50. And now I run it. And you'll see it is giving me this entire line running out of this space. On this file system, 70% on my first Linux, this is the host name as on September, Saturday, and the date and time and everything, because it has that date in it too. You could use that one if you want to. It's a little bit complicated, but if you do understand this script, perfect, be my guest, use that one. It works perfectly as well. And it is not using for loop as I was using it in my previous script. So now you have two scripts. So the third script that I wanted to show you guys, which is very easy and simple and straightforward, I'm going to copy the check disk to check disk 3. VI check disk 3, and let's get rid of everything. And what this was going to do is df minus h awk single quote 0 plus $5 greater than or equal to 10. This is the threshold that I wanted to go with, and print the threshold. Okay, so if I just run this command just like that, oops, single quote, it is giving me everything that is above 10% on the fifth column. So what I'm saying is the fifth column has to be equal or greater than 10. So these are the equal and greater than 10. So if I modify that to, let's say, 50, then it will give me only the one of the rows, which is the slash mounted. So to put it in a script, so what we'll do is we'll do echo. This is a simple line. Another echo. Following is the disk space status. Echo one more line, and then it will do is it will run that same command right here. Now I'll get rid of this, and I will filter out what I don't want, and I will just print $5 and $6. And that's pretty much it. This is just that simple script. What it's doing is it's running a df-h command, awking it the fifth column, and saying this is just the way it is, 0 plus $5. And if the $5 fifth column is greater than or equal to 10, then print that and awk fifth and sixth column. So let's run the check disk 3, and following is a disk space status 70 and 16. Perfect. Now since I have the threshold set to 10. I will modify that to 90 or whatever. So since the lowest one I have 70, so I'll go with 60. So anything above 60, I should get a message. And it says the following is the disk space status 70%, and this is how I'm going to get the result when I run this command. I could change the value to whichever the value I want. So this, the last script that I have written, this is the one I've been using lately because it's very much simpler. Let me clear the screen. Very much simpler, and it's one-liner. You don't have to use the for loop. You don't have to use the while loop. You could just simply use this command to check the disk space status. So now you learn how to check the disk space with for loop, how to check the disk space with while loop, and how to check the disk space simply by one line. 3 different options. Try all 3 scripts and see if you are actually having any issues, and I'm sure all 3 of them should work for you. Okay, moving on to the next lesson. Now we have status on the total number of files. So basically, we're going to have a script that will send alert if files are less than 50 or whatever the defined number of files. So this type of scripts are often used in corporate environment when an application generates a few number of files, and for the developers or even system administrators, they have to make sure those files are there before they actually go and run another workflow. So if the number of files are 20, go ahead, run the workflow. If it's 19, the workflow is not complete, it's waiting pending, and then once it's complete, notified. So these type of workflow or entire process depend from one to another. So this is what we will cover. What we will run here is simply we will run ls command with -l option because it will give the listing with different options if you want to, like lsltr or just t or any other option that will give you the entire listing of your directory. Then we will create a script to perform that comparison, and of course at the end schedule and notify if you have to schedule it through the cron job and notify through the email. So that's the 2 main way to schedule the job and to notify users through the email. So let's go into our main lab Linux machine. I have already logged in as myself. I am in home directory. Let's go to PS directory, and I will create the script real quick. So let's call this script, you know what, before we call the script, so let's create files so that we could run that script against those files. So to create the file, I will create, instead of 50, I'll create 20. So touch file, and of course I want to have 1 through 20, and let's call it .text. So I want to create files from 1 to 20 that ends with .text. So hit enter, and you will see I have files from file 1 all the way through to 20 and as .text file. So my script, what it will do is whenever it runs, it will verify if we have total number 20 files in my home directory, and if it does, then it will notify the user, hey, I got the 20 files, go ahead and start your workflow. So to verify it, you do ls-l command and do file and asterisk, and you will get all the 20 files. But now we have to do wc-l to check the count. Count is 20. Now perfect. Now let me put that script, a little command, this one in our script. It's a small tiny script, and we will run that script. So count files. This is the name I want to give my script. And we are defining all our parameters up there, all our settings, the author, the date, the description. This is one of the most important one. This script will verify total number of files. Perfect. Modified. By the way, you could also add any of the comments you want that will actually make you understand what the script is for. You could also give comments on every line whenever you write something. So let's say if you are defining a variable, I'm going to define that variable here, a equal tick ls-l file asterisk wc-l tick close. So I have defined variable A. So I could put a comment here if you want to. Comment defining variable A. That's it. If you want to actually do, if you want to actually add comments on every line. So our variable is defined. So what we have to do is if $A is equal to 20. Now we're using EQ because we're using integer. And you remember when we use equal sign, which is equal, when we actually using the letter. So if you are putting Y or no, then we put equal. All right, so if A is equal 20, then echo, yes, there are $A files, meaning 20 files. Else, echo, files are less than 20, because now we're defining it actually number what we're looking for, so we cannot put our variable here. Phi. That's pretty much, it's that simple. Let's put if here, so it'll come in line. So let's give it executable permission. Count files, and let's run it. It says, yes, there are 20 files. That is perfect. Now what do we have to do? I could show you real quick. If first of all, before I show you something else, let's change it. Let's delete one file. So one remove file 20 text. Now when I run it, it will tell me count files. Files are less than 20. Okay, so now we know the script works. Here's another quick thing I wanted to show you. You see right here, we always define variable here, right? And variable is A equal whatever the variable is. What you could also do here is, instead of just defining a variable, you could also actually put this entire command here. So you could do like tick, if this command, like whatever comes out, it is equal to 20, then do that, and then you don't have to define the variable. You just comment that out. Let's see if it runs. Yes, files are less than 20. If I create back the files, touch, I removed file 20.txt, and now when I run it, yes, there are files. Yes, there are files. Which one is? Oh, remember we have that variable in there. That's why I couldn't. Right here. Yes, there are, and it doesn't understand what that variable is because we are commented out the variable. So we could say, yes, there are 20 files if you want. Anyway, my point here is to explain to you that you could define variable, which is the best way and cleanest way to put your script together, so you will know where to use your variable. If you do not want to use variable, you could also put that entire command inside of if else statement. So that's how this works, and once that is completed, you can also send a message, a return status to another workflow. Hey, the command ran successfully. Create system inventory, a step-by-step user input. In this lesson, we are actually going to create a script that will ask from a user for its input for any type of form or record that we will have to create in Linux. Now, if you are running, let's say your Apache server, your web server, then you probably would have to give some kind of form to the user, so they would come in and type in, let's say, even a DNS record or even a system inventory. In our case, you'll put in a host name, you put in an IP address, you put in a description, or any other information that's a kind of form you're given, right? And then you click on save, and that record is saved. That's how we usually see it online. Whenever we go online and whenever we type in information, that is saved somewhere. Well, most likely in bigger companies, it is saved in a database. But now, since we are creating our own little database, own little inventory, we will keep track of all the systems that we build. So there has to be a way. So you could have that script together, and we could expose that script on our web server so user can use it as a form and put that information in. So anything that you want to do, that could be done later. But for this lesson, we will learn that the first script that we'll create is that script that will add a record. So it will ask you, do you want to add a record? And so please provide host name. Second question will ask you, please provide IP address of the system. The third one is, please provide the description of the system. Once all that information is provided, that information is saved into a file. Since it's a Linux machine, it will be saved in a regular text file. If you are using Windows, most of people create this Excel sheet to keep track of all their equipment, do all type of asset management. Second type of script we'll cover is about deleting a record. So this script will ask pretty much the same things as the first script, but in this case, it will ask to delete the record. And the third script that we will cover, it's about combining both of the above scripts of to add a record and to delete a record. So we will use a case statement in which it will ask, hi user, what do you want to do? Do you want to add a record, or do you want to delete a record? User picks A to add a record, or B to delete a record, depending on their choices. Then it will take them to either the first script or the second script. So this is what we are actually going to learn. So let me get into real quickly my Linux machine. Okay, I have it open. I am logged in as myself, and I am in my home directory and PS directory, which is the professional scripts directory that I created. Now, the first thing before I start writing a script, I need to create an empty file where all the input will be stored once actually provided by the user. So I'm going to create touch database. I'm going to call it database. Let's verify it's there. Yep, the last one is the database. Okay, let's clear the screen. Now, the first thing I want to do is to add a record. So let's create a new script called add record. And you know what we have to do here. We have to define the bash, the comments, and the comment could be the author, the date, description, one of my favorite. This script will add system inventory to database file. Modified. Let's leave the same date. Okay. All our formalities are done. Standard is followed. Now let's get into asking question from the user. What do we want to ask the first question? And when you ask the first question, you have to throw that question on the screen. And to display that question on the screen, you have to use which command? Echo. Yes. Echo. Please enter host name, because we are going to create an inventory of our system. Whenever we build a new system, you could add your system inventory into this database file. Please enter your host name, question mark, and then what do we do with that? Once we throw that question on the screen to the user will enter the host name. Once the host name is entered on the screen, then we want to capture that and put that into a variable, right? And to put that answer into a variable, we have to use the command read. Read. You could use any variable name that you like, but I'll pick host name. Just host, because host name itself is a command, and I don't want to confuse you with the actual command. So I'm just going to leave read host. Echo. The second echo I'm adding is because to put in an empty line on the screen, so it will look neat. All right. Now what do we want it to do? First thing first, before I add a record into my database file, I want to check the host name the user has entered does not previously exist in the database file. If it does, I am going to error out that. So to error that out, let's do grep minus Q, Q as in for silent, and dollar host is our variable. From where are we grabbing this? We have to define the absolute path and the absolute path file, which is home IFSol PS database. Remember, this is the file we created before we started working on the script. Okay, so this is going to actually grep from this, grep the output of the host from this file. Okay, perfect. Now, next thing is simple if then. If the output, which is, what is that? The return code. Yes, if the output is successful, which is equal 0. So if it does find it, then echo error. Host name, which is the host that you entered, already exists. And simply echo out another line just to make it neater and exit the script. And phi for the if that we opened up. That's pretty much it for hostname. Now we will do the same thing for second question. So first we'll ask the second question, which is echo. Please enter IP address. Read that IP, put in an echo as an empty line, and then we'll do the same thing. Grep minus Q as in silent for $IP, which is the variable. From where? From home IFSol PS and the database file. If the output, which is $, is equal to 0, which is the return status is successful, then error IP, which is the variable, already exists. Then simply echo again. It's a line. Exit here too. If the IP exists, just don't do anything. And then pretty much end the if with phi. Nice. Okay. So now we have asked two questions and we wanted to verify or validate these two answers against our database file if that answer provided by the user already exists or not. Perfect. Now the third question I wanted to ask the user is, let me hit enter key so this way it will be easier to see on the screen. So echo, please enter description. And we want to read the description and put in one more echo. And now just echo out that host, which we have the host that we asked on the first question right here, host with the IP with the description. I'm just going to copy the description so this way I don't make a mistake in the spelling. And to redirect sign to our database file. I could use one, but then every time the script runs, it's going to overwrite it and it would delete all the records that were added previously. So it's going to add, and then I could put at the end. Now, before I do that, I will just put right here, echo. The provided record has been added. Perfect, right? And just put one more echo just for it to look good. Let's save it. Okay, now assign the executable permissions. Let's run it. Add record. Perfect. Please enter host name. I'll put in Red Hat 1. Please enter IP address 192.168.1. I'll start with 2. Please enter the description. This is Red Hat version 6. The provided record has been added. Perfect. Okay, so now when we go and do cat, our database file, you will see that record being added there. You see? Now what we could do is to make it look a little neat and clean and organized. We could just VI our database file, and right here we could put the name, which is the host name, IP, and description. It has no effect on our script. It's just that I am putting it in, so it will be easier to read. Okay, the record is added. Now let me try to run the same script with the same record. So then we'll see it will complain that this record already exists. So let's clear the screen. Add record. Please enter hostname, Red Hat 1. Boom. Error, hostname Red Hat already exists. Perfect. It is doing its job. Please enter hostname, Red Hat 2. It doesn't exist, right? So now let's please enter the IP address, 192.168.1.2. Add record line 23 error, command not found. Okay, we have an issue in the script, guys. So let's look at it while it is actually validating the IP, whether it exists or not. It is complaining that something is not right in our script. And what is not right? The line in line 23, it says error, command not found. Why? Because first of all, error itself is not a command. We should have an echo in front of it. We probably don't have that echo. So let's go look at line 23. Let's VI add record and just put colon 23 will take us straight to that line. Ah, yes. You see, what I did is I put it in if the return status is 0, which is successful, then they should have then here, and then echo. This should be echo. We don't want that then error. See, simple fix. Also make sure whenever you run and you get an error message back, read it, see what it says. Okay, let's try again now. Add record. Please enter hostname, Red Hat 2. Please enter IP address, 192.168.1.2 this time. See, error, IP address already exists. Okay, now we know our check about hostname and IP address works perfect. Let's add a command in my add record, and that command I wanted to do is every time it runs, it should clear the screen first. So this way you don't see anything that you're already working on. It should bring up a new screen. Okay, so let's run it, and you will see what I'm talking about. So when you run add and hit enter, you see it came up with a newer screen, and it actually pushed all the stuff that you had on the screen, pushed it up. So it looks better, it looks professional. Please enter hostname, Red Hat 2. Okay, please enter IP address 192.168.1.3. Please enter description, Red Hat version 7. Perfect, the provided record has been added. This is just the information that we have at the end. Okay, so this is what we wanted to do to create or add a record. Now we need to create another script that will, instead of adding it, it will delete that record. So before we go ahead and try our delete record, let's add another record so we could actually have quite a few records to play with. So please enter hostname, so Red Hat 3, IP address 192.168.1.4, Red Hat test machine. And now if I do cat database, you'll see I should have 3 records. Yes, I do. All right, so now clear the screen, and now I want you to copy, add record to delete record. Now we have copied VI the delete record, and you could just leave everything up and delete everything right here. So we could start a new script and change the description. Of course, this will delete system inventory, the system from inventory database. Okay, perfect. Now what do we want to do? First, always ask the question. We cannot add any record if you don't ask a question. Add, please enter host name or IP address. And now why am I asking either host name or IP address? The reason I'm asking is because either the user enters the IP address or the host name. We should give that option right in front. So the next command would grep for that input and delete that record. It's just that simple. I don't have to ask, please enter the IP address, please enter the host name, and then it will go into either enter it from the host name or grep it from the IP. It's a bit cumbersome. So we'll just put an IP or host name and I'll do the job. Okay. And then what we wanted to do with their output, we wanted to read it. Read host or host IP, whatever that variable name that you want to specify. Give it an echo for the empty line. Now, grep minus q, again quiet, host IP from my database file. Okay, if that returns 0 equal 0, if the exit status is 0, then echo. Now, we have found the IP or the host name provided by the user. And now, before we go ahead and delete it, we want to make sure the IP or the host name provided by the user actually exists in that database file. We're not just going to go into the file and start deleting it what we don't have anything. So we first need to validate if it exists. And to make that validation, we have to grep that provided name from our file. And if I get the result, which is right here, if the result is successful, then you could go ahead and delete it. And to delete a record and update it, you have to use a command, sed. Sed is a very powerful command, one of my favorite commands that could do a lot of things, a lot of wonders in a file modification. So sed minus I, single quote, slash host IP, single quote around the variable, delete, single quote from home ISL, PS, database. Okay, so don't worry, let me explain it to you. What it's doing is it's going into this file and it's trying to find host IP, which is provided by the username right here. And once it finds it, it deletes it. So you see that slash and slash. What I'm saying is whenever you find this this provided variable and slash D, replace it. Replace it with what? With D. And what D is? It's to delete that line. If you wanted to put in, let's say if I put in right here is host IP with old, just like that, and then I will put an S here, then what it will do is actually just replace that name provided with the name old. But we don't want to replace it, we want to delete that record. So instead take out the substitution, which is S, and take out the word old and put D, the actual D, to delete it. So this is what it's doing. And then echo the host IP, which is the variable, has been deleted. Nice. Okay, so now we are good. We found the provided host name or IP, and we checked, we validated it from the database, and we deleted it. What if it does not find from this file? The user says, hey, go ahead and delete Red Hat 5. Hey, I don't have a Red Hat 5. If that return status is not 0, then do what? Then we'll say else. Echo record, which is the host IP, which is a variable, does not exist. Simple as that. And we close our if with fee. That's it. Hopefully you understand. It's very simply written and done. And now I'll go ahead and try to run that. Delete record. Hit enter. Please enter host name or IP address. Now I'm going to do the same thing as I did in my earlier script to clear the screen. So I'm just going to do Control C NVI, the script again, and I'll just put in clear at this top. So again, it will look professional. Let's run it. Delete record. Okay, please enter hostname or IP address. I'm going to put in Red Hat 36 just to check, just to play with it, see if it actually finds it or not. Record Red Hat 36 does not exist. Perfect. This is what I want my script to do, and it is doing its job perfectly. Now let's delete a record, actual record. We remember we have a record, a Red Hat 1. Let's try that. Red Hat 1. Red Hat 1 has been deleted. Nice. But did it actually delete it? How can we verify it? We could actually do cat, our database file, right? It actually goes into this file database and it deletes it from this database, right? So let's verify it. Yes, the Red Hat 1, it's gone. Perfect. Okay, so I have add a record, I have delete a record. Now I am going to create a third script right here, which will combine both of these scripts and ask the option from the user to what option they want to pick. Do they want to add a record or do they want to delete a record? So I will go here is what I will do is I'll copy one of the script add record and I'll rename as inventory management. Nice. Okay, so now inventory management. Let's come down here. Description. This script will ask to add or delete a record from database file. Okay, the rest is gone. Okay. Clear? Yes, I want to clear. Right below clear, just go ahead and delete everything. So we can start from fresh. Okay. First thing first. Echo. Clear line. Another echo. Please select one of the following options. And those options are echo, just a line, echo, comma, sorry, not comma, quote, single quote A, equal, add a record, single quote close. Second, what do we want to give the option for the second one? D, because it's delete a record, right? You could pick B too, but it's better to pick D, delete a record, and echo. Okay, so far what the script is going to ask is please select one of the following options. And the options are A is to delete or add a record, and D is to delete a record. So the user has to either enter A or D. So now at this point, whatever the choices that are made by the user, I will read those choices and I will put it in a variable and we'll call that variable choice. It's just a variable. It's not actual choice, some kind of command. So you could even put read I if you want to. That would be a variable where the answer of the user will go inside of that variable. So I'll pick choice. Now once I read the choice, I will say case. Case is the statement, and I will do $choice in. All my choices, whichever the choice that is picked, put it in a case statement. And once the case statement is being put in, then what to do? So for A, do this. Home, I of Sol, PS, add record. Right? This is the script that will actually add a record. Colon, semicolon, semicolon. This is how the case statement works. D, home, I of Sol, PS, delete record. Semicolon, semicolon. Perfect. Anything else? If user enters anything else beside A or D, then just say echo invalid choice. Bye. And we will end our case statement with ESAC. Why are you picked an empty line here? Nothing, no reason. You could put it here as well, but I just wanted to make my script look good. Okay, so hopefully you understand what I just did here. So basically from here till here is just what it is throwing on the screen. And then whatever the option is picked by the user, if will lock in into this variable choice. And then it's going to read those choices in, and it's going to run based on the choice. If the choice is A, right here, if the choice is A, run this command. If the choice is D, run this command. If the choice is anything but A and D, then says, hey, invalid choice, bye, and then close the statement. Just that simple. Save our script. Run our script. Inventory management. Enter. Please select one of the following options. A, to add a record. D, to delete a record. Let's try adding a record first. A. Hit enter. Okay, see, it took us to another script, and that script is to add a record. Now we'll add a record. Red Hat 5. IP address 192.168.1.6. Description, Red Hat second, whatever that is. The provided record has been added. Awesome. Now let's do the same thing for delete, inventory management. Please select one of the following options. Now this time select D. Hit enter. It took us to the second script. Please enter hostname or IP address. Now I'm going to pick 192.168.1.6. The address I just entered. Hit enter. That IP address has been deleted. Awesome, awesome, awesome. Now, the last choice. If I just accidentally hit B, and B is not one of the choices, right, guys? Enter. Invalid choice by. Perfect. See how easy it becomes to put that in a real structural form way to add inventory. Now, adding an inventory is just one of the examples that I picked. I have worked many times in the past where I would have to create some kind of a file or keep track of some inventory regardless of hostname or IP or anything else. So you could actually use this script and provide that to your users so they could add it instead of VIing the file and adding the record, because most of the people are not comfortable with VI the file. So try that and try it with different options. You could also add 4 scripts or 5 different scripts and put all those scripts together into one main script. Hello everyone. In this lecture we are going to cover how we could have those predefined values whenever we write a script. We have those predefined values which are like which script or which bash or shell environment we're going to run, and then we put down the date, the author, with the date it was modified, the description of the script, the hashtags, and all that information, right? So we wanted to automate all those predefined information. And that's, I'll tell you this, I should definitely give a credit to one of my students who actually reached out to me and who actually offered and gave me one of this script, which I modified a little bit later, and who told me that we could have all the information in an automated way. So it will be a script to create a script. So what are the information do we have that is always or always have to be there? One is we have to define the shell environment, right? So it will be hashtag bang/bin/bash. Then what we do is we kind of like make a nice format. We put a hashtag or we put a dash or equal sign, whatever the way you picking. I usually pick the hashtag to make a line. Then what I do is I put the author, as which is myself, because every script that I've been teaching you, I'm telling you to make sure you do put this information in there, so it will remember this is the right way to do the scripting language. So you need to write the name of the person, or if it's you who's doing the script, you need to write your name. Then we have to define the date. You could put the entire date, or you could put a short date. Then the description, what exactly this script will do. For example, it will delete all files, or it will run and it will execute a such and such script in a remote server. It will ping one server and get the information. Anyway, you got what I'm trying to convey. So description, then modification. When was the last time this specific script was modified? So maybe you wrote that script in 2011, and then you came back in 2020 to modify it. Whatever that you modified, put the information in there and a little description of that modification. And then you actually close that off with the same line if you're using hashtag or if you're using equal sign, plus sign, whatever that you're using. Then after that, you start writing your script, right? After you're done writing your script, then there's one last thing you have to do. You have to make that script executable. So what you do is you do change mod AWX, then the script name. By the way, the script name, it has a space in the middle. I meant to say it's one word. So you do script name and you assign executable permission to the script. Then you go in and execute and run that script. So what if we automate this entire process and simply start writing the script without going through typing all that author, date, description, modification information? Wouldn't that save you a lot of time, right? Because we are actually dealing with the training in which we have to automate our daily task, and what best it could be to automate the scripting of itself. So let me tell you how it is done and then how the script is written. So I'm going to log into my Linux machine. I'm logged in through my PuTTY session, and my Linux VM is right here. It is my first Linux VM. When I do who am I'm logged in as myself. Which directory I'm in /home ifsol. Which host name I'm in my first Linux VM host. Perfect. We're verified we are on the right machine. Now in this machine we have a directory called PS, which is professional script that I created. Now in this directory, when we go in cdps ls-ltr, you'll see there is one script in there which is called GoScript. This is the script I have written, and also again, as I said, one of my students provided me some scripting, and I had to modify a little bit as well. That will let me automate this entire process. So let me first, before I run the script, let me cat the script. So this way we all understand what is it doing. All right, the catting is very, everything is coming up in white. So let me VI the GoScript. Yes, now you'll see. So what is it doing is, first thing it is actually, since this is the script itself, we have to define the shell. So we have defined it. Next thing is we have to enter the name of the script. So every time we do a VI, we have to specify the name of the script followed by the name. So it will ask you what is the name of the script, and it will read that. Then it'll ask you what is your full name. It will put that in the container F name. Then it will ask you what's the description of the script. Then it will, whatever the description that you type it will put it in a container called description. Then the next step, it is going to add this line #bang/bin/bash excuse me, and it will output that to the file home ifsol ps and the script. And what is that script? It's the same script that you define in the first line. So it's going to add that into as the first line in that script. Then echo. Then the next one, it is going to add this entire line right here into that script. Then it is going to add this author, and in author, it's a variable $f name is what's your full name is the name that comes here that you actually have right here that you added in this line. Next one is date. It is picking up the date of the exact same time you're running the script. Description. It will add this line as a description, and then take this is as a variable, and the variable is right here on the third line. This is a container which has information, and it will add that into the same script file. And the last one is modified. When was the time it modified? And the closing line right here says echo this closing line to that file. Now, as you notice right here, it says echo, and then at the last part is change mod. So now since it has already done the work for us, predefined these values. Now once that is done, once we're done writing the script, it is actually going to change mod of that file. So see the script that we have defined right on the top line right here, what it's doing is its first step is it's changing its permission and assigning its execution permission. Beautiful. And the last part is now it's opening up that script for us to start typing it in. Isn't that beautiful? It's saving you so much time, so you don't have to go in whenever you create a new script. You don't have to go in and type in the same the shell environment, which shell you're going to use, what date, what author, and a whole bunch of information, right? Everything is in there. So beautiful. By the way, this code, I am going to copy this code into a file, and I'm going to convert that file into PDF, and I will save that PDF, attach that PDF to the handouts of this section. So you could download it and you could copy paste as well. All right, so let's go ahead and save it. All right, so it is saved. So this is the script we know, which does go script. So I'm going to run this script. Go script. It is asking me enter the name of the script. Now remember, this is the name of the script of the new script that you are trying to write. So the new script I want to do echo hello world. That's it. So it will output hello world, HW, just like that. Who is the author? So what is your full name? My name is Imran Afzal. What's the description of the script? This script will output hello world. Okay? There you go. Beautiful. So if you pay close attention, if you come closer to the screen, sorry, it's coming up in blue. So anyway, so if you notice, it has automatically the first lines, second line, third, fourth, fifth, sixth, seventh. All these 7 lines is already there for you. All you have to do is now start creating your script, which is echo hello world. This is my script. And who wrote it? The author information is there. I already specified. The date is going to pick that date from the date command. The description is the description that I specified. The modification is the date that I will modify. But since it's the first time I'm writing it, it's going to take the same date. And now what exactly the script is doing, this is where you write your code. And I've already done echo hello world. Perfect. Let's go ahead and save it. Now, as soon as you save it, I want you to do ls-ltr. You're going to see output HW hello world. See, it already has executable permission. Now go ahead and run this. Output hello world, and it is outputting what you wanted it to output, hello world. Now if you do cat hello world, which is the script itself, you're going to notice these are the predefined values. Remember I was telling you about? You don't have to go into every script again and again to put that information in there. All you have to do, wherever your directory is, wherever you're going to create your scripts, new scripts every day, or whenever you need to create, make sure you have this script is there. Run this script before you are creating any new script. This script will actually help you or guide you through creating a new script. Isn't that cool? All right. Hopefully you like it. If you have any questions, please do message me, and I will definitely help you out wherever you need my help. Thank you. Getting online help. Now, this is the most powerful tool that you have that you could utilize while you are writing a script or you need help writing a script. Well, let me tell you this. Not everybody is perfect with their expertise. The people always learn, and you're not going to find anybody in the world who will say, hey, I got it all. I know maths. I know everything about maths. I know biology. I know everything about biology. So what I'm trying to say is everybody, even if you become expert, you will still learn newer things. So people who are very proficient and expert in writing scripts, they still need help. They sometimes get help online. So they actually go help other people and also get help online. So if you're writing a script today, so let's take an example. Let's say if you want to write a script today and you need some kind of syntax in your script and something is not working for you, don't waste time. Go online and ask questions. It's okay. We don't know everything inside on our head. Sometimes we do forget. So that's what this lesson is about, is getting your online help. You should use all online resources. What I mean is, if you're writing a script and you need help, go online and use online resources like Google, Yahoo, Bing, Search, or whatever the search engine of your choice. People actually even start writing questions nowadays with websites like Facebook or Quora, or there are so many other websites. You actually go and paste your questions, and you know what happened? Within few hours, your questions is answered. Now, how people are answering your questions when they don't have interest in spending time for you? Well, first thing is most of the people are nice enough to help other people out. That's one of the reasons they actually help out. Plus, if you help someone, you are not actually making a difference or actually doing a favor to them. You're actually improving your own skills. So that's why go online, try out all the resources that are out there. Second, when you search online, try to make a precise search, meaning don't just have a vague search like Linux shell scripting. Well, you're going to get thousands of search results. But if you are looking for Linux if-else statement, you will get exactly if-else statement. But if you're looking for a specific error that you get from if-else statement, you will get that to specific. So be precise. Then next one is second opinion. What I mean is if you find a search, an article, on a website that someone has offered that you should do the script this way, then just don't be done with it and it's like, hey, I found my search, I'm just copy and pasting, even you don't understand. No, go ahead and look for another search. Maybe you'll find a better search, an easier one that will make you understand what this is about and how the scripting works. Then ask questions. What I mean by ask question is if you are trying to look for something and that is not already answered by the community, then you could post your question online. If you're writing a script to actually delete certain servers or to wipe out or do patch management on your system, and you want to delete those patches that are no longer used by users, and you need help, go put that question online. And I tell you this, people will answer. People will reply back to your question with the right script. So this way you will learn as well. Then at the end, create your documentation. When you write, whenever you get something from someone, write it down on the documentation. That's one of the things I always do. I write it down because a year, 2 years, 5 years from now, I will forget. So I write down on the documentation. And once you become yourself an expert, a proficient, please go and help others. Don't forget that you were helped once and people help you. So now when you become good at something, go and help out others. Now it's your turn to return the favor, right? Okay, so this is all about how you could get online help. Now let me go and open up my browser and I'll show you exactly what kind of help that you could get if you are trying to run or write a script. So let's go into my browser. I have opened up my browser. I like Google, so I pick Google again. Don't go by my preference. You could pick any search engine that you want. So if you wanted to do, let's say, exit status, right? You want to learn more about exit status, how exit status works. Then you could do Linux, first of all. You always start with Linux because that's the operating system. Linux, exit status, and bash because you're doing bash script. And you're going to find tons of articles, tons of information about Linux. See how do you exit in a command line, understanding exit codes, and how to use them in bash script. So before you could come in and ask me a question, not that I'm not going to answer, I would love to, but I would encourage you to go find the answer online yourself. This will help you in your real life career, wherever you're working. So you see you have a lot of articles here. People have put in articles about understanding exit codes, how they work, spend some time reading it. And you see right here, they have given also examples, cannot touch, rest test, permission denied, and the echo, and the exit status is 0, file ran, all the different commands, all the testing for codes. Look for it. See right here, if $? Equals 0, then echo successfully created file, else could not create a file. So this is right here, they use this exit code right here. So it's about exit code. And let's say if one of the script that we written in our course was check a process and kill it. So let's say if I wanted to actually do that exact same thing, check a process in Linux and kill it. Simple as that. Check a process in Linux and kill it. Find and kill process. You see? See how easy it is? A guide to kill, pkill, and kill all commands to terminate a process. And here you will have this website, TechMint, that explains you how you could find the process, different commands to find the process, and what are the commands to kill the process. If you wanted to do automate, you could actually go and put your search precisely, check a process in Linux and kill it. and I'll put it a script to check. And you'll find shell script to capture process ID and kill if it exists. See, you have to be specific what you're typing. So click on it and you'll find, see, right here, people have written the script already for you. So you don't have to actually spend time and troubleshoot your scripting code if it doesn't work. You could try these out. And basically, I would encourage you to try every lesson that we covered in our class. Try it. See if people have a script written in a different way. See, there people have answered. People have questioned that I probably ran this. I tried this code and it is not working. Well, you could also look for what is wrong with this code. And then you'll see answers right here. It says, this works good for me. Perfect. And then you try this. This will make you real good in scripting. Basically, in anything that you want to do in life, you'll get answers, and then eventually you'll answer people once you gain knowledge on that. Okay, going back. So let's say one of the script that we wrote was list all users who are logged in. So I'll do script to list all logged in users in Linux. Make sure because we need a script to list all logged in users in Linux. If you don't put Linux, then it will probably give you the information in Windows as well, because remember, in Windows you also write script, and those scripts are bash scripting. Sorry, not bash, PowerShell scripting. So every operating system has scripting capability, so make sure you type Linux. So anyway, Unix, Linux, list current logged in user. Let's see. Bash, list logged in users, name, terminal. 4 ways to identify who logged in your Linux. So many things that you will find. Okay, so now let's say you wanted to get more examples of for loop scripts. You could do for loop script examples. Since for loop mostly is in shell scripting, but I would say put in Linux. For loop script example, Linux. Bash for loop example. See, if you click on it, you're going to find so many examples right here. These people have went over. You could try different examples. So many of them. See what people has to say. What are the issues they had. Linux bash shell script for bash for loop. See how to loop through a list for number 1, 2, 3, do, echo, number, do, and exit. So basically what I'm trying to say is I'm not going to go into more detail about searching. I think you understand now what exactly I'm talking about. So I'm saying is go ahead and use your resources. Don't limit yourself to a book or to even my course or to a person that you rely on. This world is open for the whole world once this internet was introduced. So you have a whole world on the palm of your hands or on the lap, which is your laptop. So go ahead and open up your search engines and type it anything you want, and you'll find tons of resources out there. So that's why my focus is, even if you are in Windows or in Linux or in any kind of capacity, utilize the search engines, see how you could use the search engines, and this way you don't have to rely on anybody else. So try it out, different searches, and I'm sure you will find the answers that you're looking for. And once again, good luck.